For the first part of this tutorial, we're going to look at acquiring the Epic Games launcher to download the actual Unreal Engine. We'll be covering the various areas of the launcher, how they work, and how we can use them to develop your own Unreal Engine games. So let's begin by going to unrealengine.com in your web browser. Once you're here, I want you to go to this Get Unreal button in the top right hand corner. Click it, and then register for an Epic Games account. Now, if you've already registered for one, you can just click the sign in button here. Either way, you'll end up in the same place. From here, all you need to do is select the platform that you want to develop on, Windows or Mac. In my situation, it's going to be Windows, so I'm going to click this button. Once you've downloaded the launcher and followed the prompts to install it, you just need to log in with your Epic Games account. So enter your details again. Immediately I'm greeted by this community tab, but this isn't where I want to be. Don't worry, we'll come back to this in just a minute. First off, I want to go to the library section. And from the library section, I'm going to click Add Versions. You should see the latest version of Unreal Engine now appearing here. I'm going to click Install, and it's going to give me a new prompt. So this new prompt lets me select all of the installation options for this version of Unreal. Do I want starter content? Do I want templates and feature packs? Unreal Engine's actual source code, art tools? As well as this, it also includes things for us to download that allow us to deploy to various new platforms, such as iOS, Android, HTML5, or Linux. Now, I'm going to keep the defaults checked here, just in case. I'm also going to enable the art tools, because these are really good to have. For the most part, art tools refers to the tools that you would use within 3ds Max or Maya to work with Unreal. So with those checked, I'm now going to go Install. And you'll see that the download kicks off, and in the top right hand corner here, we can see the download and its progress as we go on. So I'm going to go back to this community tab, and I'm going to show you the Epic Games launcher. Now, a lot of people would cast this aside thinking it's just a news tab, but realistically it actually includes links to your answer hub, forums, wiki, roadmap, and blog, and these are very, very useful for developers. So let's take a look at these. The Answer Hub is an area for you to just find solutions to issues that you may be facing. This is where you can report bugs or issues that you're having and see if anyone has a good idea on how to actually solve them. The forums are for discussion with the community, so these can be very, very useful. You might want to scout out a team here. You might want to float an idea of something that you're looking to develop, see what people think. As well as that, you can talk about general features and the way the engine's going. Plus, if we scroll down to the bottom here, you can see that we actually have forums for various different areas of the world that you can go through. This is very, very useful if you're trying to form something local. So the Epic Wiki is a very, very useful area for you to get actual in-depth information on specific features. All you have to do is go to it, do a search for the feature that you want, and you'll find a wealth of information at your fingertips. And this is really, really useful if you want to try and get as much of an idea about a feature as you can. Next up, we have the roadmap. Now, the roadmap is very useful. A lot of people don't know that this actually exists, but it's very, very useful because it lists all of the things that Epic are currently working on, or at least considering working on. This means that you're not kind of in the dark about features that'll be in the engine in 6 months' time. You can actually vote on the things that you would really like to see. So if I scroll through here, one of the things that I can see is a lot of features actually coming up in the next version. I can see that this 4.15 feature is done, and that'll be useful for me. One of the great things about this is that I don't have to spend my time developing features for the game that are going to be coming into the engine in no time anyway, and developed by someone else. This allows me to save time and resources and work smarter. Next up we have the blog. The blog's great because it's not only the newsfeed, but it also has highlights for community development as well as developer features that they really want to discuss with the public. This can be a great way to find out all sorts of information that you wouldn't actually know about certain features or certain things that the community have done. Now, if I go past the Community tab and look at the Learn tab, this is really where what I believe the most useful area is. Not only do I have documentation and video tutorials, but if I scroll down, I have entire engine feature samples that are Epic's way of demonstrating how to implement things. These are entire projects that I can download and I can see how they were made. I can go through, I can look at every effect, I can look at every line of code and every shader, and I can see how everything is put together, and I can use this to try and understand how best to create my own projects. Not everyone's a programmer and not everyone's a 3D artist, so the marketplace is fantastic because it lets you go in and just cheaply purchase new features for your game. art or programming, or even audio. So go through here and see what's there. And don't worry, if you're worried about the cost of some of these things, there are plenty of free assets that are available to you as well. So if I load up this, for instance, I can see that there are Infinity Blade assets provided by Epic that are entire environments and character sets, as well as weapon sets, that are all mobile ready and available for you to implement in your own projects for free. We're going to cover this a bit more later. Next up, we have the Library tab. This gives you an overview of every single project that you're currently working on or have installed on your computer, and as well as that, we actually have a listing of every version of the engine you currently see. If this exclamation mark appears, it means that the version that you have here is out of date and that there's an update available for it. The final thing that we're going to look at is Unreal Tournament. I can't stress enough how useful this is. Unreal Tournament is a collaboration between Epic Games and the community to develop a new Unreal Tournament game. So the reason this is really useful is that you can actually load a full game that's in active development and see every feature, every line of code, every art asset, and you can see how they've been implemented, which means when you go to do this for yourself, life is way easier because you can pull everything apart and get a better understanding of everything that's there. Be aware that it's quite a large download and that if you want to get it, you want to get the one from the Create tab and not the Play tab, because the Create tab is the one that gives you the editor access, whereas Play is a cooked down version of the game. So that's it for the time being. Once this download is finished and you've got the latest version of the engine, I want you to go on to the next tutorial. Thanks. Hello everyone. So this time around, we're going to actually be working with Unreal Engine. We're not just going to be clicking at the launcher. And I'm going to have to make sure that you've downloaded your assets for this section. I've pre-created a project that's already got some things in it for us. It's called ArcViz Demo. And I'm going to need you to open that up and double click on the U project file. Okay, and upon doing so, you'll be greeted with this. Now, once you've opened it for the first time, it will now appear inside of your launcher and you can open it any stage after that. But for the very first time you load it, you're going to need to either launch the engine and then select it, or straight up double click on the U project file. Now, once you're in, you'll be greeted with this. And this is your first introduction to Unreal Engine. So to begin with, we're going to cover some of the basics. To move around the viewport, I can use my mouse and I can hold right click and move my mouse. And while doing this, this allows me to look around the viewport. While holding right click, I'm actually also able to use W, A, S, and D, so standard first person controls, to move around like this as well. You can use Q and you can use E while holding right click to also jump up and down. Now, if you don't want to use your keyboard as well, you can use your left click to move around the viewport like this. You'll notice that as I rotate left, it moves left, and as I rotate right, it moves right. And if I hold both at the same time, I'm able to move directly up and directly down, or directly left and directly right. So that's how you can have up, down, strafe left, and strafe right going on. Now within this viewport, we've got a couple of things, but there's really not much there. But that's okay. So to begin with, what we've got is this little icon in the middle. If I click on this, I can see that up top here, this comes to life and selects the icon. And that's because this section in the top right is the world outliner. So anything that is currently in my environment is automatically selected within the world outliner. If I was to click on the light source, I would see that this has now been selected as well. If I click down here, I would be able to select my atmospheric fog. Now, whenever I click on something, you'll see that a couple of other things pop up. First off is this widget. We've got up, right, and forward. And these represent the three axes of movement. We have x-axes, y-axes, and z-axes. So red refers to x-axes, green refers to as y-axes, and blue is the z-axes. Now, when I select any of these things, I'm able to move the object along that axis. If I click there, I can now move it. And of course, if I click here, I'm able to shift it as well. So, some very basic stuff, but if I was to select this button up here, or alternatively hit the space bar, it'll cycle widgets, and I now get a rotation widget. And again, if I was to grab this, I'm able to rotate it. Now, some people might be confused as to why the colors seem different. Before, blue, or Z, was pointing upwards, but it's not anymore. The reason for that is this represents rotation, and rotation is actually spinning around the axes. So the best way to visualize that is if I go back to this, you can see that the blue axis points up, and therefore, when I rotate, I'm spinning around that up arrow. And this is how I can use this to spin in various different ways, and we can put the object in any position that we want to. Now, the final one that we get is scale, and if I click this, I'm able to scale. And this just makes it bigger or smaller, and increases. Now, I'm sure you've noticed as I've been doing this, that my numbers in the right-hand side over here are reflecting the changes that I'm making. If I was to move this up, I can see that my location has changed to 272 on the Z-axis. If I move it down, 122. Now, at any stage, if you move something up and you want it to fall to the ground, you can press the End key, and it will automatically drop to the ground. So the reason I brought these up is because this is the Details panel. The Details panel represents your basic attributes for any item. If I was to click on this light, I can now see that I have the ability to affect just how bright it is in the world. If I was to click on the player start here, you can see that there's not too many things that I can change by default, but I am still able to custom set the Z-axis, for instance, and set its position in the world. I might also want to rotate it and have it facing that way. So I can just punch in those things directly and will automatically be set. Again, you can press End to drop it to the ground. So with that in mind, I'm going to actually go ahead and start making some changes here. I'm going to first off go to this section over here. Now this is the Modes panel. Within the Modes panel, we have access to a variety of different tools. We have Place, Paint, Landscape, Foliage, and Geometry Editing. So for this section, we're primarily going to be working with the geometry tools and the placement tools, and we'll leave the others for later. Now, for this first project, what I'm going to want you to do is click on this button down here that says Geometry. Upon doing so, you'll be greeted by these things here. This allows me to make a box brush, a cone brush, cylinder, stairs, or a sphere. Now what that means is if I was to get this box and left click and drag it into the world, I can see that it's now in the world. Now the reason I want you to know how to do this is that, first off, I can see there are some attributes over here. If I was to punch in 400, it's automatically stretched this box out along that x-axis. At any stage, you can click this little yellow arrow and it will reset it to the default values. Now, there's another way to modify this, and this is, in my opinion, the far more useful way, and that is you can go to Geometry Editing mode. When I click on Geometry Editing mode, you'll see each face is now turned blue, and the reason for that is I'm now able to click on a face and just drag it out. Click and drag. So with that in mind, we're now able to see that we can construct some things. But I'm sure many of you are going, well, so what? You're just resizing a box. Well, that's fine. Let's click here. And this time I'm going to go and click on Extrude. You're going to get a warning the first time this happens that warns you that extrusions only happen in local coordinate systems. And that's fine. Just click Don't Show Me This again. What that warning is essentially telling you is that when you pull out a face, you're pulling them in local space, not in world space, which means forward is relative to the angle that the surface was currently facing. I'll get more on this later. So if I was to hold down Extrude and I was to click here and drag out, you'll notice something different happened. And what happened is that this time, instead of stretching the face to that location, what it did instead was it extended a new set of vertices, which are these corner points, out to that location and added some new faces in. So these can be selected now independently of one another. I'm able to click here and drag upwards. And you can see once again it's extended out. And if I was to click here, again, now, the reason I've brought this up is that I'm going to go back to edit mode, clicking on here, and I'm just going to really quickly select these, and to do that I clicked on one, I held Control and left clicked on the other, And what that did is instead of selecting the faces, it just grabbed those 2 points. The reason that's useful is that if I was to pull this out, you can see that we can now get an angled brush. Now, we can do more than just adding these things. I'm going to drag in a new thing, and to do that, I'm going to go to Place. And this time, for the sake of demonstration, I'm going to go Geometry, and I'm going to drop in a sphere. Now this sphere, I'm going to overlap with our geometry just here. And at the moment, you can see that we have, not the best sphere, but it's a good start. I'm going to increase the tessellation here, just to make something that's a little more rounded. But I'm also going to click here. See where it says additive? I'm going to change that to subtractive. Now if I click off that object, you can now see that what it's done has carved out our geometry. So this initial process of carving out geometry is very, very useful because it allows you to very quickly set something up. Now, I know it's very unlikely that in your game you're going to have a giant sea to carve out, but a good example would be I could easily build a bridge and carve out a tunnel in it. So I want you to go ahead and do that. Now, one quick thing that's going to have happened, when I deleted the box, I can no longer see the sphere. I know it's still there, but I can't see it. Now there are 2 ways to go about handling this situation. I could click here on the sphere brush, which is in my world outliner that I showed you before, or alternatively, I'm actually able to go up to the top here and see where it says lit. I can change that to wireframe. Now you'll notice that next to each of these is an Alt key, Alt 4, 3, 2, 5, and 6. If I was to press Alt 2, it would do the same thing as selecting it here. It's a really quick shortcut for you to move between modes. So I'm going to click wireframe, at which point we can now see the world represented as a wireframe. I can now actually just click on the object directly, and I can hit delete. To go back to it just then, I hit Alt 4. If you don't want to do that, you can always go here and click on lit. Now I'm going to go ahead and I'm going to quickly make myself a bridge or a walkway for someone to go along. Now I want to point out at this point that when I drop this in, it's not exactly cleanly snapping to the grid. When I drop in the box, it's moving not comfortably around this area. I really would like it snapping to these squares. Now the reason it's not doing that is up here. See this section that says Set Position Grid Snap? I'm going to click on that. I'm going to go down and set it to a grid size of 100. Now these units are in Unreal units, but Unreal units are directly proportional to centimeters. So 100 means 100 centimeters. If I click on that and I drag in a box, you can now see that it's perfectly snapped to these grid tiles, and if I was to move it, it would automatically snap to the next tile. Now for this bridge, I'm going to put this here, I'm going to set it up, I'm going to quickly just extend this across. So I'm going to go back to geometry mode. And you can move between these modes with Shift 1 and Shift 5 as a shortcut. So I'm going to click there, I'm going to extend it to 2 blocks beforehand. Oops, I wasn't in extrude mode. So I'm going to click here and go to extrude mode. I'm going to pull out one more time. And now I'm going to put this to here. And on this side, I'm going to pull this out to here. Now I've got this shape going on. What I'm going to do at this point is go back to my geometry tools. And I'm going to add myself a staircase. So I'm going to drag in a linear staircase. And you'll see that it just looks like this. You can set the number of steps, you can set the height of each step, etc., to be whatever you desire. But in this case, I think the defaults are actually probably good. So I've added a staircase there. Now I'm going to add another one over here. And while I could just drag in a staircase again, what I want to actually do instead is hold down the Alt key and drag. So while holding Alt and dragging, I end up over here. And it duplicates the object automatically. Do you see that? I'm now going to hit spacebar, and I'm going to rotate it around 180 degrees on the Z-axis. Spacebar, spacebar, and I'm going to set this up so that it's the same on either side. Now the final thing that I'm going to do here is I'm going to get a cylinder. I'm going to drop that in, I'm going to hit the spacebar, and I'm going to rotate my cylinder this way. Now the reason for that is this cylinder is going to end up being the guts of my bridge. So I'm going to put this here, at which points I'm going to lower it down. Now, if I was to click here and go to subtractive, we would carve out something that looked like this. Now, that works, except that you've got the world's worst bridge. So instead, what I'm going to do here is I'm going to get my cylinder brush. To get that just then, I clicked in the world outliner. Again, if you want to be able to select it, you can hit Alt-2 to go to wireframe mode, and then you can just click on the brush. If things are getting complicated and you don't want to see things in your scene, you can always click on them and hit H to hide them. So I'm going to click on the floor and hit H to hide it. Now, if you want them back, you can hit Control H and they'll come back into the world. But this is a nice way to quickly just focus on some of the things that you actually care about. So I've got this, and I can see that where it subtracts geometry runs flush with the top here. Now this is one of those instances where what I would actually suggest you do is I'm going to go back to my grid size, and I'm going to set it to 10 centimeters instead of 100. And by doing that, I'm now able to move this down exactly 10 centimeters. I'm also going to set this back to 100 now, because I really want to make sure that everything that I'm doing predominantly stays on the grid. Now I've gone back to my view and I can't see the sky dome and I can't see the floor. And the reason for that is that I've still got them hidden. So I can hit Control H and they'll pop back. But most importantly, what I've done right now is we've created ourselves a nice bridge. And if I was to hit play, I will now be a floating thing. And if I run into this surface, it's not going to let me pass. But if I want to go under the bridge, no worries. Now these tools are used primarily for just blocking out the environment. You really don't want to rely on having too many of these in your final piece. Typically what happens is you block out your geometry this way, and then you'll go back later and convert them to static meshes to make them more efficient. Now that we've covered geometry tools, we're going to be looking at static mesh placement in the next section. You'll notice that when I carved out my geometry, the floor didn't get carved. Now the reason the floor wasn't carved is because the floor itself is actually a 3D model that's been imported in. If I was to click on it, I can see that it is actually a static mesh actor. So even though this is a simple mesh, it will still work to illustrate the point. I'm going to click on this little magnifying glass next to static mesh, and that's automatically going to take my content browser down the bottom to the asset. I'm then going to double click on it, and I can see, for anyone that missed what I just did, I grabbed on this and I docked it with the top so that it would be part of my main window. You can see that the 3D object is just this. Now, any good looking mesh in the game is going to be a 3D object that's been imported in. You don't really carve things out that are like fine geometry using the geometry tools. So I'm going to give you an example of how that works. But first up, what I want to do is I'm going to click on this button here, which says Show or Hide Sources panel. It's on the left-hand side of your content browser. And that's going to give me the full proper content browser view. So what I'm going to do is I'm going to go Content, ArcViz, Mesh, and I can see within this mesh folder we have a bunch of different static meshes. So I'm going to open up this couch. Now first up we have this couch. Now this couch represents a 3D object that's been imported into the game. If I was to click on wireframe mode, you can see that it is very, very dense with a whole bunch of different polygons that have been cut in to get a very nice shape. This isn't the kind of thing that you would make with your standard geometry toolset. I can click collision, and I can see that the couch has some very basic collision. It's got a standard box collision around it, and then it's also got this much tighter collision that is the complex collision. They're differentiated by the colors, and they're used for different purposes. I'll go into them later though. Now over here we have the materials that are being applied to the couch, and if I was to go to this and click the isolate button, highlight button, it's going to show you where that material is being used. This one is being used on the couch surface itself, but you'll notice that there are two materials, and the reason for that is the legs. If I was to click highlight on the legs, you'll notice that this material here is being set to these. So I can hear some of you asking, what is a material? And the best way for me to describe that is actually with a different asset. I'm going to close down my couch, and I'm going to open up this asset called mug. And now when I do so, you'll see that we're greeted with a rather conventional 3D mug. Now the reason I wanted you to look at this is, first off, if I was to get this asset's material, up on the top right it says m_mug, and I was to click this magnifying glass, it would open it in my content browser. So I'm going to go back to here, and in my content browser I can see that m_mug has been selected. Now I'm going to double click on that, and what we're greeted with is this, which is our first material. Now, essentially a material is a shader. So a material is what you use to wrap textures around a 3D object. If you imagine any object that you get, remember that when you color it, it essentially has to be colored using a texture of some sort, so a two-dimensional image. So you have to wrap this two-dimensional image around a three-dimensional image, and we use shaders to do that. And not only are they used to apply the textures themselves, but they're also used to then add other settings. Now, a good example in this case is if I zoom in here, we can see that we have our Epic Games mug. Now, if I was to get this, I can see that over here we have a logo for Epic Games, which is interacting with some other nodes and eventually runs into this base color. Now, I'm not going to go into the material editor too much here, but I will show you some of the changes that I'm referring to. If I click on mug color, so if I was to change this to, let's just say as an example, a orange, and I was to set this alpha value to 1, we're now going to get a mug that looks like this. So this is the way that you can create one 3D asset and one simple texture, but use various parameters to change how things look. Now, I'm very briefly going to go into what we're seeing here, but I'm going to cover this more in depth at another stage. Essentially what we have here is a texture sample that if I was to right click on and hit start previewing, the editor will now show me what it looks like just with this node being calculated. And you can see that it is white with an Epic Games logo. Now, this texture, if I was to open it within Unreal, looks like this. I'm sure you can see that something's missing. And the reason is that colors in Unreal, or textures, aren't stored as just red, green, and blue like they would be in a conventional image of something. They also store what's called an alpha layer, which is actually typically used to store the opacity of something, so how transparent it is. If I get rid of the opacity layer, you can now see that the logo's here. Now what this means is that if I was to just look at the alpha channel, I would get this. And what this essentially is a nice outline of where the logo is meant to go. Now I'm going to go back to the material, and you can see here that we have red, green, blue, and then there's this little gray one down the bottom. Now what this means is that on a texture sample, the white pin represents red, green, and blue. The gray pin represents the alpha channel. Essentially what it's saying here is the alpha layer runs into what's called a lerp, or a linear interpolation. And all this does is whenever something is black in the texture that goes into the alpha, make it this thing. Whenever something is white, make it this thing, which essentially combines the colors together to create this. Finally, to get the rest of the look, all that they've done is added some extra parameters to set up a normal map, which is used to create subtle bumps around the surface of the object, or in this case, to round out the object. This is something we're not going to be covering in this tutorial. They're also adding in a texture to calculate the ambient occlusion, so that it has some just slight darknesses in the model where these vertices come together, just to create a slightly more realistic effect. Now this, again, isn't stuff that we're really going to cover too much in this initial presentation, but we will cover later. So I'm going to close down my mug asset. I'm not going to save my changes, because I'd rather keep the mugs black for the time being. And I think it's about time for us to start looking at creating our first map. So for this first map, I'm going to need you to click File, New Level, and I want you to create an empty level. With an empty level, what we're essentially going to be doing is carving out geometry at the very beginning that's going to represent kind of a clean slate for our map. So initially what we're going to be doing is laying out the floors, laying out the walls, and laying out the roof. For this first piece, what I'm going to be doing is carving out the floor. Now, to carve out the floor, what we're going to need to do is once again go back to our geometry tools. So place, geometry, and I want you to drop a box into the scene. Now, initially, I'm going to get this box and I'm just going to drop it down so that it's flush against the floor. Do you see that? This grid, it's now, the top of it is touching the grid. So the reason I got you to do that is that I want you to go to the geometry tool setting and we're going to start expanding this out. Now, I could do it in this view and start pulling out walls and such. But the other way that I could do this is if I wanted to, I could go perspective, top, and now we're shown an orthographic viewport that lets me actually do things from a perfectly top-down view. This means I can move the box to here, for instance. Oops, the center of the grid. And I could then click, and whenever I select one of these lines, it actually selects the lines that are perfectly parallel with it. So the first thing that we're going to be doing is laying out this floor. And this floor is going to be quite large. So I'm going to get something and I'm going to pull it across to be about this big. This is something that we can tinker with later on. But I'm going to pull it across so that it is 2 of these larger grid spaces across. And then going down, I might do the same so that we have a square area. So if I wanted to, I could always go from from top view back to perspective. Now, it's at this point that I really want to point out that whenever you're carving up a map, it's really, really important for you to have perspective. If you don't have perspective, this entire thing can be a very frustrating experience. So I'm going to click on Mesh, and I'm going to drag myself a couch into the map. Now when I've dragged in the couch, we can now see how big our room currently is. And it's pretty large. But that's okay, because we're going to be building walls around it and going from there. So to add walls, we're once again going to just drag in some boxes using the geometry tools. Going to drop this in. And I'm going to do this from the top-down view. So I'm going to click perspective and change it to top. And I'm going to size this up. So I'm going to go to my geometry editing mode. And I'm quickly just going to lay this out so that we have something very basic inside of our world. That's a good start. I'm going to go back to my place menu. Now remember, you can always hold down Alt and drag. And you can now see that I have a perfect duplicate of this wall here. I'm going to use that as a basis and hold down Alt and rotate, which allows me to size this up, which is currently going to need to be shortened a little bit. That's okay. Oops. So I'm going to go back to my perspective, and I can see that we have the beginnings of my walls here. Once again, I'm going to Alt drag and just pop this over here. Now, the first obvious issue with what we have is that if these were walls to a room, they're not exactly, the right height. So the question is how tall should we make something like this? So this is where, again, a point of reference really comes in handy. I'm going to drag in this doorway and put it here. So this doorway I know is perfectly sized and it is the correct height for a standard doorway. So I'm going to modify my walls to be taller to kind of match that. So what I'm going to do here is I'm going to select by holding down Control and clicking on just each of these blocks. And I'm going to go to my geometry editing mode, at which point I'm going to select all of the faces. And I'm just going to drag them up a little bit. Whichever face that you select last is the one that the widget will stay on. So I'm going to actually select this one last. And if I was to drag this up, we would now be presented with a room that was around this size, which I'm reasonably comfortable with, actually. We could potentially go higher and go for a really high ceiling and then cut down wherever we want to, but this is probably okay for the time being. So with that in mind, we're now going to start kind of playing with our space a little bit and getting a general idea of what we actually want to have as a setup for our room. Now, one thing that's worth mentioning here is that instead of flicking between the views, if you'd like to, you can click this button at the very top, which will simultaneously show you the left, front, top, and perspective views. So if I click here, you can see that it's been selected from all different directions. So I'm going to stick to viewport for the time being while I kind of lay out the fundamentals of my room, and then we're going to go backwards from there. The other thing that's I'm just going to leave out is I'm not going to touch the roof for the time being because I'm probably going to try and carve something interesting into that. Now for this initial area, what we're essentially going to do is create a reasonably small room. And I'm going to have a couch that's going to be sitting here. Other way around. And I'm going to make this like a standard family room. So I'm going to alt click. And I'm going to have another couch that's sitting over here. Oh, that's probably good enough. I'm going to drag in a couple of other 3D objects. So again, I'm going to drag in my coffee table. And these are all going to get relocated later, but this is going to be my initial grounding for this space. I'd really like to have this door kind of pulled over here so that they had to kind of walk past these things as they went. And I'm probably going to make this area significantly smaller. So I'm going to get the door, and I'm going to put another door probably around here. So this means we're going to end up with a space around this size. Since I've got the couches in there, it'd be nice if we added a chair. So I'm going to drag that in, spacebar. I'm just going to rotate it into somewhere that looks vaguely nice. Again, we'll be fixing this later. And because we've got the couches and the chair here, I'm going to set myself up to eventually have some sort of television here. Now, to drag in the TV, I'm going to drag it in. Again, I'm going to rotate it. I'm going to pull it back. Now, for obvious reasons, this isn't really the best way for us to have set up this space, but that's okay. Whenever you're doing these things, you're going to make 1,000,001 adjustments, because as you start carving it out, you're going to get a better idea of what you need to do. So in this situation, I've got a door here, couch, couch, chair, tabletop, TV. Now, if you want to follow along, I'm going to switch to top. I'm going to zoom in. And I'm just going to leave this on screen for a second so you can copy this into your own if you choose to. Now, from here on in, what I'm going to do is I'm going to start relocating these things so that they're in a slightly more comfortable sizing. The first thing that I can see I'm going to need to do is clearly bring in all of my walls because I was totally over-eager when I anticipated how big I actually wanted to make this room. So I'm going to go to place mode. I'm going to drag select all of those objects, but not the TV. I'm going to pull them in to about here. Now, if I was to go back to my perspective mode, I can now see that this is a little bit closer to what we want, although I may have been a little bit overeager. Pull it back 1 meter more. That feels nice. Yep, we'll go with that. So this is going to be my initial area. I'm now going to get this, and I'm going to pull this wall in to here. I'm going to get this. I'm going to pull it in to here. And while I'm at it, I'm just going to quickly resize a lot of these things. Again, I'm just selecting the necessary faces in geometry mode. Oops. Now, if we wanted to do more rooms, we could always go ahead and actually, keep the floor the size it is. But I know I'm probably going to be leaving it like this for the most part. So for the time being, I'm going to shrink this down to the smallest size it needs to be, just to make my life a little bit easier. So now we have the basics of our room. We're going to plan out some other things now as well. So I really want to have some sort of light kind of coming in through here, and that's going to be like a nice sunlight or evening light coming in from over there. The other thing that I'm going to do is we may crack open this door so that we have ourselves a hallway going on. I know I'm going to have some lamps around the place and some other things, but I'm going to keep this reasonably clean and reasonably simple. So it's at this point that I'm going to take myself out of the unlit mode. Problem is I have no lights. So I'm going to go to my place menu and I'm going to click on lights. And I'm going to drag these into the scene. Now, these are what I call work lights. What I've dragged in was a point light, but I'm not really going to bother setting them up. I'm putting them in more so I can get kind of a feel of the space itself and have a general idea of how things are laid out. So I'm going to alt drag a couple of work lights around the space until they, correctly illuminate everything. Also, one useful tip is whenever you're working like this, I often tap G to see how it looks as if it was in the game. So it gets rid of all of the editor looking elements on this. So G to tap into game mode, G to tap off. You can also do it through here, game view. So we've got the beginnings of our space, and it's at this point that I'm going to start making things kind of a little bit more interesting. I think the first protocol is really going to be making sure that we have some nice lighting going on from outside this doorway. So I'm going to drag this sliding doors asset over to here. And this is going to eventually end up being where my sun's shining through. Now, the obvious issue that we're going to have if we do this is that, well, I have a wall in the way of my sun. So I'm going to go ahead and I'm going to drag in under geometry, I'm going to drag in a box, and I'm going to set this to be a subtractive box. You can now see that this carves the whole way through our wall. So the first thing that I'm going to need to do is look at this and kind of shrink down the subtraction brush to be the correct size of this doorway. So I'm going to click here and I'm going to go to my set position, my snap size, and I'm going to drop it to a 5 centimeter snap. I'm then going to go to my geometry tool and click here. And I'm now going to bring this all the way back so that it's very, very thin. Now it's hard to see, but I think that will line up. The next thing I'm going to do is I'm going to select each edge of the subtraction brush. Again, if you can't see it, you can always go to wireframe mode and select the correct brush. And I'm just going to pull these out so that they kind of meet where the door ends are, just like the top. So for anyone, again, that's forgetting, it's Alt-2 to go to wireframe mode. Which one I'm going to go back into lit mode. We can now see that that's carved in and running reasonably well flush against the edge of this. We'll have a better idea in just a moment. So the next thing that I'm going to do is kind of carve out how this open area looks. Obviously this wall is massive. No one actually has a wall this big. So I'm going to get this wall and I'm going to pull it in as well. So I'm going to go to a 10 centimeter snap grid and I'm going to bring it to about there. So that's reasonably thin. You can see if I go into unlit mode that that's how thin my wall is. Now that my wall's resized, I'm going to pull out and relocate this doorway so that it's just inside of the edges here. So I'm going to go to a 5 centimeter snap grid, and I can see that it's currently doing that. And I'm just going to move it over so that it's now sitting inside the wall correctly. The other thing that I've gone ahead and I'm going to do is I'm going to select my subtraction brush, and I can see that there's a slight issue whereby the brush is currently not reaching the end. I thought it did, but it's not. And let's do that on both sides, because hey, if I'm going to make a mistake, I might as well make it twice, right? So I'm going to go to wireframe mode, and it looked like it was just 5 centimeters across. Would probably do the trick. So I'm going to do that on both. I went 10. You can now see that's ending inside of the door. And the other thing I'm going to do is I'm going to go here. I'm going to select the back face of my subtraction brush. Again, it's a little bit occluded by this static mesh, so I'm just going to get rid of the static mesh for the time being with the H key. And I'm just going to resize this to be the size of the doorway. So we've now got ourselves a nice little doorway. And I'm actually going to go ahead and I'm going to drop in a temporary directional light that's going to act as just my sun, so I know how this is going to start looking. So I'm going to go back to my place menu, lights, and I'm going to drop in a directional light actor. Hit spacebar, and you'll see that wherever I rotate this to, it's going to kind of have the sun coming in from that direction. And I think this would look best if we had like the doorway kind of casting some cool shadows going straight across the room. So it's at this point that I am going to go ahead and create a roof so I can get a better idea of how this is going to be looking. I'm going to set my snap grid to 100. I'm going to alt drag upwards. And you'll see that that's nicely snapped to the roof because we stayed on the grid. And we've got this going on, which looks okay. Thinking I'm going to go to a 50 centimeter snap grid and move this across as well, actually. Just give them a little bit more space as they kind of come in that door. Cool. So with that in mind, let's start looking at what we can do to kind of make this room a little bit more interesting. So now that we've blocked out the room, we're going to move into the finer details. To begin with, I'm going to go to my materials section and I'm going to set myself up with some walls. So for the walls, we're going to look around the materials and you'll see that there's one that is called wall pane interior matte inst. Now this is a material and all I have to do is hold down left click and drag it onto a surface to apply it. Going to do that again and again. And again, my 4 walls. Next up, I'm going to go from here to start looking at what I'm going to do with the roof. Actually, you know what? Let's do the roof as well. That's a nice white. And I'm now going to go delete the search term I had, which was wall. And instead, I'm going to do a quick search for floor. You see that one of them is wood floor matte inst. So I'm just going to connect that to here. Don't worry about the outside, we'll fix that up later. And we've now got ourselves a nice floor and some walls. So if we wanted this to look like a real space, the quickest way for us to kind of start doing that is going to be, well, to kind of make it a little bit messier. So what I mean by that is, let's actually get these 4 walls and start carving them out a little bit, because how often do you actually have 4 perfectly square walls inside of your room? Typically you're actually going to have like little things carving in because there's closet space somewhere, or there's going to be a staircase behind it that's forced a wall to be pushed in, or a chimney perhaps, etc, etc. So I'm going to start carving out my space in a slightly more interesting way, and you can do this however you want to, but feel free to follow along with how I'm doing it so that you've got something to kind of compare it to. This initial space, I'm going to go back to my geometry tools, my geometry placement, and I'm going to drop in a box over here. Now, because I had the floor selected as my last my last material, it's going to go ahead and apply that to the box that I dropped in. I kind of don't want that. I'm going to set it to be the pane interior instead, and I'm going to go ahead and drop this in, at which point I'm going to start working out how best to have this fitted. My gut says something that's very nice and snug against the wall, probably even more snug than what I'm seeing right there. Probably when I go to this, I'm going to go to a 10 centimeter snap grid, and I'm just going to pull this in until we're about 20 centimeters from the wall itself. I'm also going to run that all the way up to the roof. And I'm thinking I'll run it to the side further. I might just place it like this. So we kind of have it sticking out like that. I'm going to move this television. This means that I could theoretically have like a painting or something sitting there. I could have a nice lamp sitting over here. and potentially like a table in front of this. So I think that's going to come along all right. So I'm going to go from there, and I'm going to add that painting because I really like the idea of it. So this is going to sit around here. Yeah, that'll look alright when I'm done. Cool. I'm also going to have like a standing lamp sitting in the corner. Keep in mind that all of our lighting is currently temporary. We're going to be adjusting it as we go. Put a pop lamp in there for good measure. It's a good idea whenever you add something like a pop lamp to go ahead and add a second one somewhere, because typically these things kind of come in twos. I'm going to grab my lamp and follow my own advice. So I'll drag. Probably be nice to have another one of these somewhere over in the corner, but I feel like this is another one of those things that we could probably make a little bit messier. So I'm going to go ahead and add another wall along here. So I'm just going to select this one and just drag it across because I know it's the correct size. And something like that would probably do reasonably well. I'm going to connect this all the way over to the wall. Oops, I wasn't in geometry mode. Going to run this all the way over to the wall. So we've got something nice. Adding a little bit of disruption to the room. Looks okay. Then going to get my shelving. Drag this in. I'm just going to quickly add some bookcases along the wall here. Something that, you know, as you walked in, you would see. I'm going to alt drag, so we've got two of these next to each other. Make it look like a larger case. Now here's one of the first things you'll find when it comes to modeling. Quite often you don't have a model, but you do have something very similar to what you want. So for instance, I have this bookcase, but if I turn it sideways, I have a TV stand. Doesn't matter that it's under the ground. No one's ever going to know. No one's ever going to see. This can be our little secret. I'm also going to move these across a bit because they're now not in the best alignment with the rest of my room. Yeah, that looks okay. I've got a fair bit of space over here on this side, actually. I'll figure that out in a bit. So I've got that going on. I've got a nice lamp over there. And I'm going to go ahead and add like a rug underneath this lamp. So carpet. So I'm just going to drag this until we get into a position that's quite nice. I think it might even look better to have it a little further that way. You know, it's at times like this that I actually almost feel like my room is still too big. So again, I'm just going to eyeball this stuff. So as long as you're kind of vaguely close to what I'm doing, then we're all good. I'm going to set this to be a 100 centimeter snap grid, and I'm just going to go into wireframe mode and kind of just pull everything in by 2 meters or 1 meter in. So I'm going to grab this entire wall, just move it across a meter. This mesh across a meter. This mesh. And the good news is you know, I can do this now, and if I was building off of an actual plan, this wouldn't matter quite as much. There we go. It's a bit more snug. Yeah, I like that more. So I'm going to go out of geometry mode. I'm going to set my snap grid to be a little smaller so it's easy to place things around the world. Yep, that's good. So again, I'm just going to keep going through and just adding general clutter. I know a lot of this stuff seems kind of boring, but it's a good idea to know how to do it. So again, that went too high initially, but by pressing the end key, it fell down onto the floor and got to the correct size for something that would, be sitting along there. I'm gonna go ahead and just, okay, so if I look at this painting, I'm gonna drag this in. You'll see that it's called M Painting 1. Sorry, M Frame 1 with the material M Painting 1. And if I click on Painting 1, there's actually a bunch of different paintings that I can swap this out with. So in this instance, I'm going to go with something like this one. And I'm going to set it to be scaled up. Now before I showed you this tool, but I didn't really go into it too much. If I go to my scale widget by hitting space, or I can select it from up here, I'm able to actually click and resize the object. Now at the moment, I've made a bit of a mistake that I'm not actually 90 degrees. I thought I was, but I was negative 100 instead of negative 90. So I just typed it in manually there. I could have used the rotation widget, but I wanted to be sure. So I'm now able to kind of get this, put it up here as like a big painting of some sort. I might change these numbers to be straight 2, 1, 2. Now this scales it on different axes. So if I set this to 5, it's going to stretch out to be 5 times the length going that way as to it normally is. If I set this one to 5, it's going to be 5 times the size upwards as it normally is. So I've gone 2, but I've kept the y-axis as a 1. And the reason for that is that I still want the frame to be pretty thin, which gives us this effect. So I'm going to set this to a 10 centimeter snap grid and just snap it against the wall somewhere. So again, I'm going to keep going through and just drag stuff out, set up a very basic environment. And it's about time that I kind of went and added, thinking some little stands next to the couch could look nice, just something that you'd put a remote on that's when the table just seems too far away. Life's tough. So I'm going to drag this in, and on a whim, going to set it to 0.75, 0.75. Okay, I'll keep that as 1. Now the reason I've set it up like this is I want it to kind of be thinner, and I'm sure many of you are groaning at how I'm using these assets, but it's okay. I'm going to drag this to either side. Now I got a bit of this happening. Looks right. And we can go off and we can put a lamp on top of it. Nice. That lamp's probably a bit too big though, so I'm going to set this lamp to 0.5, 0.5, 0.5. Now, one thing that's worth noting is this little lock key. So if this lock is checked, when I scale something up, it scales all of the axes at the same time. So see how those numbers are all changing together? But if it's unlocked, I can rescale it on only one axis, which is also very useful. In this case, 0.5 is fine. I'm going to lift it up and hit end so that it drops down onto the floor. And I'm going to copy it over to here. I have one on either side of the table. Now get ourselves some lamps. I kind of want to add another rug, so I'm going to click on this rug and Alt drag it across. And I'm going to shrink it down a little bit to about 0.75, just so we've got a little bit of differentiation. Also going to rotate it so no one ever notices it's the same rug. Cool. I think finally I'm just going to quickly add some other paintings and then we'll move on to the more interesting stuff. So I'm going to shrink this down. And again, as I showed you before, I can set this to be, maybe it's a little big, maybe a little small. Yep, and I can set this to be a different painting, because we have all sorts of different things there. So that seems good. Got some basics of the room going on. Could really use some curtains. So I've dragged in the curtains, and the curtains are currently extending all the way from the roof. So what I'm going to do is I'm going to go to this section here, and I'm just going to shrink them until they're the correct size to... Oops, that was way too small. Shrink them so they're the correct size to kind of align with my doorway here. So 0.8 seemed to be my magic number. Actually, I might pull it in so they kind of... Oh, no, I'm just going to go smaller grid. Going to need to move it a couple of centimeters out so that we're not clipping with anything. There we go. And I'm going to Alt. Now, before I do this, I actually want this to be flipped because I want this corner to be in this side of it. And the reason I want that is so if I was to click on this one, for instance, and I was to extend it along this axis, it's actually going to stretch out to cover the entire doorway. Do you see that? So I want the same thing for this one. So to do that, I can right click, transform, and just say mirror along that axis, at which point it perfectly mirrors it for us, which is nice. So that's our nice little curtain area set up. Now, the only other things, I mean, obviously we need to do a higher decoration pass on this, but this is going to be our basic blocking out for our room. The other thing I might do just quickly is I'm going to throw a mess along this ground here to make it look like a little kid's been playing around. So I could manually go through and just place these blocks into the map. So see, I just drag it in and then groan about my life as I do so. Instead, what I'm going to do is I'm going to use the foliage tool. So see this tool up here? If I click on that and I drag these blocks into the foliage tool, what I actually have the ability to do now is, if I zoom out, you can see that the entire world I have a massive circular cursor around it. I'm going to use the square brackets on my keyboard to shrink this down a bit. And you'll see that I'm now greeted with a nice little brush size about this big. Now, if I hold down left click, this actually lets me kind of paint these into the world. Now this is meant to be used for grass and general foliage, but you can really use it in any way that you want to. In this case, it's particularly good for just laying out small objects, like blocks. And if I want to, on any of these, I can actually change things like the radius, the density, so if I crank this number up and then paint, probably going to crash my editor, and I should have thought about that before doing it. Oh, yep, there we go. You can see that it added a ridiculous number. P.S. Don't do what I just did. I'm going to hit Control Z. But as I increase the density, it's going to increase the number of them in an area. I can also use the Shift left click to remove them. So if I look at this and I'm like, oh, my mess should really be over here and away from the area there, I can do so. Can add a couple of rogue blocks over there, so it looks like this kid that was fooling around has managed to spread their mess all around the room. If some of your blocks are clipping, you can always click on this button here, at which point you can grab any singular block and kind of move it around a little bit, put it somewhere that you think's nice. I want to cast a little shadow from it. And that seems like it'll be okay. Yeah, that'll probably do for my general clutter and mess. And it's at this point that I'm going to leave everyone to be, and I want you to just add some mess to this. Actually, one last thing before we do is I'm going to get this wall over here. I'm going to go back to my place mode. I'm going to go ahead and I'm going to make this wall a brick wall. So under Content Materials, I'm going to tap on the word brick. And I'm just going to set it to this brick blue. The reason for that is I'm going to set this up to be kind of like a general feature wall. So I want you to go through and add your own details. If you're trying to figure out what to do, a good idea is to add books to the room. So you could add all sorts of just like general books to the shelves here. You could add some mugs on the surface, etc., etc. So we'll meet back in just a little bit, and we'll start with our meshed out room. We'll start looking at how to do some lighting. So I've gone through and I've done my detail pass. There's a couple of things that I've done that you'll need to keep track of. First off is to get my lighting not looking completely hideous, which I'm sure you've noticed that some of your walls are doing some very odd things at this point. I've just clicked the build button up the top, which builds your lighting. I've also saved my map. You can do that by just clicking Save Current, or alternatively going File, Save Current As, which will save it as a specific name. In this situation, I've called my demo map pre-lighting, and the reason for that is that I wanted to have a save point that was before I actually started correctly adding my lights to the map. So if I go through here, I'm just going to show you some of the smaller details that I've added. First off, you can see that we've added some tiny things such as the light switches to the walls. We've added books to all of the bookcases, so these have just been added and then manually kind of rotated to look slightly nicer. The material on the books automatically changes the color according to their position. If I go across the room as well, I can see that we've got this. So I've added a coat hook to when you first walk in. I've added this little environment here, which is made to just look like an adjoining corridor. I thought this was nicer since it kind of opened up the space a little bit more. I've added some statues up top and some pot plants down here, as well as a couple of vases. It was kind of sneaky, and I shrunk one of these pot plants and put it in the vase. As well as that, I've gone ahead and I've added this outdoor area. So you can see here that we have just a very simple fence that's running along the outside with just a tile. Now I'm sure you've noticed that I have no material set up for this outside area. So I have no material set up for it because I never want the player to go out there. I only ever want them to see it from this perspective. I've also gone ahead and added a building and an atmospheric area out here. So to do that, the building itself is just a background card, so you can just drop that in this here. I scaled it up to 65 times size, so it's huge, at which point I dropped my camera to about here, placed it in, and then positioned it so that it was nice. To get the atmosphere effect, I went ahead and added an atmospheric fog actor. Now, an atmospheric fog actor is added by just dragging it in from here. I typed in the word Atmo, and atmospheric fog came up, so it's in my place menu, my place mode. When I drop that in, it's automatically going to look similar to this, but not quite the same. And that's because the atmospheric fog simulates what the atmosphere would look like given the sun's position, but it needs to have one very important piece of information, and that is it needs to know where the sun is. So you need to tell it which directional light in your scene is the sun. To do that, it's very simple. You just click on the directional light that you have in your scene, and if you go to your search tab and type in the word Atmo, you'll see that we have atmosphere sunlight is one of the options. If I uncheck that, you'll see what it looks like by default. And then if I check it, it'll automatically put the sun in the correct position so that the rotation of this directional light matches up with where it is in the distance. Now the atmospheric sun can be tweaked in all sorts of nice ways. I can click sun multiplier and I can crank up just how bright that sun is in the distance. And I can handle all sorts of other areas like how much fog is coming through, the size of the sun disk itself. So, we can really tweak this. In this situation though, I'm just going to keep all of my defaults because it's nice enough for the outdoor environment. We don't really need to modify it too much. Instead, I'm going to go ahead and start actually working on my lighting pass. So with that said, can you save your map and make sure that you've saved it something that is like pre-lighting? And once you've done so, we're going to, in the next session, start going through and adding lighting and then post-processing. So now that it's time to actually light the map, it's a good idea for us to go File, and I'm going to File and Save Current As, and I'm going to call mine Demo Map Post Lighting. And the reason for that is I want to save it so it's something that whenever I save, I've got something that I can fall back on that's before lighting. Now you don't need to do this, it's up to you. If you want, you can just keep powering ahead, but I like to kind of keep checkpoints of where things were. It's also good for later if you want to see how the environment progressed. So the first thing I want everyone to do is go through, and we're going to go ahead and delete the lights around the map. So all of the point lights, we'll keep the directional light for the time being, but I want you to go through and just remove any point lights that are still sitting there within your scene. Hit delete, and then I'm going to go up to the top and I'm going to click build. Now, in building lighting, it's just going to cast all of the lighting into the world, and you should get something that looks vaguely like this. That's basically what we want to have for our starting position. The first thing that we're going to do is basically focus on this light and then go from there. So I'm going to click on my directional light. At the moment I've still got my filter when I was looking for my atmospheric sunlight, and I can remove that by clicking on the X. And when I get into this, I can see that there are some things that we can tweak and change. Now, the first thing that I want to do is I want to activate a feature called cascading shadow maps. Now, see how at the moment when my light comes in, it looks like this? It's not exactly pretty, and it's definitely not how the sun should really be looking. So I'm going to scroll down, and you'll see that there is a section here called cascaded shadow maps. Now, how cascaded shadow maps work is they basically project a dynamic shadow from the sun that is a much clearer and harder shadow than you would get if you were to bake things in. When you bake in lighting, it automatically kind of blurs between the values, which can look okay, but it's definitely not the result you want most of the time. So here's an example of how cascading shadow maps work. I'm going to turn this number to 200. And if I start approaching the shadows, you can see that whenever a shadow from the sun is 200 units away from me, it starts bringing in a nicer version. Now, in a game, it would really matter about how optimized we were with this value. For instance, if I did 500, I would need to be aware that, things are going to change at a distance. It doesn't matter so much for architectural visualization, but there are some values that you should be aware because of it. So, for this, I've already gone ahead and put in a couple of base values, but the defaults look like this. Now, the first thing that I want to show you after the dynamic shadow distance is this one down the bottom that says distance fade out fraction. Now, if I was to set this to 0.5, you can see that the blend between static shading and dynamic shading is much longer. If I go 1, then it never is truly fully dynamic. It's always fading out over the course of its shadow. Do you see that? Now, if on the other hand I was to set that to 0 and move backwards, you can see that there is a very harsh line where the two of them are meeting, so where the static comes in. So in my situation, I'm going to go ahead and I'm going to keep this distance fraction to be about 0.2, and I'm going to increase the dynamic shadow distance to just about 2000, because this I know will always capture the entire map, so it should look pretty good all the time. Now, there are some other things we can do. For instance, we could change the number of dynamic shadow cascades. This essentially is going to create a lower or higher res shadow map on your scene, which can look really good, but can be something that increasing the numbers doesn't always increase the quality, but it does definitely increase the rendering cost. So you really want to be careful about how you do this. It basically kind of splits the shadow into a couple of maps and bakes them out separately. To be honest, the default values are usually pretty good here, and unless you're having some serious issues, it's not worth tweaking. If I increase this or decrease this, I can change how they blend between one another with this transition fraction. So those are all very useful values, but 9 times out of 10 I'm keeping them pretty close to the defaults, apart from enabling it with a specific shadow distance and controlling how soon those fade out. So we've now got this happening, and it's about time for us to now add a light mass importance volume around our environment. So to do that, I'm going to go up to here in my placement, and I'm going to type in light. And you'll see that one of them is called a light mass importance volume. And when I drag this into my scene, we have this. Now, essentially, a light mass importance volume is used to tell the scene where the actual lighting that we care about in our environment is. So it's kind of telling us where the main level is. So you always want to wrap this snugly around your map without too much overflow. 1000 was almost right for me, but I'm going to go 1200, which is probably a little bit too big, but not too bad. So I'm going to go 1200 by 1200, so I know I've got a big box around the map. And I'm going to increase the height to be, I'm going to call 400 to be safe. Cool. Now, after we add the light mass importance volume, which just gives us more accurate lighting results, I'm going to go ahead and I'm also going to add something called a light mass portal. Now, light mass portals were added a couple of versions ago, and they're one of those things that kind of sneaks into the engine that people don't really know about, so it's really important to use them. So you can see that when we've finished building lighting, the light mass importance volume has more accurately calculated how light should be bouncing around the room, and we're getting this extra light around here, which is substantially nicer than what we had when we did our first bake, where it was a stark black on light contrast. So I'm going to add my light mass portal, which essentially tells the game, if you're casting light near me, make sure that I put a whole lot of light through this area is in an accurate way. So it's a good way to essentially denote where windows are, or in my case, transparent doors, so that the game correctly calculates lighting going through those things. And that's because typically when you do something like this, your windows, you always want to have like nice natural lighting, coming through them. So it's a good idea to kind of tell them where your area actually is and let it kind of adapt to it accordingly. So the values that I need for this are 120 on the Z, and I'm going to call it 140 on the Y just to be a little bit more accurate. I'm going to call 20 on the X as well, just so I know that I've definitely encompassed that entire opening. Now, when I hit builds, this should give us slightly nicer results. It might be a little bit hard to see initially, but believe me, when you have more windows, this really can make quite a difference. So with those in place, we're going to start looking at how we handle the actual smaller sublights within our scene. We have lighting now kind of coming in, casting some nice shadows on the scene, but it's about time that we start looking at these lights that I've placed on the roof and putting some actual projections to them. I went and added the SM round ceiling light to the world. I also went through and changed its material from the ceiling light matte inst to ceiling light matte lit inst. And if you see the difference there, it's that versus that. And it's at this point that I'm going to go through and I'm going to start adding some spotlights to these to kind of correspond with what we're seeing. You know, we can have an emissive looking object, but if there's no light coming off of it, then we clearly have something wrong. So I'm going to drag in my first spotlight, and I'm just going to place this to make sure that it's flush against... There we go. So about there. Now, one thing that's worth noting here is that the reason I place these lights close to the walls is I really like this effect of illuminating an object within the scene. If I was to get this same object and alt drag across to here, you can see that again we can kind of create this really nice effect, especially along something like a feature wall. So initially, how a spotlight works is it projects light through this cone up until the point where it reaches its attenuation distance. So see how at the end of this, it's projecting light all the way through to here? We don't want that. We want to make sure that our lights are set up as snugly as possible and they're not going too far. So I'm going to set this to 400 as that kind of nicely goes beneath the floor, but only just by a little margin. And I'm going to set that on both lights. I think the overall radius of the lights is probably okay. We can tweak that later if need be. But essentially what I'm going to do for the time being is click on each of these, and I'm going to alt drag across and just place all of my lights within the map. It's worth noting that it's a good idea to make sure things like lights kind of align in a logical way. The reason being is that because lights are typically placed by architects, they're not kind of added in a free-form way. They're usually spaced out, in theory, rather nicely. So I'm going to add that there, and I'm going to drag this over here and just add some more of these around. Now, because this section of my roof, because it dips down a bit, I'm going to have to make sure that I dip my light down to correspond with that. And I'm going to go ahead and add this other one here. Now, before I go any further, I'm going to go ahead and change one other thing, which is I'm going to go Window and enable World Settings. And after I've done that, I'm going to go to my World Settings, and I'm going to scroll down until I get to this section called Light Mass. Okay? Now, within my Light Mass section, there's a section that says Number of Indirect Lighting Bounces. And by default, how it works is light is calculated by bouncing from here onto the surface, and then it bounces to somewhere else in the room. And it does this 3 times. But I'm going to crank this up to 100, just to make sure that any subtle lighting that would be bouncing around the room is captured nicely. And I'm going to now build lighting for the first time with these in my scene. Fantastic. So you can see that by adding those into the world, we kind of get this nice, vibrant lighting kind of pushing out that has a nice split between the artificial lighting, which is these lights, and the natural lighting that's coming in from the window, which is this nice sun. So we can see that everything is reasonably well lit, but there is a nice distinguishable line between the two. The other thing that I think is probably worthwhile us doing is getting a couple of these lights and lighting this interior area that I added. Now, if you haven't added the interior area, that's fine. But because I've got it, I'm going to quickly drop these in. And I should probably add one down the end as well. So I'm setting these up. You can see that I'm getting an X here, and the reason for that is that by default these assets can only overlap up to 4 other stationary lights. So at the moment I'm using stationary lighting. I could use static or movable. Essentially how this works is if you add a movable light is completely dynamic, and it renders all of the shadows dynamically, and you can remove them and add them to the world, and they look good, but you definitely don't want to use them as an environmental light. Purely because their shadows don't have all of this nice pre-baking. Now, next up we have a stationary light, which is somewhere in between a static and a movable light. So a stationary light can't move, and it allows you to do partially baked lighting. It gives you nice dynamic shadows from objects in the scene if you want to, and it can also be tweaked, so you can change things like the color of stationary lights as you go. Finally, we have static light. There's fully balanced baked into the world, but it can't be changed in any way at runtime. I don't mind too much about having this light here as a static light, and as this light here also as a static light, because it's only going to be like subtle lighting that's coming out of here. It's kind of this extra area that's stacked in the background. Now, the reason that most of these are currently still overlapping is if I select them all, I'm sure you'll see the issue. If I scroll down, you can see that they're just overlapping by a tiny fractional amount on the corners of their attenuation radius. Now, you can always kind of try and fix this by just tweaking this attenuation radius to find like a nice area that's still forgivable before they hit that point where they overlap. 390 somehow works. So I'm going to just change these around until I get something that works. And you can also limit your cone angle by a little bit as well. By default it's 44. I might just drop it down just a tad. So with these two lights now set to static, after doing a lighting build, these things have kind of worked themselves out and everything is now calculating correctly. It's worth noting at this point that if I wanted to, I could set every light in this scene to static. It wouldn't matter too much, but because there's a chance of wanting to kind of like dial these down dynamically and whatever else, I'm going to try and keep them stationary for as long as I can, manage the scene and work from there. So now that we have the basics in, we have all of the lights themselves added, it's time for us to start looking at the finer details for lighting. And one of the big aspects of this is reflections. We'll cover this in the next video. So we've added these lights in and everything there is okay, but it's time for us to kind of start getting these subtler, smaller details going as well. So the first thing I'm going to do is I'm going to show you a mode called Visualize Reflections. Now this is how my world currently looks if I was to look at the reflections in my scene. You can see that if things are on my screen, it can map out a reflection based on screen space, but the rest of the world is barely touched. Now the reason I'm showing you this is that any reflective or any potentially reflective surface in the world currently doesn't know what to reflect. So it's a good idea for us to go ahead and add initially a skylight. And I'm going to set the skylight to be set to an intensity of about, I'm going to call this 0.75 on gut feeling. And it's going to look weird at first because it's going to illuminate everything, but I'm going to click build. So with the skylight built, I'm now going to click on here again and go back into reflections view. And you can see that this is now how the reflections across the scene will look. And you'll notice that while these are accurate for outside, they're not entirely accurate for the interior. That's okay. It still gives us a little bit of a shine for the fallback in the event that we haven't got reflections set up correctly. But let's get them actually set up correctly. So I'm going to go here and I'm going to type in the word reflect. And you can see that we have three options. We have planar reflections, box reflections, and sphere reflection captures. Essentially, wherever you place these in the world, so I'm going to put one here just as an example. If I drag one into the world and I go to my reflections view, you can see that any surface that is in this area is basically casting a reflection of the image from the very middle of this actor. And you can change the offset of this actor using the capture offset functionality. But basically, it takes a 360 image at this location, and then anything that this overlaps then has that image, which is a good way of faking reflections without having to dynamically capture it from literally every sequence across your map. Now, if I look at how this looks in the world, you can see that there are some kind of subtle effects that start kicking in. Things like my TV can now more accurately reflect the rest of the world. This over here is going to start getting some nicer bounce lighting kind of appearing on it. Generally, areas are going to start coming out nicer. You are going to get artifacts though. For instance, if I put this here, and this is casting a 360 reflection from that location onto everything, then it's getting red bounce lighting coming from this location. So because of that, you want to shrink these down. There's a bit of a balancing act between finding like a good number of reflection capture actors and finding like results that work well that aren't completely covering your map in reflection capture actors. I'm going to put one over here by default towards this general part of the room because it's a bit darker. I'm going to place it up because I figure that's probably going to be a slightly nicer area for it to bounce in. I'm going to switch to my reflections view as I do this, so you can see that as I drag it, it starts blending the reflections at a certain point as these two kind of cross over one another. And you can control how that fall off actually works between the two as well if you're using cube ones. But otherwise it's just a linear fall off in a standard spherical reflection capture actor. So I've put this here and I've put this here, but I'm going to set up this front area slightly differently, and that's because I really want to make sure that in a night scene, it's not so apparent in a daytime scene, but in a night scene I want to make sure that this glassway would reflect the room perfectly. So to do that, I'm going to drop in a box reflection, and I'm going to place it in the center of this little, actually no, just in front of it, there we go. I'm going to place it there, I'm going to lift it up, and I'm going to essentially place it in the middle of that window. And you can see that the box reflection capture actor is huge by default, so I'm going to scale it down a bit. And it's now, actually that's probably still too big, so I'm going to go, there we go. So that's going to capture the room reasonably nicely. Because I want to be safe about where the reflection is getting captured from, I'm going to move it a little bit in front of the door. So to do that, I change the capture offset. And when I go back to lit, I can see, might be a little tricky to see, but you can see the red reflection in the window just there. That is this couch and chair just here. They have a nice reflection now that kind of accurately represents how far they are from the door. So setting that actor in that exact location was pretty important to get a good result. Again, I can now go back to reflections, and I can see that there's still a couple of holes in my environment. This is still blue because the skylight is blue. So I'm going to get this, and I'm going to just move a couple of these into these areas, but I'm going to shrink them down as well. 250 seems like a reasonably good value. Push it towards the door. There we go. And I'm going to do it over here as well. And this now gives us reasonably good reflections across the room. So with the reflection actors now all in, we've got a skylight, we have our point lights casting general light into the scene. It's a good idea for us to start looking at some of the other things that are going on that can often be kind of easy to miss. The first of those is light map resolutions. So I'm going to be upfront about this. There's a slightly confusing element of Unreal where we refer to light map resolutions in two different ways. So when we're referring to a light map resolution of a 3D asset, a higher number is going to give you more accurate results. I'll explain that more when we're looking at objects, but essentially when we're casting light onto objects, we're baking that lighting information into them. And on a 3D object that's been added, the higher the resolution, the more light is being baked in because it's like a bigger texture that stores the lighting. Now, it's different when it comes to geometry, and that is that the lower the light map resolution refers to how much of a space there kind of is between light map texels. It's a little bit confusing, but all you need to know is that when you're doing geometry, if you're getting results that aren't quite as accurate as you would like, it's highly likely that it's because your light map resolutions are a bit too high. Now, as you increase the quality here, you will have a bit of a trade-off in that your map file size will get larger, so you need to be aware of this. But I'm going to grab these areas along the roof, and when I look at them normally, you can see that we're getting some weird shading kind of kicking in here, but this isn't absorbing it. And I'm going to set my light map resolution to 16, just as a test. I'm now going to build lighting. And you can see that now the lighting's built, we're starting to get a more accurate collection of this ambient occlusion being baked in here. Again, if I look at here and here, you can see that there's this weird line that kind of cuts between the two surfaces. And there's a couple of ways that we can fix that. It's largely because this area here is 32 and this is 32, but the others are 16, so they're blurring their light across them kind of a bit more. I'm going to try changing these to 16 and see what my result is. While I'm at it, I'm actually also going to just generally go through some of these areas and see if I can just increase the resolution just in a few of these areas to get some slightly better results. This is one of those things that, because it's ArcViz and I know we're trying to keep, it's going to look as nice as possible is really the aim here rather than efficiency and file size. I'm going to set these to 16 and kind of go from there. Usually I'd be a lot more careful. So with this built at 16, you can see that a lot of the artifacts that we were getting from these lines are now missing. That's a lot nicer, and we have a significantly better environment to work with, which is pretty good. And if I go to here, you can see that that's all come out quite nicely. And I'd say we're probably good for this first area. It's probably time for us to really start looking at doing some post-processing. So I'm going to hit save, and I'm going to save this as my final version of demo map post lighting. And in the next section, we're going to start covering the basics of post-processing within Unreal Engine 4. So it's time for us to look into post-processing. Now, post-processing is one of those things that everyone knows they have to do, but they don't quite know what they're doing. They just kind of tweak numbers until they get something, also known as game development. What I'm going to do is I'm going to load up post-process, and I'm going to drop this into the map. Now, when I drop this into the map, it drops in a cube that looks like this. Now, the thing with the post-process is it essentially gives your screen certain overrides and tells it to handle certain visuals in different ways. This means that in theory, I can set up two post-processors next to one another and actually have it so that as I move through the map, one room is shown differently to another. Now, I'll give you an example of that. If I click on one of them and I go to settings, and just as my quick example, I'm going to go scene color, and I'm going to set my scene color to be blue. That'll do. And then on this one, I'm going to set my scene color to be like that. When I'm inside of this post-process, my world looks like this. When I'm inside this post-process, my world looks like this. So these values are actually changing how the environment looks. Now, I'm going to remove one of these because for this project, I basically want things to look pretty consistent. One thing that you might want to do if you were to work on this in the future would be if you ever wanted this doorway to open and people could exit out into that area, it might be a good idea to have a post-process that's like the outside post-process and the inside post-process that you could tweak things differently. But for the time being, this is a good enough position for us to start. Now, since we're only going to have one, post-processors have a nice little feature that instead of having to like wrap around the entire level, I can just click this button that says Unbound. And you'll notice that the second I clicked Unbound, the bounds of the post-process no longer mattered at all. No matter where I am in the map right now, I'm going to see the same thing. So I'm going to uncheck scene color because that was not what I wanted for my final scene. And instead, I'm going to start looking at some of the values that we do want to tweak. Now, the first of those is under white balance, you'll see temperature. Now, if I was to increase my temperature or decrease my temperature, you can see that we get this nice subtle tint in the scene. It's a good idea to go into game mode whenever you're modifying these things. But by increasing my temperature or decreasing, I can really change the entire mood of the scene in a subtle way. By default, it's set to 6,500, but if I crank it up just a little, so 7,003, we can end up, it feels like it's a much warmer day outside, and this, everything else is just that slightly nicer temperature to kind of complete the scene. Now, so white balance really does matter, and if you want to, you can also affect the white tint, which kind of does it a little bit more aggressively. I personally usually just play with the temperature and leave it about there. Color grading is something that we're not going to tinker with too much. Suffice to say, if I wanted to, I could really affect how the world is calculated by desaturating certain channels. Increasing contrast on certain channels is another strong thing, so I could end up with a scene that, look, it looks quite cool, but as far as ArcViz goes, it's not particularly great. That said, if you're ever after a scene where you're having a bit of a flashback memory kicking in, color grading settings here for saturation, contrast, and especially gamma and gain to kind of get that old filmic view for a memory works really, really well. It also means that things like your whites can blow out in a way nicer way to kind of suit a memory. That said, because it's not what we're doing, I'm going to uncheck these and I'm going to go into the next sections that matter. Now, the color grading for shadows, midtones, and highlights, I just used to control them in certain areas. So for instance, if I wanted to only desaturate the shadows of the scene, I could do so. So you can see here that that's only affecting the dark areas of the couch while everything else is staying unaffected. So that's how those work, and that's per channel. So I could do that with any of them and I would get a similar effect. I don't really want to tinker with that for this, but I'd like you to know exactly what you're looking at. Now, as far as film is concerned, film is pretty useful. It's used to simulate how a camera actually takes in footage, which means you can do a lot of stuff like crushing your shadows and your highlights and generally kind of mixing your channels a little bit. For this kind of stuff, it's way too in detail for me to really want to cover in this tutorial. So instead, we're going to look at some of the things that we do care about. You've already seen scene color, but the first one we're going to look at is bloom. Now, bloom is very, very useful. However, it's one of those things that people can kind of treat in a slightly obnoxious way. If I was to crank up bloom, you'd get this. How it works is anytime something on the screen is above the threshold lighting value, it's going to start to blur it out and create a nice highlight. So if I set bloom to 0, the scene looks like this. I'm just going to stare at this light as my example. If I set bloom to 0, it looks like this. If I crank it to 5, it's now making it super bright and pushing out. And if I look around the world, I can see that same thing. And keep in mind, it's not just from the lighting. It's also in situations like this where it's kind of bouncing out. So the indirect lighting is causing these to bloom out in certain ways. So it can be very, very... It's very, very tempting to use a lot of bloom, but the truth is that too much bloom really quickly looks like amateur hour, so avoid doing it. One thing that I find is balancing the threshold is a good idea, so I can put the bloom up, but by increasing the threshold, the only things that actually do bloom are those things that are at a very high brightness level. So see this here? If I was to decrease the threshold, and then slowly increase it, until eventually only some things would actually be blooming. Now, obviously, that was a bit too hard on this, but it's a good example of where you would go. So I'm going to set this threshold by default to about, I think 2 looks good. So you get a bit of bloom kicking in. If I crank this up, you can see it. If I get a bit of bloom kicking in certain areas, but for the most part, my threshold's okay, so that we're not getting it excessively in other areas. I might decrease the threshold just a little bit so this window kind of picks up a nice glow coming from it. But we're still ruling out some of the objects, the other objects that were previously blooming out. So with that done, we're now going to work through some other areas. Things like your size scale control how large the bloom is. So if I do this, I'm just going to set them back to default for a second. If I was to do this and then increase the size scale, you're going to see that it increases the overall blur of the bloom. So if I decrease my size scale, it kind of just confines it to the area pretty close to where it actually is blooming from. But as I increase it, that blur reaches wider and wider and wider and wider. Now, by default, it's at 4. I actually personally kind of prefer it to be at a slightly lower value of around 1 or 2. To each their own, though. So I'm going to set my intensity to 1.5. I'm going to set my threshold to 2. I'm going to keep my size scale a little bit more. Oh, wait, threshold 1.5. I'm going to keep my size scale around there. Again, though, if you did want to crank this up, it really kind of depends on the effect that you're after. 3 in this instance, or 4 or 5, is going to give way more of a look of this light kind of billowing out into the room, whereas 1 or 2 is going to kind of keep it more as specifically that source. It's up to you. Now that I'm looking at it, I might actually keep it as 4 for this. So the next part of bloom that we need to really consider is the size and tint. So for this, I've turned up the intensity. It was at 2 before, but I'm just going to crank it up to 15. And I'm going to just show you how some of the sizing works. Essentially, bloom works by doing a bunch of blur passes, one after the other, on top of it. So you can control the size of each blur. So if I pull back to here, and I change the size of the first blur pass, you can see that the inner rim is switching between being visible and not. So you can really kind of tightly control what you're doing here. If I am going to adjust this, it's usually because I'm turning it down a little bit around that inner rim so you can still see the outline of the shape. When it's at its default, you can see that it's a lot harder to identify it, and instead it's just kind of this blur. So I'm going to turn that down to like 0.5. This works for all the rest of them as well, so again, I can kind of resize these bloom blurs to be the exact size that I want. It's a good idea to actually just use the sliders when you're dealing with this. So I'm just clicking on the number and just kind of dragging until I get the exact kind of bloom that I want. 5. I kind of want this to spread out towards the end, so this is probably going to be, yeah, about that. And I'm then going to turn down my intensity until I get back to an area that's a bit friendlier. Now, the other thing that I could do is tinting. So each of these passes can actually be a different color. So what I mean by that is I'm going to turn this up again so you can see what's going on. And I'm going to change my blur to tint from being gray to now being a slight red. You can see as I crank that number up, you can actually see the blur pass itself. But it's a good idea to work out how you want to tint each pass. I typically, when I'm approaching this kind of stuff, would go kind of like a subtle curve in my tints, one after the other. So the first one is going to be gray, but then the next one's going to be blue, and then the next one's going to be slightly darker blue. Actually, I might just lighten up that first one. So it's kind of like more of an intermediate step between the gray and the blue. And then I'm going to go up to a nice, brighter, almost borderline yellow. And then I'm going to pull that down again to a blue. And it's very, very subtle when you do this, but it does actually change how the room feels. So with those in, you can see that we have now slightly a slightly more blue kind of bloom kind of coming out of it. If I was to turn them back to default values, you can see the difference is actually reasonably substantial on some of the areas. Again, if I turn off my blur size, we kind of jump back to this. And if I turn them up, we end up with this. Now, the next thing that I can do here that might be nice is going about the dirt mask intensity. So to use a dirt mask, I've already gone and made one, but essentially what this texture is, I'll load it up so you can see it, is a texture that looks like this. Okay, so they've simulated what would happen, what the screen would look like if there was just some grunge on the lens and just baked it into a texture. Now, once this is done, I can actually turn up my dirt mask intensity. I'm going to set it to 50 as an example so you can see it. You can see it popping in around here. As I'm now looking towards the bloom, we get a slightly more realistic, I guess is the word that I meant to be using here, lens effect kind of going on. Now, this really depends on the kind of overall effect that you're after, and it's a really love or hate kind of a deal. Some people really, really like it, and some people just despise it. I'm personally for it in certain situations. I think it looks really good, especially in areas like where you're simulating like something like Blade Runner or doing that kind of futuristic look. A little bit of grunge on the lens goes a long way. Just finding the right way to use it though is the trickiest bit. Just kind of getting the right amount. One of the issues with getting the grunge looking good as well is that, I mean, when I do it here, the max the slider lets me go is 8, which is a super subtle grunge. And I actually, if I'm going to use it, I'll usually go the whole hog and set it to like 20 or so, 25, at which point it's a bit more visible if we're looking for it, but I think it can look nice in certain situations. So I'm going to leave that enabled for the time being. The other thing that's worth noting is that you can tint it a bit. Now the reason tinting it might be good for you, obviously not in an ArcViz demo, but you know, making it look like there's some green grunge on the screen if you're in the sewers or something might be a bit more appropriate as to, you know, to whatever it is you're trying to do. So I'm going to set this up to be a slightly, pretty much a gray tint. I'm also going to turn my bloom down to where it was before, which was a level of about 1 or 2. That's right for that. Now that we've covered bloom, we're going to move into some more post-processing effects in the next lesson. In the last section, we covered the beginnings of post-processing, but it's quite a big area to look at, so we'll continue with that now. First up, we have auto exposure. So auto exposure is a it's very useful, but it's also something you've really got to watch out for, because if you forget that you have auto exposure enabled, it can really ruin a scene. So the more I see this, the more I actually want to turn that dirt mask intensity down a bit to be a little more subtle. Yep, there we go. So when it comes to auto exposure, basically you've got a low percent and a high percent, which control how much of the screen has to be in darkness or lit for this to take effect. And essentially what it does is it automatically sets the brightness levels between one of 2 different levels. So if I control my minimum brightness level, I can now push it to here. And as I pull this back, the auto exposure is kicking in and fading down to a level that's equal to default lighting. Whereas my max brightness level is going to push it further up. So if I was to tweak my max brightness level, and lower the percent that it took to reach to hit max brightness levels, we would unfortunately end up getting this. I typically don't touch these unless I really want to. The main thing that I do work with is going to be my speed up and my speed down, which controls how quickly it goes from being accustomed to like a dark environment to being a bright environment. So these variables can be pretty useful. In this situation though, I would, oops, we can't see that. So finding a nice point in the screen, open one, because it's kind of fading between them. There we go. So now I can clearly see it because it does very quickly. So finding a nice value for these, if it's dark, we want to set this to be the lowest percent with which you do it is going to be, say, 7%, and my minimum brightness is going to be, oops, 0.875. Oh, that looks alright. And max brightness, I mean, I could touch, but we're not really changing brightness too much. Auto exposure is one of those things that we're going to look more when we do an evening version of this map. So I'm going to leave those values where they are for the time being. And I'm going to reset the time it takes though, so that it's a bit more natural for your eyes to adjust. Lens flares, again on the list of things that are kind of contentious. If I do lens flares and we kind of get some going on. So to get lens flares working, I'm just going to click here and set an intensity value. I'm going to go with 5 for the minute. And I'm also going to select a bokeh shape. So I'm just going to click here and I'm going to type in the word bokeh. Now these are 3 textures that we have stored inside of the ArcViz folder. And now as I move my screen across, you can start to see the lens flares kind of kicking in there. And you can control how big these are and what kind of threshold it takes to get this. So if I wanted to increase the size, we can kind of get this more blurred out version kicking in. Whereas if I do this, we can kind of get these tinier. I mean, if I was going to do this, I'd probably go here and I'd change the threshold to be just very subtle. And I'd turn my intensity right down. Now they kind of pop in. Now, if you want to as well, you can control the color of each one as they go through. These are the default tints, and they work reasonably well. But again, it's kind of a situational setup, so if you do want to tweak them, go for it. Now, the next is what I would argue is one of the most important areas of what we've been doing. I'm going to go ambient occlusion, and I'm going to show you how this works. The edges of two surfaces, and anytime they touch, it goes ahead and adds this darkness into them. So if I look here at this corner and I set ambient off, whereas as I crank it up, now it doesn't just do it on these corners here, it's also going to do it on the statue. So for instance, if I look here, 0, 1, you can see it's getting darker inside here and in around these curves and stuff. Now, turning the ambient occlusion up is a thing that people are immediately going to want to do, but finding the right balance for it is also really important to get your scene looking good. So in this situation, what I'm going to do is I'm going to first off set the radius to be in world space. If I go radius in world space and check it, the ambient occlusion extends up to 2 meters away in world space. So see, as I increase that, I'm controlling how far the ambient occlusion is willing to spread between surfaces. So I personally find kind of doing a tighter, more controlled AO at a lower intensity works reasonably nicely. That said, there are plenty of different ways to achieve this. So you could go through here and like up the power, which is going to result in this. So you can see it's at the inside of it, it's getting far stronger. That said, I personally prefer to kind of just work off the world radius, get it nice that way, and tweak the rest of it from there. So now that we've kind of got that looking all right for the initial pass, I might actually tweak that a little bit further. So quality, again, because we're ArcViz, let's just turn that up to 100, so that way we get a nice smoother transition. Before it was at 50, it's hard to see here, so I'm just going to turn the intensity up so you can really see it. 0 quality, 50 quality, 100 quality. So that's why I'm kind of pushing for a value that's around there. At the moment my radius is quite high, so I'm gonna drop to about 50. That way it's just kind of the edges of the room that are really getting highlighted, which I think looks alright. As I mentioned before, you can use the power to kind of control how strong this is. I'm gonna, instead of going for a 2, I'm gonna push it up just a fraction so it's slightly darker inside of those areas. The other one that we can work with is bias. The bias is going to control where, like how it kind of creeps in and out of the corner. So as I increase it, you can see that the bias is kind of pulling back into the corner itself. So for this type of scene, I would typically use a bias of about 5. You can see this wall's now looking a lot nicer than what we had before. The MIP blend is basically, it controls how it actually blends into your light maps. So MIP blend, at the moment I've got it set to 0.6. If we wanted to crank it up a bit, we could, but I wouldn't go too far above where we are. I'm going to leave the rest of it all there, so that should be fine. Yeah, that looks nicer. Now we are getting a little bit of a weird effect around this post, which could be the result of a couple of different areas. Yeah, okay. So the reason for that kicking in so strongly was it's kind of at a perfect in-between area where at exactly 50 units away, it's not really calculating it very well. I could push the thing up to about 60 instead of 50, and it looks a little bit better. Yeah, it's nicer. Now, the next is global illumination. So global illumination is very, very, very useful. This is one of those areas that a lot of the time people are doing their lighting and they're like, oh, why doesn't it look good? And I'm like, well, you haven't set up your GI contribution correctly. And they're like, I don't know what those words mean. So here's where we cover that. If I go to global illumination and I go indirect lighting intensity, this If I turn it off, this will immediately give you an idea of what's happening. Basically, this controls the level of your bounce lighting in the scene. So all of your lights are directly casting light into the world, and then they're bouncing. And this is what we use to scale how much of an effect that bounce lighting has on the rest of the scene. By default, it's 1. But I almost kind of want to push it up a little bit to about 1.25. It's just a little bit nicer. By the way, I'm really regretting having dirt on the screen for this because we're trying to go for something that was super clean. So as we go, I'm just going to keep turning this dirt mask down and down. That's okay. Okay, AO, global illumination. Okay, and the other thing we can do with the global illumination is we can tweak the color, which is really good. It's very similar to the temperature, except this is only changing the temperature of the tint of the bounce lighting itself. So if we want the prime lighting to always look the same, but we want that bounce lighting to have that slightly more, sunnier feel in this area, for instance, we can kind of get this. And you could achieve something similar by doing only the midtones and shadows of the other area, but this is, I personally think it works a little bit nicer for some scenes. So getting that kind of like slightly orangey look. Typically what I do is I get what I think looks good now, and then I dial it back because I know that in about 10 minutes time, I'm going to want to dial it back. So I'm going to get something that's just slightly yellower. So we get a slightly friendlier bounce light that kind of works with the temperature that we set up before. Yeah, that looks alright. Depth of field is one of those areas that, we can cover, but it's more of a cinema technique. If you're using depth of field and you're unfamiliar with it, essentially what you're doing is you're adding blur to areas that are beyond or before a certain region. If I was to turn this on, I could just set my scale to 1. Now at the moment this is what I'm seeing because my depth of field is set to render stuff that's really far away. But if I wanted to get my focal distance and tell it to focus on things that are at a specific point in the map, say something that is 2 meters in front of me, and then I set my scale to like 0. We now end up with like that blurring of anything that is beyond or before that region. Now, for something like this, it's not really the best use of depth of field. It is good when you're trying to mimic a real-world camera, or if you're doing a cinematic scene. So if I turn it on and off, you can kind of see it kicking in around the edges there. If you are doing a real-world scene or a cinematic scene, and you want to follow a specific actor, you can use that focal point as something that you're, following the entire time. It's something that I don't use too often in games, though, unless I really, really need to. Now, after depth of field, motion blur. This kind of goes without saying. It just adds blur to anything that's moving around. It's not something we would touch in an ArcViz demo, so I don't really have an easy way to demonstrate it. MISC is screen percentage. So this is one of those areas that it helps a lot in VR. You're not going to see a difference when you're in the editor, but when you are working with VR projects, you can basically super sample them by cranking up your screen percentage to like 150, at which point you'll get a far, far better image in VR. It is kind of useless for us to use right now, though, so I'm just not going to touch it. Screen space reflections are the reflections that we were seeing earlier. So if I do show reflections only, you can see that there are some reflections that are perfectly being calculated based on what I can see. And as those objects exit my screen, you can see that it's no longer calculating the reflection. So as I can see the block, it's essentially just working on a transform on the screen to kind of get that effect. And most of the time it looks really good, and your reflection actors kind of pick up the rest of it and nicely fade between them. In a demo like this, it's a good idea to push the quality up. So before it was at 50, but if I push it up to 100, we're just going to end up with slightly nicer reflections. The other thing you can set up is at what roughness level do screen reflections actually kick in. So for this kind of a thing, if I was to turn this up, I'm actually going to have to show you in a lit mode. So at the moment, if I look at this surface, and then I decrease the required point for screen reflections, you can kind of see it kicking in. So once this roughness goes beneath a level, yeah, about 0.7 looks good. Again, this is one of those things that's going to be really per map. So you're going to need to tweak it as you see fit. Now the next thing I'm going to do, so blendables are if you want to add materials that are going over the top. If I wanted to add a cartoon shader or an edge detection shader, I would do it through the blendables. Other than that though, we've kind of covered the brunt of it. I'm going to kind of look at my scene as a whole and retweak a bunch of things that we've tinkered with. The first and foremost I'm going to tinker with is going to be bloom. I'm going to up the threshold with which things start to bloom out. And I'm going to set my bloom amount to be a far friendlier level. I'm actually going to turn it all the way down to like... There we go. I don't mind the lens effect kicking in, but I do mind the bloom being as nasty as it was. We're going to turn down my size scale for all of this actually. There we go. Now we end up with that. The lens effects as well, I'm going to just go back through and just turn these things down. As I said, typically the first time you do something, you do way too much of it, and then you go back and just adjust. I know I've ended up with a scene that looks like this. I can still see some issues with what we've done, but for the most part, it looks alright. Got a nice warm glow to everything. Up here is getting probably a bit too much shade, but it's still okay. The AO looks nice. Yeah, so look, I think that's probably it for the post-processing stage of this. The next thing that I'm going to want to do is I'm going to go into Sequencer and I'm going to start setting up a camera for when you hit play to kind of show off the world so people can see what you're doing and how you're doing it, etc., etc. In between now and then as well, I might also just do a couple of little minor tweaks to adjust the scene. The first and foremost I can see here is increasing the resolution of this floor. As this one's at 16, but these are at 32. So I feel like decreasing the res of the floor is going to give us slightly nicer shadows and match the environment just a little bit more. But otherwise, stick around, check out the next tutorial, and we'll start covering Sequencer. So now that we have the lighting and post-processing done, let's go about actually adding some camera tracks that can show off everything that we've done to anyone that wants to actually check out the environment. The reason being is that at the moment if I hit play, we're going to become a disembodied head that can fly through the world using WAS and D controls, and that's not particularly great. Instead, what we want to do is go ahead and have some cameras that kind of do some nice, like just slow moves around the world. They can highlight certain aspects that we're particularly proud of, etc., etc., etc. So let's go ahead and do that. Now, to do it, I need to go Cinematics, Add Level Sequence. And then I'm going to make Sequences section, and I'm going to make one that's called seq_demo map camera demo. Yeah, that'll do. So with that added, it opens us up the Sequencer tab. Now, if yours is opened up in the middle of the screen, that's fine. All you need to do is hold click and just drag this down. And I've connected mine to where my content browser is here, but you can set it up to whatever you fancy. Now, whenever I use Sequencer, I try to think of it in terms of using seconds instead of frames. So for any of you wondering what Sequencer is, it essentially lets you grab any actor in the game and manipulate it in any way, and then keyframe those manipulations. Now what that means we can do is get a camera, drop it into the scene, move it around in various different ways at different times, and we've created ourselves a nice, smooth camera track. So, to get started with that, what I'm going to do is put my camera about where I would like to have this camera based, like to begin with. And I'd really like to do like a slow pan that begins here and then kind of comes out and shows the rest of the room. So I'm going to start it facing the wall. The next thing I'm going to do is click on this button here that says Create a New Camera at the Current Cut. I'm going to make sure that Key All Channels is selected, and I'm also going to go ahead and make sure that Auto Key All is also selected. Okay? Now with that in mind, what we're able to do is if you make sure this button here is checked as well, I know there's a few things that you had to check, but this, and this are the three. Then what happens is anything I do with the camera is now going to be copied. So if I was to wiggle it around and put the camera, actually I'm going to move it backwards and just have it here. you'll see that a little keyframe appeared on my transform. If I was to scrub up in time to say 5 seconds and move the camera to here, then when I was to scrub back through, you can now see that the camera's moving between them. If I want to play this, I can always press spacebar and it'll play it in real time. So this is a good start, but obviously we want to do something that's longer than 5 seconds. So I'm going to go here and I'm going to set the working range end and the end frame to be higher numbers. So I'm going to say 20 seconds is probably a good point. If you put it in the end frame, it'll automatically extend the working range. So we've now set ourselves up for 20 seconds of video. The other thing I'm going to do is get this red line here and just drag it to the end. So now that we've got the first section, let's kind of get this camera just following through and doing something vaguely interesting. Let's say at the 10-second mark, we now want the camera to be... Let's put it up into the top corner, kind of looking at the room. Now if I play this, the camera's now going to go up and smoothly move to that point in the room. Now, it looks alright at the moment, but we could probably tweak this a little bit. I wouldn't mind if that move up was a little bit slower. Rather than adding that frame in another way, I can just drag the keyframe that I added up to here, about the 12-second mark, at which point we're now moving at this speed instead. So we've got our movement track working here, but at times I'd really like to be looking more at the scene. So midway through the track, I can just kind of move the view direction down a little bit, at which point, when I hit spacebar, we're going to cleanly move between here. It's now going to be focusing more on the couches and such, and then it's going to move up to here. And I can do this as many times as I like. So if I want to get this midpoint and make sure that it's a little more focused, I can. So spacebar. So that's a nice initial cut, but let's go ahead and change some of the other issues that we're having. So if I go to this and I look at this scene, one of the big things that's clearly a bit of an issue is the focus. And you'll see that if I look over here, I have manual focus distance, which actually allows me to... There we go. So you see that as I tweak it, we can actually change what the camera is focused on within this. So I'm going to bring this back at this scene to about the 4 or 5 meter mark, so about 496. And when I let go, I can go to here, I can add a keyframe. So that's now at the 5 meter mark. At the beginning, we probably want to actually focus on the cracks that are inside the screen. So I'm going to set this initial value to be something else. So I'm again going to drag this back until we get something that's very close to the frame. So I think it's about 20 or 30 centimeters. No, take it back. It's 112. There you go. So you can see that these cracks are now visible. And it's going to, as I play the thing, it's going to blend those two focal distances between blending on the wall to now blending out to focus on the cracks. And as I go through, I'm going to kind of adjust this focal distance to kind of make sure that we're really centered on the aspects that we want to. I think about there is quite nice. Get a bit of the grit coming in on the there we go. And again, we can also modify other settings such as focal length or camera aperture. This all depends on the kind of view that we really want to have at the time. I personally always start with just doing my transforms, and then I kind of go from there, but everyone's got their own workflow. So if I get up to here, so this is the final shot, I really want to make sure that this is actually all synced up. First thing I'm going to do is actually just move this a little bit further down so it's a little better in terms of framing. Yep. And then I'm going to go ahead and modify the focal distance as well. Let's be about there. And if I might actually increase the focal length by just a little bit. So because I've never keyframed the focal length before, when I typed in the number, it did it for the entire channel. But if I go to here and I hit set that as 40, and then I go back and I set the focal length here to be 35, it's now going to automatically add a keyframe as I go through. So that's going to slowly adjust the focal length over the course of the shot. Which, to be honest, I don't entirely mind. Now, that's one way to go about doing this, but what if we wanted to cut between multiple cameras? Well, I'll show you. So at the moment, we've got this camera here, and it's kind of going out to about there. Let's say during the shot, I wanted to have the camera doing something more interesting. I can actually do that pretty easily. I'm going to uncheck this, so unchecking the lock, and let's just find something else that we kind of want to focus on that could be good. So I'm going to add a nice downwards shot that's about here. And I'm going to go ahead and I'm going to create a new camera at the current camera cut, at which point it's popped in a new camera at this location. And you can see that we now have Cine Camera Actor 2 and Cine Camera Actor. So for this location, let's go ahead and actually start kind of tweaking this and getting things together. For this initial shot, let's make sure that the focal distance is set to a good distance again. So I'm going to bring it so that it's kind of focused on the couch. And I'm going to add a keyframe for that. Now we're going to have this moving sideways, so I'm going to set my transform, and again auto keying's enabled. I'm first going to add an initial transform by just clicking there, and then at the 15-second mark, let's have moved it to say about here. So that's now moving. And my focal distance at this point is going to be way closer because I want to see those blocks. My focal distance at this point, though, is still going to be reasonably high. There you go. So now that last second, it kind of snaps in. And that feels alright. So with this basic camera track working, we're now playing between here and here. And the cool part of this is instead of focusing on the camera actor, if I go up to here and I go lock viewport to camera cuts, you can see that when I hit spacebar, it starts with the first camera and then it cuts over to the second camera. Now the second camera is not yet moving, so it's a good idea for us to kind of adjust where these cuts are and how we want to have things structured. So I'm going to go ahead and add some camera cuts in here that will just be a little bit nicer. So to do this, all I need to do is click on here at any stage and just click add camera, and I can add in a cut and choose which camera I want it to cut to at that time. So obviously I've created a little bit of a mess here. So I'm going to delete these initial cuts and I'm going to tell it to run Cine Camera 1 up until we get to about here. So I'm going to drag that across. It's now going to start by doing this. And we probably want to switch to the other camera at about this stage as an example. So if I was to hit add camera, camera 2, it's now going to go. So if I play this, you'll see. Now because of how things were structured just then, I actually think it's better for the camera that we come into to already be moving. So I've moved it just a second up. Another thing that might be kind of nice here is instead of popping from one to the other, let's actually add a fade track. So if I go add fade track, you see that we've got this. And if I go to this section just here, I can hit enter and I can set this to be a fade of 0. And if I go to here, enter, I can set this to be a fade of 1. And then if I go to here, enter, fade of 0. You'll now see that when it gets to these, it's going to just black out between the two. And now for good measure, I'm just going to add a third camera. That's going to be the last section of this. It's also worth noting that if you want to get into like more in-depth sequences, you can actually add sequences to sequences. So if I wanted to set up an entire shot with everything going nicely, I could add that and then use a shot track to add various subsequences kind of going on within it. Okay, so with that in mind, I've now got that set up and I'm going to add my last camera. So I'm going to go camera cuts. I'm going to go ahead and decouple my screen from the Cine Actor. And for my last shot, I think it'd be nice if I had something that was okay, so we're going to start down here, which means I'm going to go add new camera. And I'm going to go transform and just add the current transform there. I'm going to lock this to my current camera. It's already selected. And at about the 18-second mark, I really want to be up here. And what we're going to do is now when I watch that, it's going to start here and go to here. And the fun thing with this is that my focal distance is going to initially be up close. And then by the time we get to here, what we're going to do is about a second beforehand. I'm going to keep this reasonably low. So this is going to be a focal distance. It's still kind of focusing on the couch. But then by the time we finish the shot, I then want to push this to be far focused. Probably a better idea for me to go like 600, so that kind of fades in. You can now see that this is going in. Now those were my initial shots, and if I look at how I've kind of lined them up with the rest of this, I can see that I've probably been a little over eager in how I set things up. So I'm going to set this to end at the 22-second mark instead. And I'm going to get all of these frames that I just added, and I'm just going to move them along. So I'm just going to select you, drag selects, and I'm just going to push them up to here. And if I go up to my camera cuts, I'm going to add this other camera cut just here. Actually, let me just have a quick preview as to how this looks overall. We start here, we work to here. Oh, whoops, I see what's happened. When I added the other camera cut, I removed my initial one. Camera cut 2 is going to be at that point. And then this shot's going to come in about... so that stays at the exact 15-second mark. So I might as well just add it there for... so camera cut. I'm going to cut to the most recent camera. At which point, it's going to look like this. Yep. And then it's going to focus at the end. Yep. So the only thing I can think of that I'd really want to do is I'm going to go fade. Just going to add a dark fade location there. At this point, I'm going to add a 0th fade. Fade out again. And then at the very end of the shot, I'm just going to fade to black again. It's all over the course of 1 second. If you feel like having, more specific snaps, you can set this to be whatever you would like it to be. I'm going to set the fade. So we're going to fade in as well for that first second. At which point, if I view this, we fade out. That was a good trick. Cool. So that's the beginning of our scene, and if we want it to loop, we can set it up to loop. So I'll show you how to do that in just a second. So now that the sequence is set up and working and that everything looks good, the last thing that we're going to need to do to make sure that this plays is to simply go to our world outliner and do a search for our sequence. So I know mine's called seq_demo map, and if I click on that, I can now just go down to autoplay and set a play rate, and I'm just going to tell it to loop indefinitely. And now, if I would hit play, it would automatically work. So that's it for the sequence. Stick around. The next part is going to be final touches, as well as beginning with particle effects and IES profiles. We have the first part of the particle systems in place, but let's continue so that we have something that, actually looks like dust. So I'm going to right click and I'm going to create myself a material. It's going to be called m_dust. So I'm going to open up m_dust, and this is what we're greeted with. Now, When it comes to the material editor, this is our first time really kind of creating something, but I want you to keep in mind how everything is structured as we do it. The first thing is that I'm going to click here on the preview mesh to turn it into a plane, because any effect that we create is going to be spawned onto a single flat plane and shown within the world that way. With the plane created, I'm going to right click and I'm going to add a particle color node. So this particle color node is what we use to drive effects from within the particle system. Whenever something sets the color, it's actually setting the color of it in this node. Whenever something sets the alpha layer or the transparency, it's setting it within the alpha layer of this node. So to demonstrate that, I'm going to quickly just connect this to my base color, and I'm going to go to my required node and set this to be m_dust. Now, with that set up, I'm going to hit apply on my material, my m_dust, and in the world, you'll see that we have these white cubes, well, white squares floating around. Now, after I've done that, the next thing that's important for us to kind of look at and to work with is to get these looking like actual dust. Now, the best way that I can suggest doing that is to go back into the dust effect and start setting things up. The first thing that I'm going to do is I'm going to right click and I'm going to type in the word radial. And there's a nice function called radial gradient exponential. And if I was to connect this and just plug that into my base color, you'll see that it's creating a nice radial fall off on this object. Now the reason that I want that is I kind of want to have a transparent sphere that is being used as the shape of the dust. So I'm going to go back ahead and plug this back into the base color. And this time around, I'm going to plug this into the opacity. However, there's a problem with that. You'll notice that upon connecting it, this is dark gray. And the reason for that is that by default, the material is told that it is opaque, which means that it has no transparent aspects. So I'm going to scroll down and I'm going to set the blend mode to be translucent. You can now see that we have a translucent radial fall off acting as our opacity. And the particle color is currently setting the base color. If I were to hit apply, and go back to this, you can now see that these are circular shapes that almost look like snowflakes falling through the air. So, with that out of the way, let's go ahead and add some other little features to make sure this is correct. Now, let's go back to this dust mode for this first feature. Before I said that the colors are being driven out of this particle system. Now, how that works is if I go to color over life, I can see that there are two things that I can change, the color over life and the alpha over life. I'm going to open up the color over life and the distribution and then the curve and then the points and then each point. Now I know that's a long journey, but we got there. So within the constant curve, how this essentially works is that in member 0, it says an in value of 0, which means at 0% of your life, you are this color. In value of 1 means at the end of your life, you are this color. Now, purely for the sake of demonstration, I'm going to change this to say that at the beginning of your life, you are red. And I want you to look at the particles on my screen now. They start red, and eventually they fade into a white. Now, this is very, very important, because essentially it means that we can control how the dust looks in the world. I'm going to go return these to being a full white, because the thing that I actually care about here isn't the color. The thing that I care about is the alpha, because I want the dust slowly fading into existence and fading out of existence. To do that, I must go back to my material, and I must tell it to multiply. So I'm going to hold down M and left click to add a multiply. If you don't want to do that, you can always right click and type in the word multiply. And I'm going to multiply the alpha channel of the particle against the radial gradient exponential. And then I'm going to connect that to my opacity. What this means is that if a value was coming out of the radial exponential that was equal to 1, and it was multiplied against an alpha of 0, it would equal 0, and it would be invisible. If it came out and it was being multiplied against 1, it would be fully visible, and it would be fully visible here. So with that connected, I'm going to hit apply. I'm going to go back to my dust modes, and in the alpha over life, I'm going to open up these two areas. And you can see that by default, how alpha over life is structured is that at the beginning of your life, so at input 0, the output value is 1, so be fully visible. At the end of your life, so at input value 1, you need to be 0. And if I look at this in the world, you'll see that the particles are slowly fading out over time now, which is a nice start. However, it does have an issue that we want to address, and that is simply that we want them fading in as well as fading out. So I'm going to go back to my particle system. I'm going to click on this little arrow next to the 0, and I'm going to hit duplicate. And all I'm going to say is that for point 0, at 0% of your life, I want you to be 0. At 0.2 of your life, I want you to be 1. And then, at 1, I want you to be 0 again. Which means that it's going to fade in until it gets 0.2 of its life, at which point it's then going to fade out again. And if I look in the world, you can see that the particles that are spawning are kind of bleeping into existence and then bleeping out of existence. So, with that in, I'm going to hit save on my material, and I'm going to close this, and I'm going to go to here, and I'm going to start modifying some of the variables. It's a good idea to have your scene open as you do this. I'm going to start changing some of the things, such as the initial size, and I'm going to keep this open as I do so. Now in my initial size, at the moment it's between 1 and 10 centimeters. Let's try dropping that back to where we originally had it. I think that looks a bit nicer. There's a couple of motes here and there, but they're not too frequent. The other thing that I'm going to do is I'm going to decrease the rate with which they spawn. So I'm going to go here, and I'm going to set the spawn rate. So I'm going to click spawn, and I'm just going to drop that from 20 down to 10. This way we just get the occasional fleck of dust kind of appearing in our scene. Fantastic. Now the next thing for us to look at is to go ahead and actually kind of structure this a little bit nicer. And what I mean is we're going to go here and we're going to set these up to not go full bright. At the moment they're going between 0 and 1 when we light them up. But I really want this to be a very subtle effect. So I'm going to go to my dust modes, I'm going to go to my color over life, and under this value where I said at 0.2 be 1, I'm going to try setting it to be 0.5. Even that's probably still too bright. So I'm going to try decreasing it to 0.3. Now it's worth noting that every time I change a value, it's restarting the entire particle system. And one way I can get around that is by going back to my particle, and I'm clicking over here, just in this blank empty space. And under warm-up time, you'll see that it's set to 0. If I set it to 1, it means that every time it starts the particle effect, it starts it from 1 second in to where the things would have ended up, which is just a bit nicer for the refresh. So this is looking a bit better with them being kind of nice and subtle. But the final thing that I want to do is, as I get close to these, I really don't want to be able to run through them with the camera like that. So I'm going to structure them to automatically go invisible as we approach them. To do that is very, very simple. I'm going to open up my dust material, and not only am I going to multiply the alpha against the radial gradient, I'm also going to add something called a distance blend. So I'm going to right click and type in the word distance and blend. And you'll see that we have this value here called distance blend. All distance blend does, and I'm going to right click and preview it to demonstrate it, is that as I move towards the object, it goes from white to black. And it does so by being given a start offset value, which is the point where it changes, and the blend range, which is how long it's kind of gray for before it goes into being white or black. Now, what I'm going to do from here is I'm going to plug in some values into here. By default, it's 100 and -1000. Now, to plug in just a straight number into these things, all I need to do is add a constant. The alternative is I can hold down 1 on the keyboard and left click. Now, the number I'm going to plug into my start offset is going to be equal to -100. And the number I plug into my blend range is going to be 200. This means for 200 units, it's going to go between its intended opacity and invisible. And at the 1 meter distance, it's no longer going to be visible. So again, I'm going to add a multiply. I hold down M to add those, or I can right click. The reason I use M is that it just is way quicker, and multiply is a very frequently used asset. I'm still previewing this. If I zoom in my particle, as they get closer, it vanishes. And this is what we want happening with ours as well. So I'm going to hit apply. I'm going to go into the world. And now when I get close to one, the little dust motes disappear. From here on in, it's a bit of a game of finding the right values. One thing that's happening is our anti-aliasing is kicking in when they get too small, and it's making them very hard to see. So to get around that, I can go into my material, and under the settings here, under translucency, there's an option that says responsive AA. This essentially says don't anti-alias this particle, so don't do any edge blending on the particle system itself. The final thing that I'm going to do is, again, I'm going to go back to here and I'm going to tweak this size until I get something that I'm comfortable with. Between 1 and 3 looks okay as a good starter point. It's just very subtle on screen. Now there are plenty of different things I can do with this particle system as well. I could make this way more interesting. I could make it automatically, have just a little bit of motion in it and dust going over the top. And in the example that I've provided, you can look at how I've done that. But for the time being, I think this is probably all I really want in this scene. So I'm going to hit play. You can see that just a couple of those little particles around the world kind of just add a little bit of character. I probably do want to turn down the number of them as well, though. Just a little bit of character. Fantastic. So with that done, let's go ahead and do the last thing that we want for this project, which is to make yourself a playable character that's not just a flying disembodied head. So to give myself actual controls that I can walk around within the world in, I've gone ahead and already created something. Don't worry, I'll show you how to make something similar to this in another lesson. For the time being, if you can drag an FPS character blueprint from the blueprints folder into the world, you'll see that we have this asset. It's got a nice little arrow that says which way we're currently facing. Now, if I add that to the world, and under here I type in the word possess, you can tell to auto possess player 0. So I've changed it from disabled to say that the second the game loads up, let player 0 be this person. Now, my problem is that if I were to drop into the world and be this character, my sequence would automatically be playing over the top of it. So I'm going to go back to my sequence, and I'm going to just make sure that this loop is now set to don't loop. The other thing that I'm going to do is make a slight change to my sequence, because if I were to hit play, the sequence ends by telling the camera to fade to black. The problem is that we actually don't want it to fade to black. We want it to fade to black and then fade into our own view again. So I'm going to open up my sequence by going Cinematics, Sequence. And then all I'm going to do to set this up is I'm going to tell it that the world now goes for 23 seconds. I'm just going to stretch that out just a second. And all I'm going to do is, this now goes to black here. And instead of setting a new camera at this time, what I'm going to do is I'm going to go to my fade track and I'm going to add an extra key whose sole job is to be set to 0. And now, if I were to hit play, it's going to play through my sequence. I'm going to fast forward this so you can see it. Fades to black, and now it fades in, at which point I have nice control of my player that I can use W, A, S, and D controls on and move around. And I'm now capable of kind of exploring my environment as a person would. I can look at my fancy paintings and doorways, and I can go through the environment in a realistic way. So that's it for our ArcViz demo. What I'd really like you to do now though is take what we've done and create a new room. I don't care how it's structured, but feel free to use any of the assets that we've provided and just create something new. It's really important you get used to just how to put meshes into a world and get it looking right, how to get lighting to come through and look nice, and how to get everything set up. So I'd highly recommend you kind of check everything out and just practice. So please do this just once more and then move on to the next lesson. So it's time to create our pinball project. I want you to open up the engine once more, but this time I want you to go to New Project and go to Blank. And we're going to create ourselves a new blank project to build from. So I'm just going to go here, and I'm also going to set up down the bottom. I'm going to tell it to save to a specific folder, and I'm going to name the project Pinball. I'm also going to say no starter content because it's not really necessary given that I've provided assets for this, and maximum quality in desktop is fine. So with blank selected and this selected, I'm going to click Create Project, and now we're just going to wait for it to load up. Now that the project's loaded up, you can see that once again we're greeted with a completely empty interface. We have nothing really here apart from a player start, a sky dome, a box, some fog, and a light. Now, in the long run, I'm going to be removing all of these things, but I'm going to keep them around for the time being just for the sake of demonstration. The first thing I'm going to do is in my content browser, I'm going to click on this button here to show the sources panel. Now if you can't see your content browser, go to Window and make sure it's enabled here. Keep in mind that this layout is completely variable. If I didn't want to have something, I could close it, or I can just drag it around and put it wherever I want. I find this to be the simplest way for demonstrating things though, so I'm going to keep mine like this. Now I'm going to right click on my content folder here, and I'm going to go New Folder, and I'm going to call the first one Assets. I'm then going to right click again, New Folder, and I'm going to call this one Blueprints. So to begin with, let's quickly just import the ball mesh that we're going to be using for our pinball. So I'm going to open that up, and I'm just going to import the mesh itself. So by dragging this in, now be aware that you're going to have a little pop-up as you first drag it over that says that it can't accept it, but after about a second or so, it'll turn to something that will allow it. So when I drag this in, I'm just going to set a few things. I'm not going to import materials or textures. I'm also not going to automatically generate collision for the mesh. In this situation, I believe I can just import normals and tangents. Everything else by default should be fine. Yeah. So I'm going to click import. It's going to throw a smoothing group warning for me, but in this situation, it's totally fine. So we're not going to worry about that. So to begin with, we've got ourselves a mesh, but I really want it to look like a pinball, so I'm just very quickly going to whip up a material for it. I'm going to right click, I'm going to go New Material, and I'm just going to call this M_simple metal. Going to double click on that, and we're going to be greeted by this. So luckily our sphere here is actually pretty much identical to our actual pinball sphere. So I'm going to go to this, and I'm going to set this up to be metallic. Now, if I hold down 1 and left click, it's going to add a constant variable. So by 1 and left click, you'll see that it adds this node. Keep in mind that anytime I add any of these things, you can also search for them up here within the palette. Now, the first thing that I'm going to do is I'm going to set this to have a roughness of around 0.25. You can see that the second I set the roughness to a low value, this got incredibly reflective. But I'm going to set this to 0.25. so that it's not quite as reflective as that. I'm also going to set the metallic by default to be a value of 1. And of course, upon doing that, I'm then also going to need to set up a base color. Now, I could drop in a number the same way I did for these two by again holding 1 and left clicking, or alternatively, I could actually make it something that can be modified outside of this within Blueprint itself. So something that could be changed in-game for one reason or another. So to do that, I'm going to hold down V instead and left click. Now, if you don't want to use the keyboard shortcuts, you can always type in the word vector param, and you'll see the vector parameter can be just dragged in. Now, a vector parameter gives you a couple of output pins here. Essentially, I read into it a red, green, blue, and alpha value, and it will output me things. But you'll notice that again, there's an extra channel. So how this works is the red, green, and blue channels all respond to their colors. This bottom gray channel refers to the alpha channel, and this top white node actually outputs the color, so it outputs the combination of these nodes together. So by plugging this in, the top one, into base color, I'm going to go to here, I'm going to name it color, and I'm also going to click here and just give it a base color. Probably going to set it up to be a little dark. That's good enough. And if we wanted to, we could theoretically tint it as well, but I don't actually want to tint it because I want my pinballs to look reasonably just gray. So I've hit OK, and we've got ourselves a simple metal. So now if I hit save, I'm going to go back to my ball sphere, and I'm going to double click on it. Now, the first thing that's worth noting is that the material is not applied. So I'm going to go up to here, and I'm going to apply it. Now, here's the thing with this right now. If I was to go and drop this in the world, it's actually not going to let me tell it that it's a physics object. See how down here this is grayed out? Now, the reason it's doing that right now is because I didn't import collision when I imported the ball. And the reason I didn't import collision was because if I imported collision, it would try and wrap a squared off shape around my perfectly spherical object. And instead, what I'm going to do here is go collision, add sphere simplified collision. And that's now going to add a nice simplified spherical collision to my mesh. If I go back into here and I click on this, you'll now see that simulate physics is actually an option. Now, the reason that I'm setting things up this way first is so I can quickly demonstrate a point. And that is that if I tick simulate physics and I click simulate, you'll see that the ball just drops to the ground. Now, the problem is that if I wanted to make an actual pinball map, I would really need to have a nice angle to correctly get the ball bouncing and then adhering to the ground. And, you know, that would work. There's nothing inherently wrong with that, except for the fact that it does make it a whole lot more difficult to create levels that are at an arbitrary angle. So what I'm going to do instead is I'm going to develop a flat level, and then I'm always going to give the ball velocity towards the bottom of my screen. So this is where Blueprint comes in, and we're going to have to create ourselves an actual object. So we're going to have to create ourselves an actor in the world that has certain properties that we're feeding information to. So I'm going to go to my Blueprints folder, I'm going to right click, and I'm going to click New Blueprint Class, and I'm going to create an actor. I'm going to call this BP underscore ball. Now when we create our first blueprint, we can open it up by double clicking on it. Now, if I go to the viewport class, this is where we control any of the components that are being added to the world, and we can get a good idea of what it's actually doing. So we can see it within here and move things around, change where things are located, and really make sure that everything looks correct without having to test it in the world over and over again. The first thing that we need to do is make sure that this has a mesh applied to it. See, at the moment it has this simple white ball, but that's not actually a ball. If I was to drag this into the world and hit play, we can't see anything. It's purely there for the sake of us knowing where the blueprint is if it's just code-based. So I'm going to go to here and I'm going to add a component, and the component that I'm going to add is going to be a mesh. Specifically, it's going to be a static mesh. So I'm going to click here and I'm going to call this ball. I'm also going to go ahead and, at the moment, this is the scene root and the ball bases its position on the scene root. I don't actually want that to happen. Instead, I want the ball to be the root of the scene, so anything that's ever added to this will be based off of the ball's position. So I'm going to drag the ball upwards, and it's now going to make it the root component. Now, obviously, our ball's missing something, you know, the actual mesh. So to get that, we go to the right-hand side here, and in our details panel, I'm going to click here, and I'm going to select ball sphere. And there we have our ball. Now, with our ball added, what I'm going to go ahead and do is, by default, we want it to simulate physics. So I'm going to enable that. There are other things that we will need to change later on, but for the time being, this is all we need to have within the world. So if I go back here, you can now see that that actor that was in the world is now actually my ball blueprint. And if I hit play, it'll fall to the ground because it knows to simulate physics by default. Now, when it comes to Blueprint script, it's very important to know that there are two areas that you can work with. You've got the construction script and the event graph. Now, the construction script handles all of the things that you would want to run when a Blueprint class is created. For instance, you may want to run script so that when I add a fence actor to the world, it executes that script and then automatically creates a fence to the nearest wall. Now, the event graph, it contains all of the code relating to gameplay events. So the event graph is typically what you would use in most cases when you're making something in Blueprint. Now, within the event graph, you've got two things that are very important that you keep note of. You have begin play, which runs before the initial gameplay tick of the actor. So this is the event that fires the second the game begins, or if the game's already running, it's the event that fires the second that actor kind of enters play. The other thing that's important to note is tick, because tick is the function that runs once per frame per actor. Now, this can be disabled, but essentially what this means is that after begin play has run, tick runs, and every single frame, so every single time the computer is updating, it ticks every actor again and again and again. And what's also very important is that the time between ticks, so the time between your computer updating all of the actors again and again, is called the delta time. Now what I'm going to be doing here is I'm going to go to my event graph and I'm going to actually go and modify the function called tick, because I want this to always be moving in a very specific direction. Now, because ticks have a variable associated with them, that is that we never know exactly how long a tick is going to be between now and the previous tick, we have a nice little thing called delta seconds, which is what we use for controlling that. So what we're going to be doing here is I'm going to go and right click, and every single tick we want to add an impulse. Okay, so I'm going to type add impulse, and it's automatically going to give me anything associated with the words add impulse. And in this situation, the one that I really just want to add is going to be simply add impulse ball. And you can see that by default, not only is it added the node, but it's also, because ball was in brackets, it's gone and added this as a reference. So what this essentially means is when something touches this pin here, the exec pin, it's going to add an impulse that's given in this category here to the ball. Okay? Now, what I want to do is I want to tell it how much of an impulse to add. So the thing with doing that makes this kind of tricky is that by default I want that impulse to always be I want it to be roughly 2,000 units downwards every second. But that means that I'm not actually going to be adding 2,000 units downwards every tick. Instead, I'm going to be adding 2,000 multiplied by the fraction of the second that it is. If for some strange reason tick was, say, half a second, it would be 0.5 seconds multiplied by 2,000 is how much of an impulse we would be adding. So in this situation, what I'm going to do is I'm going to create a variable that is simply going to be called default speed. I'm going to set the variable to be a vector, and it's not going to let me do anything with that variable, but that's okay. If I click compile, you can now see that these have all been filled in. Now the default speed that I want is going to be negative 2,000. So I'm going to drag that into the world, and when I drag it into my event graph, you can see that I can select get or I can select set. In this case, I want to get the value of default speed, and all I'm going to do is multiply the output of tick. So I'm going to type in an asterisk, which gives me the multiply symbol, which allows me to go, I want to multiply a float by a vector. Okay. Now the reason for that is that delta seconds is what's called a float. So there are two types of standard numbers that you can really store. You've got integers, which refer to whole numbers, and floats, which refer to numbers that can have a decimal place. In this case, I'm going to go delta, so vector times float. And when I click on that, you can see that it's added a nice little function here that allows me to multiply a green variable against a yellow one. So I'm going to connect these two, and then I'm going to plug that into my impulse. Just going to rotate these around a bit so it's a bit nicer. If at any stage you want this to be prettier, you can double click on the wire itself, and it'll give you a reroute node for you to arrange things nicer. I'm then going to connect the exec pin to add impulse. And the final thing that I'm going to do is say velocity change, which essentially says ignore any of the actual mass of the object, just make sure that this is the value that it gets to, and whether it's big or small, move at that speed. So with all of that said and done, I'm going to hit compile and save, and I'm going to add the ball to the world, and I'm going to hit play. And you can see that immediately it's flying off down the y-axis. So the next thing that's worth noting here is that while the ball, when you hit play, does fly off in a straight line, it doesn't do a particularly great job of really adhering to the surface. Now, there's a couple of ways we could accomplish this. A lot of people would jump to the conclusion that it would be a good idea to set the mass scale up and force it to be a heavier object. There's a couple of ways to do that, but because we're making a game, I kind of don't want to deal with it as far as mass goes, because that can have some other ramifications that just could be problematic. I'll give you an example of what I'm talking about here. So I'm just going to place these, and if I hit play, when it shoots off, you can now see it kind of does that, which isn't really what we want. Instead, what I would like is to set it up so that the ball, it at all times looks down at the surface that it's on, and it tries to stick to that surface and adhere to it as best as it can. So I'll show you how to actually do that. The first thing that I'm going to do is I'm going to go into my ball again, so I'm in my event graph, and I'm going to go ahead and I'm going to do that very first step, which was I had to check what was beneath the ball itself. And the way to do that is what's called a line trace. So in this case, I'm going to do a line trace by channel. I'm going to put it over here. And all a line trace by channel does is we've got a start position and an end position. And if it hits something between those two positions, it's going to return a value for me to inspect it more closely and get information from it. Now in this instance, the things that I need are rather simple. I need to start this line check from my own position, so this actor's position. So I'm going to type in get actor location. And you can see we've got this thing here that says get actor location. If I click on that, that now gives me a node that gets the actor's location. So that gets the ball's location in world space. Now you can see that we need to trace to a location, and I need to trace downwards. Now within Unreal, X is forwards, Y is sideways, and Z is up and down. So what I actually need to do is get my current location and subtract, say, 500 units from it, and then trace to that location. So all I need to do here is subtract. See here, it now says this number, subtract 500, is going to be my end position. And if I want to preview that, I can actually set the draw debug lines up. So if I type in persistent and hit play, you'll see what I'm talking about. See those lines coming out beneath it? Those are all of the checks. And you can see that along the way, it's left these to say exactly where the surface was that it was hitting. Now that we have information about what's beneath us, let's use it. So to do that, I need to go ahead and look at the hit result. So see this thing here that says out hit? I'm going to drag off of that, and I'm going to type in the word break. I'm going to break the hit result, and you can now see that when we collide with the ground, I'm able to now get all of this information. And in this instance, all I really want to do is, once again, in the same way that I added an impulse, I'm going to click on this, and I'm going to hit Control W to duplicate it. I could type in just the word add impulse, but you'll find that there's a lot of copying and pasting going on with Blueprint, so it's good to get into the habits. So I'm going to get this, and I'm going to tell the line trace to add an impulse. The next thing I'm going to do is, unlike before, where this was connected to ball, I didn't copy the ball reference. So I'm going to make sure I drop that in again. So I'm going to go up to the top here, select ball, and drag it in. I'm then going to connect that to the target so that the thing that we're adding an impulse to is the ball. I'm now going to go ahead and I'm going to get the impact normal of hit test, and I'm going to multiply it by -1. Essentially, the impact normal is the direction in world space of the trace test. So by getting that and then multiplying that against an arbitrarily large number that we can use, I'm going to multiply it by a float. Before, we created a variable for the default speed, I'm going to go ahead and create a variable again, and this one's just going to be called table stickiness. I'm going to set that to be a float. I have to compile it to get it to appear, so I've compiled it. I'm now going to type in, say, let's make it super sticky to start with. See what happens. We're going to set it to 5,000. And in the same way before that I multiplied this number against delta, I'm once again going to get this. So the stickiness, I just dragged it in. Float by float. I'm going to multiply it against delta again. This is rather ugly, so I'm going to double click on the line to add a reroute node. Now I got this set up. I'm going to multiply that against my impact normal, which means get the direction of the line trace and try and stick yourself in that direction. I'm going to hit compile, save, and you can now see that it immediately stuck down. In fact, it's doing such a good job of sticking down that it can't even make it over things like this. But that's okay. So that's going to be a number that we're going to tweak a bit as we go on and develop the project. 5,000 is probably a good enough starting number, because if I was to add this and this, you can now see that we've got something that correctly kind of sticks around until there's no more surface to stick to. Because once there's no more surface to stick to, it's no longer trying to put a negative value to itself. It's no longer trying to shoot itself downwards. Okay, so with that, we've now got basically almost everything we would be really using for the ball. So I'm going to save it. And we're now going to move on to looking at some more gameplay related things. So we've got ourselves a moving pinball, but it would be a good idea for us to actually have some sort of environment going on that we could test with. So it's at this stage that I'm going to delete everything that's there. I'm going to drag in a box. I'm going to set the box's location to be 0, 0, 0. And I'm going to set it to be 3600 by 2600. Oops, sorry. On the x-axis, 2600. So I have an environment that looks like this at the moment. The next thing I'm going to do is I'm going to drag in another box. And again, I'm going to set it to 0, 0, 0. But this time around, I'm going to change the dimensions just a little bit. And this is going to be 3400. Sorry, 2400. And this will be 3400. You'll notice that it's just on the inside of the box here. I'm going to change this from additive to subtractive so that we have ourselves some nice walls. And then I'm going to set the Z to be... Actually, I'm not even going to set it on the Z on that one. I'm going to click on the outside box. I'm going to go to geometry mode, which is this button just up here. I'm going to click on the bottom, and I'm going to set my snap grid to 100, and I'm just going to bring this down just one square. So we've now got a basic environment, and it would be a good idea for us to start getting an idea of how our camera should be functioning. So for a quick, I feel like this just needs to be noted just in case anyone's familiar with Unreal and they're unsure as to why I'm taking this approach. Normally within Unreal, when you have a player character, you actually have two aspects to any character in the world. You've got a controller and then you've got the pawn. Now, the controller refers to kind of the brain of the object. So in the context of a player, the controller is going to be the thing that handles all of the inputs, whereas the pawn is kind of like the body. So the controller sends messages to the pawn, and the pawn knows what to do. Now, in this situation, I'm actually not going to have a player pawn, because it's simply not necessary in a pinball game. Instead, what I'm going to do is I'm going to go up to my modes panel, and I'm going to type in the word camera. I'm going to drag the camera into the world, and I'm going to set it as 0 on the x-axis. I'm going to drag it up. And I'm going to go ahead and just rotate it around 90 degrees. I'm going to look down at our pinball map. So we have something like that happening. Position it as best as I can for the time being. And then if I scroll down here, you'll see that there's an option that says Auto Activate for Player. And I'm just going to set that to be Player 0. And now, when I hit play, you'll notice that the camera automatically snaps to this location. In addition to this, I no longer have the piloting controls that I had when I hit play earlier. So with this setup, I'm now going to go about actually creating some more things within this world. think it would be a good idea for us to start moving on to bumpers. So working on the bumpers essentially involves us creating a new blueprint that's going to be something we can place in the world. Now, when the bumper is touched, first off, it's going to launch the ball away from it. The next thing that the bumper is going to do is it's going to flash up, it's going to change color, and it's going to have a little section on the bumper that kind of moves down and up every time it gets hit. As well as that, we're going to have some illumination kind of coming out of it, so just a dynamic light. So I'm going to go ahead and actually set one of those up now. So the first part of adding the bumper in is going to the Assets folder, and I'm going to import the static meshes into this location. Now there are two that we care about. There's the bump mechanism itself, as well as the pop bumper base. So once again, I'm going to load up the folder that I had and start importing these assets. I'm going to scroll down until I get to SM pop bumper base and pop bumper mechanism. I'm going to control click on both, and then I'm just going to drag these into the Assets folder. Once again, I'm actually going to not generate collision for these meshes, so I'm going to leave this unchecked. Again, because they're kind of round objects, we want them acting a certain way. I'm going to make sure it's set up correctly and just go through the motions myself. The next thing, everything else is set correctly, so I'm just going to hit import all. And now that they're in, you can see that we have these two meshes. So we've got this, which is going to be the main bumper. Things go under it and hit it. And then we've got this, which is going to be underneath it, popping up and down. So I'm going to go and right click, and I'm going to create a new blueprint class, but I'm going to do it in my blueprints folder. Nickel for every time I nearly messed that up. So go to there, blueprint class, and I'm going to create a new blueprint actor. And this is going to be called BP_bumper. I'm going to double click on the bumper, and you can now see that we've got a simple empty blueprint. So first thing that I'm going to do is going to add a static mesh. And I'm going to drag this over the top of the scene root so it becomes the scene root. I'm also going to click F2, which allows me to rename the object, and I'm going to call this bumper mesh. I'm going to set this now to be the bumper base. I'm now going to add another component, which again is a static mesh, and this is going to be called bumper mechanism. I'm going to set this to be the mechanism. And you can see that it's here. And essentially whenever this gets hit, it's going to go ding and pop down. So I'm going to leave that where it is for just the time being and get everything set up. Compile, save. So if I go off and I look at the bumper base, so I'm inside of the static mesh of the bumper. If you're trying to get there, you can do so by going to Assets and double clicking on the mesh itself. I'm going to go and add collision to the mesh. Now if I hit the collision button, you can see that we have complex collision that looks like this. But realistically, I'm going to be setting up a thin capsule on the inside that is one part of the collision, and around the top, which is another. But I'm also going to have an overlap region that is about here, that is going to be the thing that whenever the ball enters that region, it's going to get imparted with a force. So the great part of this is that if I go to here and I set enable collision to false on this bottom section, and we're only going to do this for just a minute, and I hit collision, auto convex collision, and I create it, it's actually only going to automatically generate collision for this top area. Now the collision that generated there isn't fantastic, but it will probably do for the top. I'm now going to re-enable collision on the bottom area, and instead of generating collision on that, I'm going to go collision, and I'm going to add myself simple capsule collision. And for the capsule collision, I'm just going to hit the spacebar to get to my scale widget. I'm just going to set this up to be just that inner section. And the reason I'm doing it this way again is because I kind of only actually want to have a hard collision around this outside, whereas overlap is going to be the rest of it. And the auto-generated collision can be a little bit nasty on these kind of objects. Whenever something's round, you really want to either make it correctly externally or do it by hand inside the engine. So that's our bumper base. I'm now going to go back to the bumper and into my event graph. So I'm in the blueprint of the bumper event graph, and I'm now just going to set this up. And the great part is setting something up like this is relatively easy. All I'm going to do is, when something overlaps the region that we want, we're going to go ahead and check if it's a ball. So to check if something is anything else, I'm going to get I'm going to right click here. I'm going to type in the word cast to ball. Now, essentially, a cast to a ball, cast to anything tries to verify that it is that kind of object that's being read into it. So it checks if the other actor is a ball, and if it is a ball, it fires this pin. If it's not a ball, it fires this pin. So I'm going to connect this up, and I'm going to say, if it's a ball, we want to run the function called bump. Now, I haven't created a bump function yet. I could just have a massive sprawl of code coming off to the side here, but I'm not going to do that. Instead, I'm going to right click here. I'm going to type in the word custom event, and I'm just going to add a custom event. And I'm going to call this bump. And you'll now see that if I go to here, I can drag off of this pin, off the execute pin at the very top, type in the word bump, and it now says, if it's a ball, do bump. Okay. Now the other thing that I'm gonna have to set up here is if whenever the bump function is called, I want it to actually read in a reference to the thing that we want to bump. So I'm gonna add a new input pin by clicking there and adding a new input, and I'm gonna type in the word ball, and I'm gonna click reference. I'm gonna name it ball. So essentially what this means now is on begin overlap, so the second something is overlapping us, so it's in a region that counts as an overlap, check if it's a ball. Is it a ball? Can I connect these two pins? Is it a ball? Yes, okay. And then do a bump on it. And a bump here is actually relatively easy. All we need to do is essentially get the direction between this and the ball, and then multiply it by whatever impulse level we really want to give it. So I'll give you an example of that. I want to add impulse, and I'm going to add, actually I'm going to drag off the ball and type add impulse. And essentially what we're doing here is on bump, get a reference to the ball mesh of the ball. And all I want to do is read in a direction that we want to send it in. Now, to get that direction, there's actually a really nice way to do it. Essentially, we need to look at our location and the ball's location and find out what direction that is. All I have to do that is type in get actor location, and that gets my location. Now, the next thing I need to do is again, get actor location. This time I can just click on this and again hit Control W, which duplicates it. But instead of the target being self, I want the target to be the ball. So see how that's set up now? I then just drag off of this and I type in get direction. You see there's this function called get unit direction vector. I'm going to connect the two up to each other. At which point I'm going to go ahead and I'm going to say multiply this by a number. So I'm going to multiply this by 2,500. That'll do. And I'm going to plug that into the impulse. And that's now going to send an impulse of 2,500 in the direction from the bumper to the ball, into the ball. We're also going to check velocity change. Don't forget that one. It's very easy to make. So with this added, the next part that we need to add is I'm going to go to my viewport again. And I'm going to add a component. And all this component is going to be is very simple. I'm going to add capsule collision. And I'm going to set the capsule collision to be a radius of, oops, sorry, I got to set the height up as well. Doesn't matter if it goes into the ground. I'm just going to set this up quickly as, say, 200 by, you know what, 100 is probably good, but I'm going to call it 120 so it just bumps almost immediately. I'm going to set the half height as well to be 180. There you go. So with this, I'm also going to double check that it's set up correctly. I can see that it's set to overlap all dynamic. So at the moment this is set to overlap anything that goes into it. In this case, I actually only really care if the thing that it's overlapping is a physics body. So I'm going to click this button and tell it to ignore everything that isn't a physics body, and I'm going to tell it to overlap just the physics body. Okay? If I now hit compile, all I need to do from this point in is go to my blueprints, and I'm going to drop in the bumper and just add it here. Then hit play, and you can see that it got pinged off of it. So I'm going to add a couple of these by alt dragging just into the scene, so you can kind of get a better idea of what's going on. World's easiest game of pinball right now. Ding, ding. That was a good trick. You can see that each one though is kind of just propelling it outwards. Ding, 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 ding. Cool. So we've got ourselves a basic setup. Just gonna put my camera somewhere a bit nicer. There we go. And we've now got ourselves the initial part of a functioning bumper. But for us to keep going on this, we really want to set up the rest of it. So we want to give it the following things. We want to have a sound that plays. We want to have the movement, and we want to have the light. And as well as that, we want to actually set up the bumper to have something nice on it. So let's begin with setting it up as an actual actor. So setting up a material and such. I'm going to go to my assets, and I'm going to go to that folder. And once again, I'm going to this time go to textures, and I'm going to drag in the texture for the bumper. So the texture for the bumper is just here under T, pop bumper top. I'm going to drag that in. And I'm going to right click here and I'm going to create a new material called m_bumper. So I'm going to open this up. And now we're going to just set this up very quickly. So because we want to add a texture, I could type in the word texture and look for it, but again, I'm going to take the shortcut of holding down T and left clicking, which adds a texture sample. I'm then going to click here and tell it that the texture that we want is T bumper top. Now, this looks wrong, right? Like this doesn't seem correct. It's just a bright red texture. However, remember before I said that we have red, green, blue, and alpha? So alpha, if we look at it in this case, actually stores that. So this alpha channel is what we're going to use to set up our bumpers. And it's going to be controlled by a couple of parameters so that every bumper can be distinctive if we want it to be. And this is going to be reasonably straightforward. I'm going to essentially use this to control a blend between two different colors for the base. And as well as that, I'm going to use this as something to drive the emissive parameter that controls whether it's like lighting up or not. So I'm going to click L to add what's called a linear interpolation. Again, I can do that by going up here and type in linear interp. Now, a linear interp is very straightforward. You've got three parameters, A, B, and alpha. Now, in this situation, I'm going to run the alpha into the alpha, and all this does is wherever this texture is black, it will make whatever color we want it to be. And wherever it's white, B will be whatever color we say. So I'm going to plug this into here, and you'll notice that nothing changes. And that's because by default, a lerp blends between 0 and 1, or black and white. So I'm going to hold down V to add a vector parameter, which is going to be my first color. I'm going to hold down V and add another one. And then I'm just going to quickly name these base color. And this can be logo color. And I'm going to set my logo color by default to be, let's go with a blue. That'll do. I'm going to plug that into B. You can see that we've got that. And I'm going to set the base color by default to be white. That'll do. Going with a slightly grayer color, but that's fine. I'm going to hit apply. Now, the other thing that I said that I wanted was something to control the like how bright the emissive was on it, and that's going to be rather simple. For the time being, I'm going to just use the logo colors color as the emissive color. So I'm going to drag off of this, and I'm going to multiply it. You can also hold down M as a shortcut. I'm going to multiply it by a parameter that says whether it should currently be lit or not. So I'm going to hold down S to add a scalar parameter, which means a parameter that's driven by just one single number. I'm going to call this emissive boost. And the other thing that I'm going to do, so if I right click on this and hit start preview, you can see that by default it's blue multiplied by 0 is equal to 0. It's equal to black. If I change emissive boost to 1, we get this. But that's not actually what I want. If you think about it, I then need to multiply what we have here against the alpha texture and if I right click on this and preview, we now get this instead. So only this blue bit will be emissive, and if I tell it to be very bright, it'll pop up like this. So we've got our emissive boost that's going to come out like that, and if I plug this into emissive color and I stop previewing, you'll see that it now looks like that when it's lit up, if that's a value of 20, and if it's not lit up, it'll just look like that. One thing that's probably going to look kind of nice here but be reasonably subtle is typically when something like that is lighting up beneath the surface, it's going to have a rather smooth level of roughness. So the last thing that I'm going to do here is simply, I'm going to hold down L to add another linear interpolate or lerp. I'm going to plug the alpha in, I'm going to plug that into the roughness, and all I'm going to say is I'm going to click on this because I don't think this really needs to be parameterized. I'm going to click on this and I'm going to say whenever you are, I'm going to preview it so I can see it clearer. Whenever you are the logo, I want you to have a bright roughness of 0.25, and whenever you're just the rest of it, 1's probably fine. You can now see that we get this nice shine going across the blue, which I think will look a little bit better later on. So that's it that we really need for our material. Make sure that by default your emissive boost is set to 0 so that you don't run into issues. I'm going to hit apply, I'm going to save it, I'm then going to go to here, and I'm just going to apply the material to the top. So I'm going to set this up as the bumper. By default, this actually just grabs the outsides on that part, so it's fine. I'm then going to do it again, bumper. You now see that we've got that set up nicely. If I hit save and I look in the world, you can see that these are all in there. However, we do have the issue that because of where the camera is located in my situation, these are all actually upside down. So I'm just going to control click on all of them, and I'm going to set the default yaw value to be 180, which flips them around 180 degrees. So that's our base setup for a bumper. Let's go through and add the last little bits to it from here in the next lesson. So coming up next, we're going to be looking at the component changes as well as adding lights to it. So I'm going to go back to my BP bumper and we're going to start setting things up in here. We've got our add impulse all set up, so we know it's kind of sending the ball away from it, but let's go ahead and actually get the rest of it working. Now, the first thing that I'm going to do with this is I'm going to go and I'm going to create a timeline. So a timeline is particularly useful because essentially what it is your way of kind of creating a mini graph of time versus a variable and letting it drive parameters within any blueprint that you create. That'll make more sense in just a second. So I'm going to drag off of add impulse and I'm going to look for timeline. I'm going to type add timeline and I'm just going to call this bump lerp. Cool. And if I double click on that, well actually before I do, I just want you to see what's going on. On add impulse, we call play. I'm actually going to change this to be play from the start. So on add impulse, we play from the start. If you're looking to disconnect these, by the way, it's alt click, or alternatively you can control click and then put it elsewhere. And anyway, I'm now going to double click and I'm going to load this up, and you can see up the top that I can add different tracks. And the track that I want to add is going to be very simple. It's just going to control a 0 to a 1, essentially. So it only needs to be a float. It doesn't need to be a vector or anything of the sort. So I'm going to click add float track, and I'm just going to call this bump alpha. Okay, and my bump alpha is going to be reasonably straightforward. We basically want it to say start, so I'm going to right click and add a key, and I'm going to say at 0 seconds in, I want you to have a value of 0. And by the time we hit half a second, I actually want you to be 0 as well, so it returns to 0. And in the middle, I'm going to add a key, and I'm going to say that at, say, 0.15 seconds, you want to be a value of 1. Now that's currently how that looks. It's a straight line up and a straight line down. So as this plays, the number that's getting output from it will start as 0, go up to 1, and then back to 0 again. But you'll notice that it's not really a smooth transition. It's just like, that'd be very jerky. So the quickest way to fix that is just to right click and set it to auto. You can also do so by pressing 1 on the keyboard when you click on it. So I've set these to auto, and you can now see that it's got at least a little bit of a nicer curve there to create that. And if I go back to my event graph, you can now see that there's an output called bump alpha. And what this means is when update is running, bump alpha is always going to be changing. So we're going to use that to just drive different parameters within our bumper. Now this is a very useful technique that we use all the time in different areas of Unreal. So in this case, the first thing that I actually want to do is I want to make the bumper mechanism that we added to it pop down and pop up again. And this is going to be rather simple. All I'm going to do is I'm going to drag off of update and I'm going to type in relative location. And you'll see that we can do set relative location of a bumper mechanism. Going to drag that in, and what this means is that my bumper mechanism, if it's got a location of 0, 0, 0, that means it's exactly where it started. But I then want to essentially kind of move it down and then move it up again. So the quickest way for me to do that is going to be to drag back from this new location and set a lerp. And now I know the values ahead of time, so I'm just going to tell you, I'm going to set the B value of, the Z value of B to be -70. And essentially what this means is that when bump alpha is equal to 0, so when this is equal to 0, this bumper mechanism is going to have a relative location of 0, 0, 0. So it's going to be located right here. But as this plays and this bump alpha goes a higher number up to 1, when this is equal to 1, the bumper is going to drop to a location of -70, at which point it's then going to go back to here again. So we've now set ourselves up with a rather simple bumper that should work. I'm going to compile and save, and I'm also going to change my camera position so it's a bit easier for you to see what's going on. So I'm going to just drop it. That should do. And I'm going to hit play. And now can you see that happening? The little section is kind of dropping out. I'll hit play again. Ding, pops out, and then each time it reverts up again. Which is fantastic, because that's exactly what we wanted it to do. Now we've driven one parameter, but let's drive some more. So the next parameter that I want to push is I'm going to go back to my viewport, and I'm going to add a light, and it's going to be a point light. So we've added a point light component, and if I was to just hit compile and look at it in the world, point light component's not going to be visible. And the reason it's not going to be visible is that it's getting shadowed by itself. See, there's nothing out here, but if I was to look on the inside of the object, it's super bright in just the middle. So the reason for that's rather simple. If I go to the bumper, I can see that by default my point light is located at the ground, and it's right there. So I'm going to just drag it up a little bit, first off. I'm also going to tell it not to bother casting a shadow. We just want it to just project out into the world. So if I hit compile and I look in the world again, you can now see that there's a soft white glow around each of these. But I actually don't want that glow right now. I only want, I'm going to close these down. I only want that white glow as it's getting hit. So you can see that by default there's a value called intensity. And what I essentially want to do is, by default, I want this light to be off, so an intensity of 0. And then we're going to drag that intensity up to 5,000 and then back to 0 again. So I'm going to go back to my event graph, and this time I'm going to get my point light, I'm going to drag it in, and I'm going to type in the word intensity, because I know that's what I want to change. And you can see right here that we have set intensity. So I've connected that up, and at the moment this is setting my intensity to 0. But once again, I'm going to drag off, type in lerp, and this time I'm going to again connect it to the alpha. Because it's getting a little messy, I'm going to add a reroute node by double clicking, and I'm going to say 0 to 5,000. So now when it hasn't been hit, it's not visible, and then when it's full brightness, it'll be at 5,000. Compile, save. So you can see that the light is now turned off, but as we're playing, whenever they get hit, see that little flash coming out around it? Wonderful. So the next thing that we want to do is change the bumper's color on the top to be flashing as well. Because at the moment our light is projecting light around it, but this isn't being that nice emissive blue that we were talking about having. So let's set that up. Now this requires one extra step to go ahead before we can blurb that number, and that is that we need to actually create what's called a material instance dynamic, which is that because each of these is using the same shader right now, if we wanted to change a variable to be like brighter and then darker again, it's actually not going to work because we need to create a dynamic instance that solely applies to that one bumper. So each bumper has an individual set of parameters so that they can be different brightness levels to each other according to where they are when they're getting hit. So to do that, I'm going to go to my bumper, and this time I'm going to go into my construction script. Now, all I have to do here is rather simple. I'm going to drag in my bumper mesh, and all I'm going to do is drag off of it and type in create dynamic. And you'll see that we have this nice little function here called create dynamic material instance. And all this does is it automatically gets the element index that you've specified, it creates a dynamic material instance of it, and then it applies it to the mesh. Now in this case, I want to use element index 1. Make sure you're using element index 1 and not 0, otherwise it's not going to work because they're different material channels. So 1 refers to the top section of the mesh, whereas 0 refers to the base of it. Now upon doing that, I'm also actually just going to store a reference to this material, the dynamic material, just because it's going to make my life easier later. So I'm going to right click on that and I'm going to promote it to a variable. And the variable is just going to be called bumper top mid. Mid stands for material instance dynamic. So we've got that. I'm going to compile and save. So to set this up, I drag my bumper top mid in and I say get that reference. And all I want to do is set a scalar parameter, which refers to an individual number, which in this case is our emissive boost. So I'm going to type in the word emissive boost, which is what I call the variable. And I want you to be a value of what? Well, let's again drag off of this, add a lerp. I'm going to hook it up to this reroute node. And I'm going to say I want you to sample between 0 and I think 20 should be a reasonably nice brightness. Compile, save, play. You can now see they flash up. They have a nice effect. Now, the other thing that I want to do here is I want to have a nice sound effect that plays too. So I'm going to drag these nodes across and I'm going to add a new thing just in the middle here. And that is, if I type in play sound, you can see that we have spawn sound attached, which just allows me to go ahead and give a sound that will then play. So I've added this between the timeline and the impulse. And the reason being is that if I added, oops, I clicked on that. If I added spawn sound attached to the update parameter, it would play it literally every millisecond that this was updating, which would be horrible. We only want to play the sound one time. So I'm going to go back to my content browser, to the assets folder, and I'm going to import the sounds. I'm actually going to make a new folder and call it sounds within assets. So I'm literally just going to click the top, hold shift and click the bottom, and I'm just going to drag these straight in. Now how these sounds effectively work is these are all sound waves, but we don't want to play a sound wave, we want to play a sound cue. Don't get me wrong, if I click on this, it'll play. But essentially a sound cue is a way of us setting up sounds so that they can be a little bit more dynamic than just playing the pre-recorded sound. So I'm going to go and I'm going to right click and I'm going to make myself a new sound. I'm going to make a new sound cue. And I'm just going to call this bumper hit. I'm going to double click it and it will open up the sound cue editor. So you can see here that we have an output and then an empty area. I'm going to go back to my content browser for just a second and I'm going to select the impact punches. So I've held down shift and clicked on all of them. And if I go back to bumper hit and I right click, there's now the ability to hit random multiple waves. This will automatically add references to each of those sound effects and it will randomly pick one, which if I plug into my output, it's now going to randomly choose a different sound every time. So it's going to choose them. Now, I'm also going to drag off of this, and I'm going to type in modulator. I'm going to connect that up. And all this is going to do is it's going to slightly modify the pitch and the volume just a little bit every time they play, so that it doesn't sound like 4 sounds being randomly selected, but for, you know, a rather large range of sounds. So we've got the sound cue made, and all I need to do now is in my bumper, under sound, I'm going to go to bumper hit, compile, save, and if I was to play, one other thing I had to do. So the last thing that I need to do is in my bumper, see it says spawn sound attached? It's actually asking me where to play the sound, what to attach it to. And I'm just going to get my bumper mesh and I'm just going to attach it so that it plays at the bumper mesh's location. Compile, save, and now if I watch it, it's now going to play a sound, light up, motion's going to trigger each time, and we've got ourselves a nice little touch. So at the moment we've got all of our visual effects tied together. However, we haven't done any scoring. I'm not going to do that just yet. Instead, I'm going to move on to the next asset. So we've created bumpers and we've created the ball and we have ourselves a very basic environment. But for obvious reasons, this isn't exactly adding the core part of any game engine, which is, you know, some form of interactivity. So it's a good idea for us to start looking at how we're going to go about doing that. Now, the first step when it comes to creating a pinball game and adding interactivity, I mean, the most obvious thing is for us to add flippers. So let's go about doing that. I'm going to go to my blueprints folder and I'm going to create a new blueprint class. This is going to be called, it's going to be an actor, and it's going to be called Flipper. Now, Flipper is going to require one thing that we have yet to import, which is a mesh. So I'm going to go to my assets folder, and I'm just going to drag in the Flipper mesh. This is one of those ones that I actually do want the auto-generated collision to be enabled, so I'm just going to check that box. I'm now going to hit import. And we've got ourselves a basic flipper. Now, I'm going to go open up the flipper blueprint, and I'm going to look at it in the viewport. So add component, add static mesh, and we now have a 3D model representing the flipper. If I go to here, I'm going to go click, and there's our base model. Now you'll see that the pivot point, which is where the object rotates from, is located there, and the flipper itself comes along here. Now, here's the first trick that we're going to have with the flippers. Whenever I click the flip button, I really want to do the same thing, regardless of whether it's on the left side or whether it's on the right side. So what we're going to be doing is basically creating a setup such that if I tell the flipper that it's a left flipper, it's going to be here. But if it's a right flipper, it's going to be over here and facing inside this way. So the easiest way for us to do that is with the construction script. Now, another thing that you'll notice that I've done here is that unlike with the previous objects where I set the static mesh component to be the root component of the blueprint, I haven't in this case. And the reason for that is that I want this to be a stable, the default scene root, to be a stable anchor point that the flipper itself is going to be rotating from. So with that in mind, what I'm going to do is open up the construction script. And we're now going to have a quick experiment with what happens if I get my flipper, I drag it in, and I try setting the relative scale to be -1, 1. At the moment by default the scale on this object is 1, 1, 1, but in the construction script I'm now going to plug this in and set this up to be -1, 1. I'm going to go to my viewport and hit compile. Now you should have seen what just happened there, which is that the object itself flipped because the x-axis, which is the red axis, has now been inverted, which results in all of the areas that would be up here to be over here. So this is a useful technique for us creating a mirrored object, but I really want to have some way of identifying if this is the left or the right. So this is going to be our first introduction to enums. Now within the blueprints folder, I'm going to create something else here. I'm going to go new blueprints and I'm going to create an enumeration. Now an enum, in this case it's going to be called flip type. I'm going to double click on it. Essentially allows me to add some values that will be present in any drop box where this enum is set as a value. So I'm going to create a left and I'm going to create a right enum. And that's all I'm going to really need for the time being. So I've got left and I've got right set up as values. To do that, if you missed it, I just clicked the new button on the top right here. Now back in Flipper, I'm now going to add a variable, which is going to be called flip type, and I'm going to set it to be of data type. Okay. And you'll see that when I compile it, we now have a drop-down box that has the two variables that I just created, left and right. And all I'm going to do here is in my construction script, I'm going to disconnect my current set relative scale. I'm going to drag in my flip type. I'm going to get it. I'm now going to drag off of it and type in the word switch. And what this essentially is going to do for us is when the construction script runs, it's going to say, is it the left or is it the right? If it's the right, flip it. If it's the left, keep it as it is. The other thing that I'm going to do is I'm going to check this little button here, which allows it to be editable as an item that's actually placed in the world. And what I mean by that is if I look at the flipper in the world now, so I've just dragged it in, you'll notice that on the right hand side here, flip type is now a variable. And if I click that and set it to right or left, it's now going to change accordingly. So we have ourselves a flip type, but at the moment it's only controlling the scale of the thing. But if you think about it, we also wanted to control the rotation of the object as well, so that when it's left, it flips up this way to hit, but when it's right, it flips up this way to hit, which is actually an inverse rotation. So again, we can do something a little bit cheeky here, and that is we can use the switch on flip type, or we can use a select node. Now, the first thing that I need to do to get this set up is I'm going to quickly just pull these across to make it a little bit neater. I'm going to go create a variable. I'm going to add variable, and this is just going to be called start rotation. I'm going to set it to be a rotator variable. And I'm now going to duplicate that, but this one is now going to be end rotation. Now that I've added the two rotation variables, I'm going to set them up. So remember that I can't enter any information there until I've compiled the blueprint, so I'm just going to click compile. And I'm going to set my start rotation to be equal to, this is going to be 20 when it's the left flipper, and it's going to be negative 20 when it's the right flipper. Now, I could use this branch over here to kind of do a couple of extra set nodes, but another way that I could do it is if I drag in start rotation, and I click set, I can drag in. Now you can also hold down the Alt key to just drag it in without having to do that entire extra click. I'm going to drag these two up, and I'm just going to quickly rig this up. So I'm going to set the two rotation variables. Now at the moment it's setting them to 0, 0, which isn't what I want. What I actually want instead is I'm going to drag off of this, and I'm going to type in select. And what select does is, given a certain wildcard entry, it will choose the option according to what's plugged into there. So by that I mean that if I get flip type as an example, I get it and I plug it into the wildcard entry, notice that these two options rename themselves to left and right. Now what this means is that if left is plugged in, it's going to be set to 0, 0, I'm going to set that to 20, and if right is plugged in, negative 20. So now I've got that, I'm just going to do the same thing over here for end rotation. But I'm going to flip these two around so that one of them goes from negative 20 to 20. Fantastic. Compile, save, wonderful. Now that we've got those two in there, the other thing that I'm going to do is I'm just going to set the current relative rotation to be whatever the start rotation has been set as. So I'm going to get this, I'm going to drag in a reference to my flipper, I'm going to call set rotation, and the one that we're after is set relative rotation. And the new rotation is going to be equal to the start rotation. Again, if you're dragging in a variable and you don't want to click on things, you can hold down Control for a get or Alt for a set. So now that start rotation is plugged in, if I go to my viewport and I hit compile, you'll notice that it automatically flipped down to the ready position. And it's going to go up to here whenever we hit the flip button later on. But we haven't added that functionality just yet. So that's our basic construction script setup. Let's now go to the event graph and quickly get in the final part of the flipper so that we can get everything working. I'm going to go to my event graph, and what we're going to do is make two custom functions, one called flip, custom event is what I typed in. I'm now going to type in the word flip, and I'm also going to create another custom event, and this is going to be called flop. And all I'm going to do is I'm going to get my flipper, I'm going to drag it in, and I'm going to do what's called move component to. Now this is a very useful little function that for some reason doesn't get a whole lot of use by a lot of people. I think it's kind of just snuck past. But essentially the move component to function is when you call move, it's going to gradually, over a given time period, in this case by default it's set to 0.2, go from where it is to the location and rotation that you've requested it to go to. And you just don't need to think about it afterwards. So you kind of just call that and it will cleanly start moving in and moving out. Now the reason that we're doing this is we're going to tell the flipper on move to rotate to our end rotation, which has been set in the construction script. So I'm going to do control drag. I'm just going to plug this in, and it's probably a good idea for us to also add in a better flip time. At the moment it's going to be set to 0.2. This is something that we might want to change, so I'm just going to right click on that and promote it to a variable, and I'm just going to call this flip time. So we've got flip time in there. Again, I can't change it until I hit compile. Now it's in there. I'm also, just while I'm at it really quickly, going to add a flop, which is the exact same thing as what I just did, except instead of it being the end rotation, so I'm going to hit Control W to duplicate. Instead of it being the end rotation, we now want it to be going back to the start rotation. So a quick way to demonstrate this is let's tell the game that when it begins, flip it, wait a second, flop it, wait a second, and then repeat. This will give us a nice demonstration of the functionality. So all I'm going to do here is on begin play, which again is when the game starts up, I'm going to call flip, which is now going to be present as a function. After flipping, I'm going to call delay, which waits a given amount of time. In this case, I'm just going to wait 1 second, sounds good. And I'm now going to call, after the delay, flop. Oops, flop. The other thing that I'm going to do here is I'm going to add another delay, and I'm just going to be kind of cheeky. This is just for the sake of testing, and plug this into here. This will get deleted in just a moment, but it'll help us kind of demonstrate what's going on for the time being. So we're now going to just continuously run this cycle over and over again. And if I hit compile and simulate, you can now see it's flipping and it's flopping. And if this was equal to, if I stop, and if I was to set this to be a right one and hit play, you can now see that it's flipping and flopping the other way around instead, which is correct behavior. Fantastic. So we've got our flippers in there. It's time for us to now look at how we can activate this functionality from the player controller itself. I'm going to quickly delete these nodes so that they don't get in the way. And what I'm going to do from here is start looking at how a player controller can accept input from the player and pass them on to flippers within the world. So we're almost done with this flipper, however we still have something left to do. And that is, if I look at this in here, or if I drop it into the world, we can clearly see that, it's pretty ugly. So let's go ahead and actually fix that. What I'm going to be going to do is just creating a very simple material that we're going to share across a bunch of the assets in this project. It's just a very, very, very simple plastic material that we're going to create. So essentially, all I need you to do is we're going to go assets, I'm going to right click, and I'm going to create a new material. And this is just going to be called m_simple plastic. And simple plastic is just going to be roughness value. So I held down 1 and I left clicked to add a constant. I'm going to set that to 0.1. If I plug that into roughness, you can now see that we get this nice smooth effect. I'm then going to add a vector parameter. So again, I'm going to hold V. And once more, I'm going to name it color. And I'm going to plug that into my base color. I'm also just going to give it a nice simple base color that can be our default color that we use across the board. I'm going to go for something that's kind of a lighter blue, I think. It's nice. Okay. Save. Now the reason I've gone off and created this with a vector parameter is we're going to need a couple of different plastic types. So I'm going to right click on the material that we've created, simple plastic, and I'm going to create what's called a material instance. I'm going to rename it to mi_simple plastic. Now, it's essentially the exact same material as what we've already created. However, it lets us change any of the parameters in it into anything else. So what I'm going to do here is I'm going to make this one yellow. And if I double click it, you'll see that the color parameter has been exposed here. So if I click color, I can now set it to any type of color that we really want. In this case, I'm going to go for it's pretty yellow. Save. I'm also going to make a generic white one as well. So I'm just going to duplicate the existing instance. Instead of calling it _yellow, it's going to be white. It's nice. Save. And now in the flipper mesh, I'm simply going to set this up to have white top and yellow on the inside, which I think will look okay. Actually, I might go the other way around now that I think about it. Yellow and white. Just going to save that. You can now see that we have something that's a bit more obvious in the world for us to flip around. And again, this is represented nicely inside of the asset itself and in the blueprint. So the next section that we're going to be adding is going to be adding the functionality for the player to actually control the flippers so we can start to get a game together. It's time for us to start adding functionality and make this more of a game. I'm going to quickly just delete some of these because, you know, there's a couple too many. I'm also going to drag in the flippers. And remember that when you drag in the right flipper, to click over here and click right and not just rotate it. I'm just going to set these apart. That looks like a pretty good space for pinball. And it would probably be a good idea for me to go geometry. I'm going to drag in a box. And I'm just going to go ahead and set this up. Oh, actually, bring back to there. Bring you up to here. And then I'm just going to set these up as a quick downward angle so that if any ball hits the sides, it kind of rolls down into ours, which is okay. I'm going to click on that. I'm going to alt drag it across. And then I'm going to right click and I'm going to go to transform and I'm going to mirror it on the x-axis, which will make it identical but flipped. And that means that all of this can be correctly aligned as well. Tempted to pull these 50 units in just as a stickler. Again, okay, geometry mode. I'm going to click on these 2 points. I'm going to move them 50 units in as well. Okay, so we have ourselves a workable playing field that we can use. The other thing that I'm going to do here is I'm going to add an extra flipper that's up here. One of those common things that you do get in pinball is that quite often you actually have 2 flippers being bound to a single button. So when I click left flipper, both of these would fire. Now, we have a few things that we need to do from here on in. We need to create a player controller that will detect the flippers and then move them when buttons are pressed. We also need to tell the game that the player controller that we've created is the player controller that we should be using by default. Finally, we need to set up some inputs that will bind the buttons correctly to left flipper and right flipper. So I'm going to start by creating a player controller. I'm going to right click and I'm going to create a new blueprint. And it's going to be a player controller blueprint. I'm going to call this pinball player controller. I'm going to double click on it. Now that it's open, we're going to have to do a few things. First off, we need to create a function or an event that's going to go out and detect all of the flippers that are currently in the map. Once it's done that, we want it to break it into two buckets. We want to have left flippers and right flippers. So this will be two arrays that we're going to be creating that will be essentially lists of flippers. So to do this, I'm going to right click and create a custom event. This custom event is going to be called detect flippers. And all I'm going to do here is I'm going to drag off of it and type in get actors of class. Essentially what get actors of class does is it goes through the world and looks for anything that is a specific class. So if I say get all flippers, it's going to return a list of flippers. Now in this situation, what we want to do is for each loop, which means go through the list, and for every item in this list, run the function off of loop body. When it's done, run the completed pin. So it keeps firing up here until it's gone through every flipper, and then it will fire down here. So in this situation, what I want to do is I want to, for each of these, I want to look at the flipper and I want to check the flip type. So I'm going to get the flip type and I'm going to do a switch. So essentially I'm going to, for every element in the list, look if it's a left flipper or a right flipper. Now if it's a left flipper, what we're going to be doing is creating an array of left flippers and adding it. If it's a right flippers. So the nicest way for me to do this is going to go variable. I'm going to call this variable left flippers. I'm then going to type in the word flipper, and if it's blue, then it's correctly set up as a list of flipper references. However, what we want to do is click on this little button here to turn it into a array of left flippers. I'm now going to duplicate that and call this right flippers. And all I need to do is, if it's a left flipper, get the array and add to the array. Now don't forget when doing this that to add something to an array, it doesn't just add anything. You need to actually connect this to the array element that's being read. So I'm just going to make this a little bit neater. So that add node is now adding this current array element that we're looking at to the left flippers array. At which point I want to do the same thing for the right flippers. So connect that. Connect that, oops, and I'm going to drag this in and connect that too. So now I have left flippers and right flippers getting read in. So now we've got all of the flippers being stored. The next step is for us to actually create inputs for these. So I'm going to go to my project settings by going Edit, Project Settings, and I'm going to go to Input. I'm going to click here to add an action mapping. And the action mapping that I'm going to add is called left flipper. And it's going to be bound to left control. Left flipper, left control. I'm going to add a new one called right flipper. And it's going to be bound to right control. Oops, CTRL. So we now have two keys that we can use on the keyboard for left and right flipper. I'm going to go back to my player controller. And if I right click and type in left flipper, you can now see that there's an action event that exists for left flipper, which is the input action for left flipper. And all we want this to do is when someone presses the left flipper button, we look at our list of flippers. We do a for loop on them, so for each. And all we say is we want every flipper to flip. And if they release it, we want to do the same thing, so I'm going to hit Control W and duplicate. Except instead of flipping, we want to call the flop function that we created. Now, this looks like it would work right now, however we're missing a very important step. This is very easy to miss. I'm going to hit Compile and Save. I need to actually create a game mode and set this as the default player controller of that game mode. So I'm going to go back to Pinball. I'm going to go to my Blueprints folder, and I'm going to right click and create another blueprint class that's based on the game mode base. Now the game mode base is where we do all of the game mode instructions. So this is where you would do things such as calculating overall team scores, for instance. Or in this situation, what we're going to be doing is telling it that if they're playing this type of game, make sure they're using a pinball player controller. So I'm going to call this pinball game mode. And I'm going to open it up and go to the event graph. Now, if I look at this, I can see on the right-hand side that by default, it has a whole bunch of different classes that the game mode knows should exist, and they're all set to the defaults. However, I don't want the defaults. I want to set the player controller class to be a pinball player controller. I'm going to compile and save it, and then within my project settings, I'm going to go to Maps and Modes, and I'm going to tell it to use the pinball game mode. Now, upon doing so, there's really only one thing that we have left to do. I'm going to go back to pinball, and I'm going to open up my player controller, and that function that we created before, detect flippers, I'm going to tell it in begin play to detect flippers, which means when my player controller first exists, look around the world for flippers. It's going to add them to its arrays, and then when the player presses a button, flip or flop accordingly. I'm going to now hit play, and you can now see that my flippers are going up and down. They're also incredibly slow. So I'm just very quickly going to change that value for flip time, which by default was 0.2. I'm just going to set its default to 0.02 as a quick test. That was probably too quick. We've now got ourselves the basics of a game. I'm really quickly now going to go into my pinball controller, and much like with the left flipper, I'm going to go through and create the right flipper. I'm just going to Control W across that entire function. If you drag right flippers over the top of left flippers, you can actually change it from the left flipper to the right flipper array node. I'm now going to go input, right flipper, and I'm simply going to tell this on pressed and on released, do this. And now, we have ourselves the basics of the game. Again, flip time I'm not entirely happy with, so I'm going to tinker with these numbers and find something good. I advise you to do the same, find something that works best with the environment that you've set up, and we'll go from there. So now that we have flippers and bumpers working, it's time for us to move on to the next dynamic element, which is the plunger. So we want to actually add that piece that launches the ball into the game. Now, in doing this, we're going to need to expand our level just a little bit to have that initial channel that the ball moves through. Upon doing so, we're going to then work on actually importing the plunger, as well as setting up all of its functionality, so that when the player holds down the spacebar, the plunger charges up, and upon release, it fires the ball away. So to begin with this, I'm going to go into my assets folder, and I'm going to import the plunger mesh. So for this, I'm going to again just keep all of the defaults. I'm not going to import materials or textures, and just keep it as it is, and I'm just going to click import. Now upon importing it, I'm going to open it up and just quickly check out the collision, because the thing with the collision here is that we really only need actually kind of a box collision around it. It doesn't need to be this full shape. And the reason for that is I want to make sure that the thing that's launching the ball is never going to have any potential to hit an edge around the outside of this front part here. So I'm actually going to remove the collision that we generated. I'm going to go collision, and I'm just going to add box simplified collision, which adds this for us, which in this context is going to work quite well for us. I'm going to hit save. And now I'm going to quickly modify the map. So at the moment, if we were to launch the ball, it would need to be in some sort of channel on one side. In this situation, what I'm going to be doing is adding a channel just along here, and we're going to expect the plunger to be around this region here. So to do this, the quickest way for me to do it is to get this box that we've already created, and I'm just going to go ahead and expand it just a little bit in geometry mode. So I'm going to click on this edge, and I'm going to pull it out 50, 100, 150, 200 units, just in case. That should be nice. Now we can see how thin the ball itself actually is. I'm going to just use this, since it's in the map at the moment, to kind of size up how wide the channel really needs to be. My gut says we may need an extra couple of centimeters on either side just in case. So I'm going to go and have a channel that's to within about 10 or 20 units of either side here, maybe a little bit more. So we'll quickly carve that out. Again, I'm going to do a subtraction brush. So I'm going to get box geometry, I'm just going to drag it in. The quickest way for me to handle this is actually just going to be subtractive and then move it sideways and figure out where we want this to be. Now, that actually works surprisingly well as an initial default value, so I'm just going to roll with that. Now that that's in, I'm going to get that, and I'm just going to drag this down to the length that we want it to be. I'd say we probably want our plunger to start about there, and we really want that ball to get ejected at the very top. So I'm going to put that here. Finally, I'm going to need to make sure that when the ball comes up, it's going to come out this no matter what. So we really want to make sure that the edge here is going to be in some way, shape or form slanted so that it can eject all the way out. Now there's a couple of different ways that we could do this. I'm going to start by just extruding this face here. I'm going to push it out about this length. And again, I'm going to click here. I'm going to pull this out just so that it connects. Now, I think the quickest way for us to get an extrusion is actually going to be to delete these two vertices. So I'm going to delete them. At which point I'm going to look at this and I'm going to now make this area that we just deleted into a face. So I'm going to control click on each of these. And then I'm going to hit create. You'll see that that's now gone and created a face for us. So we can now, this should go up. This area could actually still be a little bit slanted, so I'm tempted to broaden it up just a notch. So I'm using the Alt 2, 3, and 4 keys to cycle through those modes here. Yeah, I'm just going to move this back just a notch. There's a couple of different ways I could do this, but the quickest is going to be to just select this face and pull it back, just to make sure that we've got a nice opening for it to pop out. I'd say that's alright. That'll most likely do the trick. It could have even been too much, and I could just be being paranoid, but we'll see. So the next thing that we're going to need to do is actually add in some sort of plunger blueprint into this section just here. Now, to add a plunger blueprint, I'm going to go to my blueprint section, I'm going to right click, and I'm going to create myself a new blueprint class. And this is going to be an actor, and I'm just going to call it BP_plunger. Now, fortunately, this is going to be a reasonably simple setup. All I need to do is go to my event graph. I'm going to create two events called charge plunger. Well, sorry, custom events. I'm going to call it charge plunger. And I'm going to make another custom event, which will be known as stop charge. So these can be called from the player controller later. Now, upon doing this, when we go charge the plunger, we want to fire up a timeline. And this timeline is going to be called charge timeline. Now, essentially what it's going to do is gradually move the plunger further and further back until it's stopped into a location. And then when they hit stop charge, we're going to go ahead and do a move component to the initial position over a very short period of time. So charge timeline is going to have a float output that gives it a alpha between starting position and ending position. So I'm going to open this up. I'm going to add a new float track that's just going to be called charge alpha. And this should be reasonably simple. I'm just going to right click and I'm going to right click here. I'm going to add a key, and the first key that I add is going to be at 0, 0, and then the next key is going to be 1 second in. We can be at 1, 1, just ballpark figure. Now keep in mind that you probably want this to be set to auto, so click on a face and hit 1 and 1, and it'll just do that with the keys. If you wanted to have a more custom setup, I could also add more keys in the middle to kind of like make it move quicker at the start and then slower towards the end. Another way to add these keys is to shift click. So I could add this and I could have something that was more like that, you know, we can tinker with it in whatever way we really see fit. Doesn't matter too much here, so go with whatever you think is going to be good. I'm going to go back to my event graph now, and it's at this time that I need to go to my viewport and add a static mesh, which is going to be the moving component. So this is actually going to be called plunger mesh. And I'm just going to set this up to be my plunger. And if you look at this, we essentially want to, as it charges, to move back to here and then fire up again. So to do that, I'm going to go to my event graph, and I'm simply going to do a blend between, just going to take a shot in the dark on how this is going to work, but we're going to lerp a vector between two locations. So this will be 0, 0, 0 is when it's at 0 alpha, and 0, 150, 0 is going to be when it's fully charged. And all I'm going to do is every time this goes to update, I'm going to set the relative location of the plunger mesh. And now that that's hooked up, I'm pretty much good for the creation. This isn't going to have a sound effect or anything like that, but that's okay. Now I'm just going to say that when you go to stop, we're going to do two things. First off, we're going to do a sequence, and the first stage of this sequence is going to be to stop this charge. The next stage is going to be a move component to on the plunger mesh. So I'm actually going to drag this in, control click, and I'm going to type in move components to, and I'm just going to move it to 0, 0. So to do that, I can just leave all of these as default, and I'm going to say I want it to move there in 0.1 seconds. Sounds good. Compile, save. Now the final part in getting this working is just going to be going back to the project settings and adding myself a new bind to handle this. So I'm just going to add an action mapping, and it's going to be called plunger. And by default, I'm going to bind it to the spacebar. And now, if I go to my controller, I'm going to set up how this functions. Pinball player controller. I'm going to right click, and I'm going to go input plunger. Now, if you think about it, to do this, we really need a reference to the current plunger. And the nicest way for us to really do this is actually going to be in that initial function where we have detect flippers. I think it's a good idea for us to create another one that is detect plunger. So I'm going to create a quick custom event, detect plunger, that is just going to do a gets all actors of class. So it's going to look for every plunger in the world, and we're going to get the very first one that it finds, because we don't need any more than that. And I'm going to promote that to a variable called plunger. Now bear in mind that if you do it this way, and there's no plunger in the world, when you press spacebar, it will throw an error, because it's not going to know what to do, because this variable will be set to null if there's nothing in this array. We can fix that with validity checks, or we can fix it with print strings and log messages, but I think for the time being we can leave it and just acknowledge it as a potential thing. So the plunger is going to, on pressed, it is going to call charge plunger, and on released, it's going to call stop charge. So the next thing that we need to do is make sure that our detect plunger function is being called on begin play right after detect flippers. So I'm just going to call detect plunger, and then we really just need to add the plunger to the world. So I'm going to drag that in. I'm going to make it considerably bigger. That's probably too big. 6, I guess. That'll do. Let's have a look at how that goes. Going to add that just very quickly, and I'm going to make the just aligned, sticking out of the end here. And now we should be detecting the plunger. Upon doing so, we're going to be trying to charge it and stop it. One thing that's worth noting is that if I go to the plunger, at the moment this is my setup, and this is actually going to cause a problem, because if I charge the plunger, it's going to play the timeline. And when it plays the timeline, it's going to update its location, and that's all going to be fine. Eventually we're going to stop it, and then it's going to call stop and push it back somewhere. But the timeline will still be in a different location, so that when I hit play next time, it's actually not going to play from where it should be. It'll play from halfway through the timeline. So what I'm going to do instead is I'm going to control click on play and connect that to play from start instead. And now compile, save, play. I can charge up and I can fire into the game, at which point I can then play it. Now that we know it works, there's really only one thing to do, which is to go to assets, and I'm going to load up the plunger, and I'm just going to set its material to be a simple metal. I'm going to save it out, and you can see now that the material is being applied. So if I hit play again, everything works fine. So let's move on to the next section, which is going to be actually setting up all of the game rules so that the ball correctly resets after it makes this mistake. So now that we've created our plunger, let's step through what we need to do for our game mode. The game needs to be able to create a ball, the ball needs to hit the plunger, we launch it, and then it starts bouncing around, at which point eventually the ball's going to end up in this area over here, be destroyed, and be reset. Now, that means that we need a few things. The first thing that I'm going to do is I'm going to create a position that we can get from the plunger that allows us to set where the ball is going to spawn. So we're going to establish a position in space that we can just have a simple widget that says where the ball will begin, and the game mode is going to look for that anytime it needs to create a ball, because us just beginning with the ball in play isn't the best move. So I'm going to open up BP Plunger, and within BP Plunger I'm now just going to add a variable. This variable is going to be called ball location, and I'm going to have it set to be a vector type. Now, if I hit compile and save, and I look at the ball, if I look at the plunger here, everything looks normal. However, if I go back to this and I enable this option for editable, followed by show 3D widget, I'm now able to hit compile, and if I look at this, I can now see that the plunger actually gives me a little widget that I can put anywhere in the world. Now this is very, very useful for me to use. However, I am going to change something. I'm going to set the default value to be around 400. Compile, save. Now, in this instance, this allows us to set the exact location that this ball will be created anytime we want to use this. Now, we need to go ahead and set up one other thing. This vector is storing its location in what's called relative space, which means it's storing it at a coordinate that is the distance from the plunger. However, we need to actually make that into a world position if we want to use it within the game mode, because the game mode needs to know where in the world to spawn it, not where relative to the plunger. That's rather simple to do. I'm now going to create a function. I'm going to go add, and I'm going to call this get ball spawn location. Now this get ball spawn location is going to return one thing. It's going to return the position in the world, so it's going to return a vector that the ball should spawn at. And I'm just going to call that ball spawn lock. Now the other thing that it needs to do is, if I go back to my event graph, these types of functions and these types of functions are different. This type here that doesn't require an exec pin is referred to as a pure function, and that's essentially what we're going to do. We're going to create ourselves a pure function because it doesn't really need to have an exec pin. Things just need to look it up. So to do this, what I'm going to do is I'm going to get the ball location, and then I'm going to run a transform on it. I'm going to run a transform location. Now, with the transform location, how it works is if I read in the transform of an actor, it will then put that into world space. So it gets a relative location, given an actor's transform, it puts it into world space. So for that, all I need to do is get the actor transform of the ball plunger, and then plug that into BP ball spawn. I'm now going to hit compile and save, and I'm going to go ahead and open up, actually before I continue, I'm going to delete this ball from play so we have no confusion. Now I'm going to go through and I'm going to open up the game mode, and all I'm going to do is click on this button that says open full blueprint editor. Blueprint defaults back to this setup if you've never actually added any graph nodes, so don't be too confused. So open full Blueprint editor, and within here, I'm going to create a custom event that's going to be called spawn ball. Now spawn ball is going to get called on begin play, so I'm just going to call that there. So spawn ball is going to get all actors of class of type plunger. It's going to get. If we wanted to spawn multiple balls because of multiple plungers for some reason, we could actually use a for loop here as well, but I'm not going to. Now I'm just going to run the function that we created, which was called get ball spawn location. So at the moment the function looks like this. However, if I delete it, I open up my plunger again, and in this function I tick this checkbox that says pure, compile. I now look at the game mode. If I drag off of this again and type in get ball, you can now see that this is a pure function. So all I need to do is I'm going to drag off of this, and I'm going to call spawn actor from class. What we're going to spawn is a BP ball. And now I need to give the ball a transform. In this situation, I'm just going to split the transform struct pin, and I'm going to connect location to location. Rotation can stay 0 and scale can stay at 1. I don't mind. Now, purely for the sake of testing, I'm going to hit compile, save, and I'm going to play the game. And you'll see that we now have a ball in the game. Now that we know that the ball spawning works, let's go ahead and handle its destruction. When the ball gets destroyed, we want to spawn a new one. Now, in the long run, we're going to be checking how many balls they have left and whether they're allowed to do this or not. But for the time being, let's just do the very simple way. I'm going to drag off of the return value of the spawn actor, which is a reference to the ball that it just created. And again, I'm going to type in bind event destroyed. This is caused by an event dispatcher, which allows me to essentially get a message from the ball when it gets destroyed. So we're going to create a delegate. I'm going to drag off of event, and under add event, I can then add custom event. And you'll see that it gives me this, which is going to be on ball destroyed. It's just a good enough name for it. And all I'm going to do as a quick test is when the ball gets destroyed, I'm going to call spawn ball. Compile and save. Now the next thing that I need to do is find a way to destroy the ball. So I'm going to go back to my world, and I'm going to create a new blueprint, just very quickly. New blueprint class, actor. This is just going to be called ball reset zone. Now my ball reset zone is going to have one thing in it, which is going to be just an overlap component. So I'm going to go into here, and I'm going to add a box collision, and this is going to be called ball overlap region. I'm actually going to make it the root as well. So now that that's in, I'm going to go to my event graph, and on actor begin overlap, I'm going to test if the thing that we're overlapping is a ball. And to do that, I'm going to do a ball cast, so cast to BP ball. So now when something overlaps this zone, it's going to say, hey, is the thing that's just encroached on me a ball? And if it is, let's just destroy it. I'm going to hit compile and save, and then I'm going to quickly add one of these to the world, which is going to sit right there. Now if I want to, I can scale this and modify it as I see fit. In this case I want to stretch it out. It should be fine. I'm going to lift it up a bit just in case as well. Save, play. And now I'm quickly going to test it. So we can see that that works perfectly. The ball got destroyed, and then a new one spawned instantly. So now we have an infinite game of pinball that has no ability to keep score, but we're going the right direction. Let's start looking into getting a functional game mode. We already have the ability to spawn a ball and respawn it, but let's actually start getting a score being calculated and also getting a basic UI up and running. So to begin with, let's work out how to get a score going. I'm going to load up the game mode class, and within here I think it's a good idea for us to look at adding a new function that's going to be the add score function. Now realistically we could at any stage have just a variable inside of the game mode that is the current score. However, it's a good idea for us to have an add score function so that if there are multipliers or anything like that contributing to the current score, anything that wants to increment the score simply reads in the current number of points, the game mode assesses the number of multipliers and anything else like that going on, and goes from there. So I'm going to add a new function. This is going to be called add score. And for this we're going to need a couple of things. So to begin with, we're probably going to want an input that is a float, and this input is going to be the points to add. Now, upon add score getting called, we're going to be having to get the score, multiplying the current points to add against a multiplier value, and then we're going to add that to the current score and set the current score to be that output value. Now that means we need two things that we haven't already created. The first is a score variable for us to add and check. So this is going to be called score, and it's going to be a float. Now after we've got the score, we're also going to want to have something for a multiplier. Now even though it's likely that all of our multipliers will be like 2 times multiplier, 4 times multiplier, 8 times multiplier, it's probably a good idea for us to make this a float as well, just in case. So I'm going to make a variable called multiplier. I'm going to hit compile, and I'm going to make sure that my multiplier by default is set to 1, because if we set that to 0, we're going to have some real trouble. So I've got my score and I've got my multiplier. So all I need to do is get the points to add, multiply it against my current multiplier, so it's going to be multiplied against a float times float, at which point I'm going to drag in multiplier. I'm then going to get this, and I'm going to add this to my current score. So I'm just going to hit plus, and you'll see that we have float plus float. And again, I'm going to drag in the variable and connect it to here. We now have points to add times multiplier plus the current score is going to be equal, and I'm going to drag this in, and I'm going to hold down Alt, so it's a set function, is going to be equal to score. Now that we've done that, it's probably a good idea for us to have an output function so that anything that's adding the current score also has the ability to see what the current score has now become. So I'm just going to add a new output, which is going to be a float, and the value here is just going to be called new score. I'm going to plug this in over here, and I'm going to connect the output of my set to the output of my function. Compile and save, and we now have a working add score function. So it's now time for us to go ahead and work out a way that we can add some score to the game to begin calculating. So I think a good way for us to begin with this is for us to go to the bumpers and just make them add 10 points every time. So I'm going to open up the bumper class, and I'm going to look at this initial bump function that we have going on that adds an impulse. At the moment it adds an impulse, it then spawns the sound attached, at which point it goes through this entire bump loop to make the animation. So it's probably a good idea for us to, before we play the animation, increment the points at about this area here. Now if you think about it, to add the score, we need to get the current game mode, we need to cast the game mode to be a pinball game mode, because that's the only game mode that has the add score functionality to it, and then we need to add some score to it. So to do this, I'm going to right click here and I'm going to get the game mode. At which point I'm going to cast to pinball game mode. Now this could be converted to a pure function if we wanted to, but just in case, I'm going to drag this up here and I'm going to set this up such that if it fails, it goes ahead and does what it normally does. So cast fail calls play from start. However, if it succeeds, we're going to get this and we're going to call add score, and we're going to add 10 points. Now the other thing that I'm going to do, purely as a quick testing variable, is I'm going to print the current score to my screen so I can see it. So I'm going to drag off the exec pin and type in print string. I'm now going to connect this to the play from start. And finally, I'm going to connect my input string, which at the moment is going to say the word hello, to my new score. And it's going to automatically convert from new score to a string and should just put a number on screen every time something is hit. So I'm going to hit compile, save, and then I'm going to play this. You can see in the top left that we just got 10 points, 20 points, 30 points. So the system's working. That said, we are going to have some issues later on when we need to reset the score. But for the time being, this is enough. In the next lesson, we're going to look at adding a UI to properly display this without strings. So, right now, I'm going to quickly remove this print string value and connect add score to the play from start. Compile, save, and we're done. It's time to start looking into how we're going to handle a basic user interface. For the time being, we're only going to be tracking one variable, but we'll expand this later. Initially, what we're going to be tracking is the player's score. Now, in the previous session, we went about setting up a basic print string that was outputting the score to the screen. We removed it because it was purely there for the sake of debugging and identifying that the feature worked. But this time around, let's go ahead and create a new widget that will act as our HUD. So I want you to right-click in your Blueprints folder, go to your user interface, and then go down to Widget Blueprint. Now I'm going to call this Pinball HUD, and this is going to open up UMG. Now there are two areas to UMG. You've got your designer and your graph. Now when you're in your designer, you're able to drop in buttons, checkboxes, progress bars, anything that you want. Now when you're in the graph, you're able to actually set functionality for each of these elements in the same way that you would typically set up something in Blueprint. So it should be very familiar to everyone. In this situation though, we're going to create something reasonably straightforward, which is simply going to output some text. So I'm going to go ahead and drag this text into the screen, not the text box, but the text. Text refers to visible text on screen, whereas text box refers to something that you can enter text into, for example, a high score or a name. So I'm going to drag this text block in, and we're going to set this up so that it's going to be our player score. It's just going to sit in the top left-hand corner of the screen. For the time being, I'm not going to bother customizing any fonts or anything like that. I just want to get the functionality up and running. So I want to go through a few things first though. Now, to begin with, we have this unusual flower-looking icon that's appeared that actually represents the anchor point. Now, this anchor point essentially helps us set it up so that no matter what size the screen is, this item knows where it should be relative to the ratio of its position on the screen. So if I was to put this here, and I was to change the screen size, for instance, to a iPhone 6, you can see that this is still saying that same distance from this corner. If I was to drop out and I was to go to a 1080i, you can see that it's sitting here. So this is very, very useful for us because it lets us make sure that ahead of time this is going to look correct on a number of different monitors and that elements are going to associate themselves with the screen in the correct way. Now, it's a good idea for us to begin by just entering the text that we're likely to have. So I'm going to have score, space, and I'm just going to enter an incredibly big number. And this is going to show us the first issue that we're going to have, which is that our text box is only the size that it was originally dragged in as. And yes, I could drag this out, but it's a better idea for me to check this box that says size to content. Size to content is going to automatically change the size of the box as the content inside of it gets bigger, which does most of our job for us. Now we could also change the justification, but in this case it's not going to be necessary because aligning the text from the left is actually what we want to do. If we were to be developing the HUD from the right hand side of the screen, we may want to justify it this way so that the score gradually pushes towards the center from the right hand side, but for the time being we're fine. Now the next thing that I'm going to do is actually set this up to have some sort of text in it. So what I'm going to do here is I'm going to look at this section that said text, and this is where I entered the value. But next to it we have a nice little button that says bind. This is where we have the option to create a binding, which essentially lets us have a blueprint graph determine what this text should be. Before I do that though, I'm just going to name this to something that's a bit better than what we have as the default. So I'm going to click over here, I'm going to hit F2 to rename, and I'm just going to call this player score, just so we have something that's a bit more understandable when we come back to it later. I'm now going to create a binding on the text, and it's going to load up a graph. So within this function, we essentially have an execute pin, that's going to run through and do whatever logic we want here, and it's going to output a text string. And that text string is whatever it is that we want to have in that text binding. So this is rather straightforward, and that is that all I need to do is right-click and get the game mode. I'm going to cast the game mode to the pinball game mode, which is the one that we've created. Now, I could do this as pure. I probably should. Purely because game modes can be set up in a number of different ways, I'm just going to be very careful here, and I'm going to duplicate the return node. And on failed, I'm going to return an empty string. However, I don't expect it to ever fail. Instead, I'm going to get the pinball game mode, and I'm going to get the score, which is this value here, just get score. And all I need to do from here is, if I connect this to the text node, it's going to automatically convert from float to text. So this would put the number on screen by itself. However, there is another slightly nicer way for us to do this. I'm going to drag off of the text instead, and I'm going to type in the word format. And we get this nice little function called format text, which essentially lets you create a string. So in this case, I'm going to write the word score, colon, space, and then anything that I put into braces, so the squiggly brackets for those unfamiliar, I can go ahead and actually have them as inputs. So I do a brace, I'm going to type in player score, and then a closing brace and hit enter, and it's going to give me this as a variable, which I can now just plug into there, and then connect over here. Now the final stage to getting this working is simply to go to my player controller, and on begin play, I'm going to call a function that says create player HUD, which is going to be a custom event. And this custom event is going to be launched by my begin play. Now all I'm going to do here is I'm going to drag off of create player HUD, and I'm going to set it up such that it initially removes any widgets from the player's current viewport. So if there is a menu or anything on screen, it's going to get rid of that. At which point, after doing that, we're going to create a widget. And the widget that we create is going to be our pinball HUD. We're now going to add to viewport. We can hit compile and save. And if I go pinball and hit play, you can now see that we have the score variable on screen. And every time I hit something, it's going to increase and set itself up correctly. So that's it. That's all it takes to get the beginnings of a working HUD. So now it's time for us to finish the game loop. So to begin this, I'm going to go and open up the pinball game mode. Now within the pinball game mode, if I go back to the event graph, we currently have this very simple onBallDestroyed function being called, which just goes spawn ball whenever the ball gets destroyed. But it's time for us to start looking at putting in some new conditions here to actually set this up well. Now, this condition that we're going to be setting up is going to have to check whether the balls remaining is greater than 0, because if it's equal to 0, they have no balls left, we don't want to spawn anymore. So I'm going to create a new variable, and this is going to be an integer type. Compile and save. So I'm going to set this by default to be equal to 3. So we have 3 balls remaining. And all I'm going to do is on ball_destroyed, what I'm going to set up is a very simple check that just checks the number of balls remaining. And if this is greater than 0, we want to spawn a ball. Now, if this is false, that means that the game is now over. So we need to set up an actual end condition here that can check the data and see whether what we have is a high score or not. So I'm going to go ahead and off of this create a custom event that we're going to call there, which is going to be called endgame. So off of this false, I'm going to call endgame. And now we're going to set this up to actually check how to handle the end of a game. So the first thing that endgame is going to need to do is check our score against the current high scores, which means we need to actually take a step back from this and start setting up the basics of a high score system. Now, to do this, I'm going to go back to my content browser. I'm going to right click and I'm going to create a new blueprint class. This time I'm going to go to all classes and I'm going to type in the word save. And you'll see that we have a save game object that we can base it off of. And this is just going to be called high score save. Now, within the high score save, what we essentially need to do is set up a simple variable that will be storing our list of current high scores, and then we're going to be iterating through that. Now, one of the nice things that Unreal lets you do is not only do we set up basic variables when scores are saved out, but we can also add some simple helper functions that make our lives easier when we want to work with these in the future. So to begin with, we're going to need to create a variable, but if you think about it, we need to actually store more than just one, because we don't want to just store a number, we also want to store a name, which means not only do we need to create a high score save, we also need to look at creating a struct. So once again, I'm going to go back to my pinball project, I'm going to right click, and this time I'm going to go ahead and create under blueprints, you'll see this section called structure. And this is just going to be called high score structs. So when I double click on this, essentially it lets us add as many variables as we want to one section that can all be tied to each other in a single data type. So I'm going to get this, and the first thing I'm going to create is going to be called a variable called name, which is going to hold text. The new variable I'm going to create after that is going to be called score, and it's going to be of type float. So if I go back to pinball, and I open up my high score save again, you can now see that if I add variable and I set this to be save structs, I can now, under the variable type, you'll see that high score struct is actually an option. So I'm going to create that, and I'm going to make sure it's an array. This way we have an array of structs. So we have a list of high scores essentially. So we've set up our in-game data types. So now let's go ahead and look at actually setting up some additional functionality too. So under functions, I'm going to create a new function that is going to be used to determine what the current lowest score in our high scores list is. Now the reason we're using the current lowest score is we want to check whether something is even worthy of making it into the list at all. So I'm going to create a new function, and this function is going to be determine lowest value, score value. Now, this function is going to go through our entire loop, so I'm going to drag in my save struct and set up a for each loop. And all it's going to do is it's going to check the score of each one of these structs. Now you'll notice that at the moment when we see this struct being accessed, it's not showing both of our variables. Instead, it's only outputting the array element by itself, which is the structure. Now there are two ways that I can go ahead and access the information within this. I can either drag off of this and click on break, or alternatively, I can right click on this and I can select split struct so that these variables are both exposed now. So to get this working, because we're just getting the current lowest score, we also probably want to save the lowest index just in case too. I'm going to go ahead and create two local variables. The first one is going to be called lowest score, and the second is going to be called lowest index. Now to do this, all I need to do is I'm going to set lowest score to be a float variable and lowest index to be an integer. I'm going to make sure that they're not arrays, which is currently the default because of the last time we created a variable. Let's do a quick branch. Now, if the index is equal to 0, which means if this is the first time we're running through this loop, we just want to set the lowest score to be equal to that current index, which means the current lowest score is the first member, and the current lowest index is also the matching index for it. On subsequent loops though, this is no longer going to be equal to 0, and we're now going to be checking if the lowest score value that we've already set is less than the lowest score index that we had earlier. So to do that, all I need to do is, if this is false, we want to then do our check for the two scores. So if the current element that we're looking into is less than the lowest score variable, we now do another branch, at which point we then either set the lowest score and lowest index to be those, or we go to the next element. So in this situation, I'm going to hit Control W to duplicate. Now if this is less than lowest score is equal to this again. Now this is starting to get quite messy, as you can see. So it's a good idea for us to kind of set up some nice logical pathways to have everything set out well. So I'm going to start adding reroute nodes by just double clicking and dropping them where I should. Again, for this variable, these are all accessing the same thing, so I'm going to go and pull these down to here. It's going to be pulled down to there, at which point I'm going to do the same thing with this one here too. That is, bring it down to here. It's still not amazing, but it's definitely less chaotic than it was. So again, all we're doing, if we follow this logic through, is the first time we're going, hey, is this the first element of the array? Yes, it is. Okay, set things up. The next time round, we go, hey, is this the first element of the array? No, it's not. Okay, well, is the score currently greater than our known lowest score? Yes, it is. Set it. Otherwise, go to the next thing. So now that we've finished the loop, it's time for us to add a return type. Now, we could output the lowest score, or we could output the lowest index and then access it. However, in my opinion, it's better for us to actually output the struct itself and let users access that as they want to. So to do this, I'm going to output the save struct as well as the index, which is rather simple because all I need to do is on completed, I'm going to select this initial node, and under outputs, I'm going to hit new. And this first one is going to be a struct of the high score struct, and I'm going to call it lowest score struct. And in addition to that, we're also going to output the current known lowest index, just in case we ever need to access it. So I'm going to hit new, and this is going to be called lowest score index. And this is going to be set to an integer type, at which point all I need to do is completed connects to this return node, lowest index connects to here, and lowest struct is the save struct. Hold down control. I'm going to type get, and then connect lowest index with the get and return that struct. So we've created a determine lowest score function, but let's also set up a quick determine highest score. I'm just going to right click and duplicate the existing function and just change the wording. So this is now determine highest score value. To avoid confusion, I'm going to quickly go through and just rename these variables. We now have highest score and highest index. In addition to this, I'm going to change my return to be highest and highest. And finally, all I'm going to do here is in this check where we're saying if the score is currently less than the highest score, we now want to say if the score is currently greater than the highest score. And that's all we require to have that functioning. With our highest score value determined, let's go back to our pinball game mode and work out how we want to work from here. So when the endgame function is called, we want to load the current high scores list and see how it's all working, see what the lowest score is, and determine whether we actually belong in that array. So it means that we need one extra function, which will be used to get the current game save data. So this function is going to be reasonably straightforward. It requires a few things though. It requires a quick setup that allows us to store the current save game data as a variable. So I'm going to create a new variable just called current save object. And this is going to be a high score save object. And now I'm going to create a new function within my game mode, which is just going to be called getSaveGameData. So when getSaveGameData is called, what we're going to be doing is we're going to be checking if the current save object is valid. Now I could drag off this and do isValid and have it set up this way, but one thing I like doing in these situations is right-clicking on it and just converting it to a validated get. So we get the save game data and we check if it's valid. Now if it is valid, then we want to just return it. Simple as that. So I'm going to add a new output, which is here. The output is going to output the current save game object. The type is, say, HighScoreSave, and the param type name is going to be current save object, and I'm just going to output that. Now, on the other hand, if it is not valid, so if the current save data just doesn't exist, then we want to do a very quick thing. Does save game exist? So we're going to check if the save game exists, which is going to require us to have a save game name. Now, I personally like storing this in a variable since it's the kind of thing that we pass around a bit. If you wanted, you could just type it in every time, but let's create a variable. I'm just going to call this HighScoreSaveName. And we're going to quickly compile, and the default HighScoreSaveName is just going to be called, let's go with something simple and just call it HighScore. So we're going to say, does the save game exist? Called HighScore. Now if that's true, then we want to go ahead and load it from the slot. So load game from slot is what it's called. So if it's true, we want to load the game from the slot. Which game? The one that we made the variable for. And after we've done that, we want to cast it to the HighScore save. At which point we could return the save games, or we could sort the save games and then return it to make sure that our high score list is always coming in the correct order. I personally like sorting it in this instance because we're not going to use it very often, so I'm going to set that up and I'll show you how to do that in just a moment. Now the other thing that's worth noting before we go ahead though is to go false. Now if it is false, we want to create a save game object, which is going to be of type HighScoreSave. As before, we want to cast it to a HighScoreSave. And let's set the current save object to be equal to the HighScoreSave. Just going to set it. And I'm going to set it here. Just quickly to get the function up and running. The other thing that I'm going to do is get my return node over here. It's going to Control W and return this. Now obviously it's possible for this loop to actually bail out, so if I wanted to, I could set this up as a pure so that it's always going to push through and cast valid's never going to be an exec pin. Alternatively, I could duplicate this and just return null if either of those fail. They've got no reason to, but it's worth noting that, you know, it's possible. So with that set up, we do probably want to have a quick sort function in there. There's a couple of ways that we could do this. The easiest way is going to be setting up a quick loop inside of our HighScoreSave. Just going to create a function called sort save data. Now to sort something like this, what I essentially want to do is I want to get the current array, at which point I would then create a duplicate array. I would then get the highest value and read it into my new array, remove it from this, drop the new highest value into that, remove it from this, new highest, remove, new highest, remove, and go through it until the array is empty. That's the quickest, easiest way for me to kind of get this going. So I'm going to add that as a simple thing. So to do that, all I need to do is set up a temporary save struct. So I'm going to promote to a local variable called temp save struct. It's good enough. I'm actually not going to set it. I just wanted to create the variable and make sure it was auto set to the correct type. And all I'm going to do here is I'm going to get the save struct and I'm going to do a very simple while loop. So I'm going to get the length of the score, the save struct that we have. I'm going to get the length of that, and I'm going to say if this is greater than 0, while. So how a while function works is it keeps reassessing this here until it's no longer true, at which point it cancels out of the while loop. So in this case, it's going to, because we're going to be removing something from the save struct every time, it's going to keep doing this until the save struct is empty, at which point it's then going to set things up and return things correctly. Now in my situation here, my loop body is going to get the highest value in the save struct. I forgot that I actually don't even need to drag that in because it's part of our thing. So I'm going to determine the highest value, at which point I'm going to add this to my temp save struct. So I'm going to call add, and the thing that we're adding is that struct. At which point from the standard struct array, so the standard array that we have that's holding all of the scores, I'm just going to remove this from there. Type in remove index, which point I'm just going to remove that index there. So this will very simply go through, get the highest value, add it to this, remove the index, go through, highest value, remove index, until we're all set up. At which point the only thing I need to do after that is on complete, I want to tell save struct that it is now equal to my temp save struct. So on complete, we're going to do that. Compile, save. So now my pinball game mode, if I go back to here, the thing that I'm going to sneak in is when loading the data, let's do a quick sort. So before I set it, I'm just going to do a very quick sort, save data on it. And that should be all we need to have a functioning sort for our save game. So from here on in, it's time for us to actually set up the rest of this in-game condition to correctly load the save and work from there. So next up, we're going to be working on the game mode, which means we need to look at the logic that it's going through. Now initially, it's checking when the ball is destroyed, whether it can spawn another one. Now it's either going to spawn a ball or it's going to end the game. When it ends the game, it needs to do some logic based on whether it's currently setting a high score or not, and that's very important. So we're going to call the getSaveGameData function that we've already created. Now after we add this getSaveGameData, what we're now going to do is we're going to check its length. And the reason we're going to check its length is we want to see how many entries are actually in there. Because if it's below a certain number, we know we definitely want to add it. However, if it's equal to the maximum number of entries, then we want to check to see whether we're allowed to go in there or not. So I'm going to do a quick check on the length of the array. So to do that, I'm going to get the save structs, and I'm going to check its length, which returns a number of how many entries are currently in this array. Now let's say at any one time I only want to have 4 save games in there, so 4 high scores saved. I'm going to branch, and if it's less than or it's equal to 3, we know we want to add it. So I'm going to execute this true pin. However, if that's false, I'm going to check one other thing, which is I'm going to check the minimum float, which means we're going to get this, and I'm going to do that check that I had before, which was lowest score value. Just going to quickly tidy this up as I go. So I'm going to check the lowest score value. I'm going to split this struct, and I'm just going to see if this score is less than the current score, that's when we also want to add it. So both of these are going to result in us wanting to add something to the score. So what I'm going to do here is I'm going to make one last thing in my high score save, which is going to be a new function, which is just going to be called addScore. And addScore is going to have an input, which is going to be a struct that we had before, the high score struct. And this is going to be called newScore. Now, we could put the validation inside of this function if we wanted to. It's really up to us how we want to handle this. For the time being, all I'm going to do is I'm going to get the save struct array. I'm going to add this to the save struct array. I'm then going to sort it. So I'm going to call add. I can add the new score to it. At which point I'm going to sort the save data. So I'm going to drag in this function that we created before. After we've sorted the save data, I then want to get this, and I want to set the size to be either the size of 4, or if this current struct is lower than 4, to be equal to that. So either 4 or that. It'll just size up those two numbers and set it to that. So this min function pulls, if I enter two values into it, it gets me the lowest of those two numbers. So this wavelength is somehow over 4. So if it's 5, it'll drop this size down to 4. And because we've sorted this struct in order of highest to lowest, it means that this will remove the remaining things on there. So I'm going to compile, save. Now you've got to be careful here because we've gone ahead and made two functions called add score. One is on the game mode and one is on the pinball game mode. In hindsight, I probably should have named these differently. Actually, I might save that now just in case. So I might actually rename this function to be called add a high score. At this point, we need to now enter that add score function that we created. However, we do have a slight issue. We could hook it up here for the time being and drop in a quick node. However, we haven't actually given the player the ability to enter their name yet. So what we're going to do here is add a very quick widget that will show the high scores currently and give us a little text box to fill in a new one. This is purely for the sake of us having something that we can kind of work with for the time being, and we'll pretty it up later. But for the time being, I'm going to right click, I'm going to go to user interface, and I'm going to create a new widget blueprint that's just going to be called high score entry. And high score entry is going to have a text box that is going to be anchored in the center of the screen. I'm going to set its position to be 0, 0. And because this is now putting it in that bottom left corner, I'm going to set the alignment to be 0.5 and 0.5, which moves it halfway across and halfway up, such that it's now anchored dead center of the screen. I'm also going to size this to content. And I'm going to stretch it out a bit, actually, its default size. So I'm going to drag this out, and I'm going to drag this out. So for the time being, that's going to be just our entry box. And the other thing I'm going to do is add a text box that is going to output the current high scores. So it's going to be set up with an anchor point in the center of the screen. And this is now going to be set as, actually I might just center this out as well. Should be fine. So let's go here. And this will definitely be set to size to content, because this will be high scores dash number. It'll kind of look like this over and over and over again. Instead of what high scores though, it'll be someone's name. So what we're going to do here is when this menu gets loaded up, we're going to create a binding. And this text, which we should really rename, so I'm just going to set this to be called high scores list, and this can be called text entry. In my graph, all I'm going to do is get the game mode. After I get the game mode, I'm going to cast to pinball game mode. Somehow that fails, which it never should. I'm going to return nothing, but if it does succeed, I want it to return a string that is made up of the current save data. Now we can only get into this if the current save object is true, because this is going to get loaded up from that screen. So I'm going to get the current save object, I'm going to run a for loop on it. So I'm going to get structs, for loop, and all I'm going to do is create a new local variable which is just going to be called output text, which is going to be equal to, basically we're going to run through the array, save the current line of text to a buffer, and then go to the next line and add that to the current buffer, and then add that until we're done. So to do that, all I need to do here is I need to get the current array element, and I need to create a format text, which is format text. So this is the function that we used before, that is going to be called name dash score. So see how I put those two in braces? And output text will be equal to, it'll be equal to the current output text with a new line added to it, and this. There's a couple of different ways that you can do this. I personally find that the quickest way is to do this. I used to go old, hold Shift Enter, and then type in new. This is just a really cheeky way to do it, but it works. Which is just going to go get the current array's name and score, and then add that to it. So the name and the score now gets appended into the old one, which is going to be output text. Cool. Compile, save. So that should work, and then at the end of it, it outputs the output text. That'll work as just a super simple list. And finally, the event, if back in the designer, this is going to be where they input their text. And upon entering this into the text, what I'm going to do is, I'm going to go down the bottom, and you can see this on text committed function. I'm going to click plus, and that's going to add that. So now when they hit enter after entering their text, it's now going to do this, which is what we're going to use for our function to call the add high score. So I'm going to get this, and I'm going to get the game mode, cast pinball. I'm going to convert this to a pure because I know this has to be true at this point. I'm going to then get the save object, and I'm going to call that function that we created. And the new score that we enter into it, the text is going to be the name that they just entered, and the score that goes into it is going to be the current score of the game mode. Now this isn't going to exit out after they hit enter right now, so that's going to be a problem, but it's still going to be enough that we can see whether this works or not. So as a very quick thing, what I'm going to do here is I'm going to create a in the same way that we had that function earlier in the player controller that was create HUD, we're going to do the same kind of thing, but this is now going to be to load the high scores list onto their screen. Now there's a couple of ways we could do this. I'm just going to make a custom event here for the time being that's called create high scores lists, which is going to get the current player. So okay, current player gets, type in get controller and you'll get player controller. We know there's only one of them, so I'm just going to get this cast to pinball player controller. I'm going to convert this to pure, and from here I'm going to add a sorry, I want to create a widget for it. So I'm going to type in the word widget. The widget that we're going to be creating is a high score entry, at which point I'm going to add to viewport, and in theory we're going to get something that's going to begin functioning when I plug this in. So off of this true, I'm going to call create high score list, and off of this true I'll do the same, compile, save. So now I'm just going to quickly test that. So I'm just going to let myself die. Ball goes out, new ball comes into play. should be my last one. Oh, okay. We're missing one thing, which is rather straightforward, and that is, at the moment, whenever we go to spawn the ball up here in onBallDestroyed, the thing that we should be doing is decrementing the current balls remaining to have one fewer. So I'm just going to get balls remaining. Now I could do balls remaining is equal to balls remaining minus 1, but I can also actually just type in minus minus, and it will give me this nice little function called decrementInt. If I plug that in, this will now reduce balls remaining over time. So let's test that out. Got our first one. Got our second one. Actually, I should get a quick score just so I've got myself on the list. And this should be our last one. Now this has popped up with our list as we requested, although it has given us another issue, which is that I don't have actually a visible cursor. So I'm going to need to quickly fix that up. So to get that, all I need to do here is, upon creating the high score widget, I'm also going to drag off the player controller, and I'm going to type in the word cursor. And there's a function called setShowMouseCursor. I'm just going to set that to true. You can now see that my mouse cursor appears, and I'm now able to just type in a name. And you can see that upon hitting enter, it's gone off and done this. So the reason for this issue is actually rather simple. I'm going to go to my high score entry, and if I look at the onText committed, there's a nice little switch that I can make off of commit method. So I'm going to tap on the word switch, and all I'm going to do here is I'm going to say that on enter, run the add high score command. So from here to here to here. And now when I compile and save, I'm going to see this. So when I type in a score, it'll have my name hyphen the score. Now it's still missing one very crucial step for a save, in that it's not actually saving yet, which is rather simple. I can actually, from here, call saveGameToSlot, and I can call that saveGame object to get called into the high scores save name. So that will now save it after I play every time and keep an ongoing list of scores. However, we're also missing one other thing, which is upon saving it to the slot, we also want to then remove the high score menu and go to what would now effectively be a main menu. So what I'm going to do is I'm going to go to my pinball game mode, and I'm going to create a custom event, which is just going to be called create main menu. And in much the same way that I created the high scores list, I'm just going to uncheck that. I'm going to hit Control W, just so that we've got this set up. So the other thing that I'm going to do is just right click and type in remove all widgets, so that when we go to create our main menu, it's going to erase anything that's currently there. So now I'm going to look at creating a widget that's never actually going to be directly put onto my viewport. Instead, this is going to be a widget that we can put into other widgets. So this widget that we're creating is going to be a simple high scores widget. So I'm going to right click, and I'm going to create a new user interface, and it's going to be a widget blueprint. And I'm just going to call this high score widget. Now, because I know my functionality is identical to the high score entry board, I'm going to be a little bit cheeky here, and I'm going to go to my high score entry. I'm going to get this, and I'm going to go to the graph and just open up the get text function that we have. And then I'm just going to copy this straight out. So I'm just going to remove that, Control C. And in my high score widget, I'm going to set the screen size here to just be, say, 500 by 500. So I'm going to go to fill screen and just change it to custom. And I'm just going to type in 500 by 500, as that looks like a good enough square that will likely be the size of my widget. You know, just to be safe, actually, I might call it 800 by 800. I'm going to now add a text widget. This is going to be anchored to the top center, and I'm going to position its y-axis to be just beneath the top center here. X position as well, so I'm going to zero it out and instead change the alignment to be 0.5. I'm going to set the justification to be centered. And finally, I'm going to set this to be size to content. I just needed a test value in there. And now with that set up, all I need to do is bind my text as we did before. But this time around, I'm going to hit Control V and just paste in what I had. I'm also going to need to recreate this output text variable that we created before. And if I right click on it, I can now hit Create Local Variable Output Text. Upon hitting compile, this will actually run and should be fine. So now if I go back to my high score entry board that we had before, and I go to my designer and I delete this, you'll notice that if I compile, I can now delete my getText function as well. And in my designer, if I go down to user created, you'll see that we have high score widget here as an option. And if I drag this in, it's now actually got the demo text that I have there as a base. I'm just going to set this to be anchored in the center. And as before, 0, 0, but alignment is 0.5, 0.5. I'll actually move this up just a fraction. And I'm going to check size to content on that as well. And in theory, if I was to hit play, and just quickly, actually I should set a high score just so we've got something on the list. I'm going to enter a name. And we can see that this is actually displaying it correctly in this area now, because this list is actually the widget that I just created that has now gone straight into it. So that's fantastic, because that means that now when I go to create a main menu, I can just drop in a high scores widget. So let's create that main menu. So to create the main menu, I'm just going to right click and go to user interface. And once again, I'm creating a widget blueprint. This is going to be called main menu. And it's going to be set up in a rather straightforward way. I'm going to have some text up top. I'm going to have a button that's going to be my main play button. And I'm going to have a high scores list beneath it. Don't really need to have anything else just yet. I'm going to anchor this. I'm going to anchor all of these to be 0 on the X with an alignment of 0.5. I'm going to put this with the same anchor so that it sits relative to it. But the anchor is going to be top left. So top middle. Zeroed out 0.5. Going to make this quite a large piece of text. So this first piece of text that I add is just going to be the name of the game. Pinball game. It'll do. And I'm going to set this up to be large font. Again, we're going to customize this later and make sure everything looks good, but for the time being, this is really all we need. I've got this. Set its position to be there. Pinball game, the button itself, and now I'm just going to add some text to it. So I'm going to drag the text onto the top of the button, and you can now see that it's added the text here. So there's a couple of different ways I can approach this situation. Right now we're going to be using the button as the thing that we're clicking on, but I don't really want this button visible in the long run. That said, I'll fix that up later when we kind of do a aesthetic pass on this menu. For the time being, all I need to do is set up an on-clicked event so that when someone actually tells this to play, it'll do it. First up, I'm just going to quickly set this text box to say the word play. I'm also going to increase its size to just be a little bit more obvious. Great, and on this I'm going to go to onClicked. Now, this is saying onClicked for button 214. So again, we've done what we did earlier, whereby we hadn't actually named the button. So I'm going to rename this to play button with F2. And in my graph, you'll now see it says onClicked play button. So on play, well, what do we want to do? This is where we need to actually communicate with our game mode and have something actually set up. So within my game mode, I'm going to look at what we have at the moment, and I'm going to work out the best area for us to go from. Now at the moment on begin play, we call spawn ball, and then upon spawning the ball, we do what spawned ball should do. But we never actually have a start game or reset game function being called. So it's probably a good idea for us to set things up to go with that instead. So I'm going to create a custom event just called reset game that is now going to spawn the first ball. So I'm going to disconnect spawn ball from that and instead put it into reset game. And what we're going to do here is when reset game gets called, we're going to spawn the ball, we're going to set the score to 0, we're going to set the multiplier back to 1, we're going to set the balls remaining back to 3. Now if I wanted to, I could actually do get class defaults and then hook these up so that they enter back in there. This way if we ever change the defaults, these will reset themselves. High score name's never getting changed, so I can leave that. But otherwise, this is a simple function that we would have for reset game. That said, spawn ball should probably be called after I set everything else. Otherwise, we're going to try and spawn a ball that's not going to work. So I'm just going to move these across. So on reset game, we're going to be doing this. And as well as this, we're going to be spawning the player HUD when they reset. So I'm going to set this up to now call from the player controller. I'm going to just copy and paste these calls that we have from before. So I'm going to get the player controller. I'm going to cast it to a pinball player controller. At which point I'm going to create player HUD, which is the function that we created before. So when reset game gets called, this is what it's going to do. It's going to essentially start the game. So now I'm going to go to the function that we created earlier, which was create main menu. I'm going to make sure that its widget is correctly set to the main menu widget. And the final element is to go up to begin play, and when the game begins, create the main menu. I'm just going to make sure that everything else has been set up. In my high score entry, after we save the game to the slot, we now want to get the game mode, and we want to create main menu. Trying to neaten things up for us. So we've now got our save game set up correctly. In theory, our game mode is also set up correctly. And when I hit play, we're now going to see pinball game as our main menu. When I click play on this button, it's currently not going to do anything because we haven't hooked it up just yet, but we're nearly there. So if I go to my main menu, on clicked, I'm going to be getting the game mode. I'm going to cast to pinball game mode. And then from here, I'm going to call reset game. Compile, save. So when I hit play, it got rid of it. Now the first issue that it's gone ahead and done is when I hit play, my mouse is still on the screen. So I'm going to make sure that that gets disabled the next time we go around. But apart from that, everything should work fine. I'm going to quickly fix this mouse issue, which is simply the same call that we had before where we did show mouse cursor. I'm now going to make sure is correctly set when we call this on the player. So I'm going to duplicate this. I'm going to plug the target into the player controller. And when we create the player HUD, I'm just going to disable the mouse cursor. So this is in my reset game function. Now the other issue that we haven't addressed yet is if I go to my main menu, into the designer, I have to go down here, and I'm just going to add that high score widget that we created earlier. I'm going to make sure that it's set up, centered from here. And from here, if I go into my pinball game mode, And I see where my main menu is initially created, which is up here. We call create main menu, which then goes down here. What we're not doing yet, that we have already done when we do the high scores list, is we haven't gone and called this get save game data function. So there's a few ways that we could do this, but the easiest way is for us to just call get save game data so that it gets correctly set. So if I was to drop this into here, compile, save, and then hit play, you'll see that all of my scores are listed here correctly now. And I can go ahead and I can play through the game. Just make sure I get a high score. There we go. And then it pops up again. Because I got a new score, I can now enter it. Person. And you'll see that that's now in there. So everything's correctly set up, and we now have a basic gameplay loop. So now it's time for us to actually start adding some more interesting score values and some far more interesting props within the world that we can use to create a more enjoyable game. However, before I do so, I'd like to change a couple of little details around here that are currently going to be causing a bit more overhead than I'd really like. I'm going to go to my high score widget and just change how this little bit is set up. Now, the reason I set it up this way was because I really wanted you to understand how bindings work and that we can output something in a nice, easy fashion, right? But the thing is that you've got to remember with bindings that literally every tick it's going to go through and it's going to reassess this to figure out what it should say. But the truth is that the high score widget only really needs to set its score when it's created and doesn't actually need to set its score at any other stage. So what I'm going to do is go to the getText function and I'm going to rename this to just generates high score text is the new name of it. Now the reason I've done that is in my event graph for the high score widget, after event construct, which is kind of the equivalent of begin play for a widget, I'm going to drag in generate high score text and I'm going to right click and I'm going to hit promote to variable, and this is just going to be called high score text. It's at this point that I'm going to go back to the designer for a moment, click on the high score, and where this says currently that this is bound to generate high score text, I'm just going to remove that binding, and instead I'm going to create a new binding that's going to be far simpler. So simple in fact that it looks like that. So what's going to happen now is when this widget is first created, it's going to figure out what it needs to say, and then from then on it's just going to output that, and it's not going to keep running that loop every time. So you can see that when I hit play here, this is exactly as it should be. But this time we're not adding all of this unnecessary overhead. Now while it didn't matter too much here because it was just a main menu, it is the kind of thing that can really matter when you're doing it with your actual game. So definitely keep it in mind that that's just a slightly nicer way to do some of these things. Just caching initially and then working from there. So we have ourselves a basic win condition loop. When the game's over, it knows what to do if you've won and if you've got a high score. However, we are missing a little detail here, and that is what happens if you lose. So at the moment, if you fail to get a high score, this pin within end game never gets called. So it's a good idea for us to just add that in, otherwise you can have a very boring game once you lose. So to do that, all I need to do is call the function for either reset game to start the game again entirely, or create main menu. In my opinion, it's better for us to go back to the main menu and let them click play to start again. So off of false, I'm just going to drag, I'm going to type in create main menu, I'm now going to compile and save, and when I play the game and I lose, and there we have it. So when I failed to get a top score, I've gone back to this main menu, and everything is great. We have a complete loop that I can begin playing the game again straight away. For this lesson, we're going to be looking into the spline tool. It's one of the most powerful yet underutilized tools within Unreal Engine 4. So for this, I'm going to need to import a couple of extra assets. I'm going to be importing rail end, rail mid, and rail mouth, just to start with. For these, I will auto-generate collision for the time being. We'll see how it performs before assessing whether it's going to work or not. So we have 3 assets. Before going any further, I'm just going to quickly go into these and set some things up. First off, for each one, let's set the material to just be that simple metal. Next, I'm going to check out the actual collision mesh. Now this is definitely not going to do. So for this, I'm going to try generating high hull vertex collision. This is still not amazing, but it'll definitely do for the project. So in this instance, I just had to set the max hull vert up reasonably high to get something that was going to work. I mostly care about an object coming down towards this and then falling. So I'm going to save that, at which point I'm going to open up rail mid, check the collision, delete it. Let's try generating one for this as well. That'll work for us as well. So I'm going to hit save. And then I'm going to go into the last one. Oops, I forgot to set the material on this one. There we go. I'm going to go into rail mouth, which is just a slightly wider version of what we've already got. I'm going to punch up the verts. I'm going to generate on this. Yep, that'll do nicely. I'm going to save. And now it's time for us to start generating the actual blueprint. Oops, and once again, same mistake. Simple metal has to be set. So I'm going to go to blueprints, and I'm going to start looking at how to use an actual construction script. So new blueprint class, once again it's going to be an actor, and I'm going to call this BP_rail. So for BP rail, we're first going to be adding a new component, which will be a spline. So click on add component and type in the word spline. Now there are 2 options here. There's splines and spline meshes. Now a spline refers to a shape that is the actual line that you draw through the world, whereas a spline mesh refers to a single mesh that will be kind of bent to follow a line that's given to it. You give it a start position, an end position, and the directions, and it'll try and warp the mesh to its shape. So in this case we want to add a spline, but later down the track we'll be adding spline meshes programmatically. So I'm going to add a spline, and I'm going to set it to be the root component. And this is what you will see. Now for this initial work, I'm going to get this, and I'm going to drag this out to be slightly longer and make it 300 units long. This will make a little bit more sense in just a moment. I'm also going to right click on this and add a spline point here, where I grab and I'm going to drag this up. So we have kind of like a basic arch. So if you missed what I just did, I right clicked and I hit add spline point here. And this is the shape that you should have on screen. Should be reasonably straightforward. So I'm going to hit compile, save, and I'm going to go to my construction script. Now essentially what I'm going to do here is I'm going to go to my construction script and I'm going to run a for loop. Now this for loop is going to do something that is, it's going to look at this spline and it's going to calculate how many of these points there are in it. Now at the moment we have 3. And for every point that's in there, what we're going to do is iterate through and add a mesh that connects to the next point. Now what this means is that we don't want to count the last point because it doesn't have a point beyond it. So we actually want to do the length minus 1, which means if we're doing a for loop, we're not actually doing length minus 1, we're doing the number of points minus 2 because the index is 0, not 1. So we're counting from 0 instead of counting from 1, which means we get a reference to the spline, we get the number of points, at which point we subtract 2, and I set the last index in our for loop to be the number of points minus 2. Then, for each point, what I need to do is add a spline mesh component. Now for this spline mesh component, what I'm going to be doing is I'm going to be setting this to be the rail. For the time being, I'm going to set all of them to be the rail mid, but I'll work on some better behavior in a moment. So we have the initial spline mesh component. However, we need to go ahead and actually set the rest of this so that it correctly warps along the spline. Now this is where we start looking at the start and end. So I'm going to get this spline mesh and I'm going to drag off of it. I'm going to type in set start, and you'll see that we have a nice function called set start and end. And when we get this, it actually gives me a start position, start tangent, end position, and end tangent. And we need to set these to correspond with our actual mesh, which means what we need to do is, we can just give myself a little more room here. What we need to do is get the point on the spline that we're looking at, get its position and tangent, and then get the next point on the spline that we're looking at and get its position and tangent. So the nice way that we can do this is to actually get a reference to the spline, get point, and you'll see that we have a couple of things here. We have get location and tangent at spline point. And all I need to do is say, at the point index, set that to be the start and the tangent. Now at the index +1, I'm going to duplicate that and reconnect the spline. At the index +1, I'm going to set that position and tangent. At which point, all I need to do is hit compile, save, and if I look in the viewport, you can see that it's actually getting this mesh and it's warping it along it. And if I was to hold down Alt while dragging this out, I'd be able to actually draw a bigger spline into the world. Now I'll show you that in the actual stage. So I'm going to get the rail, I'm going to drag it into here, at which point we see this. Now if I click on the spline ending here, I go to my translation widget, and I drag it to here, you can see that I'm actually able to kind of move along the spline. I can Alt drag to bring in new points, but I can essentially make some really interesting shapes that we can use to kind of feed the bumpers within the game. If I hit go, this is what we would see in this case. So I could set up some really cool stuff that if the ball kind of came into here, it would then roll through and then drop out and do whatever it wants. Now, to get this working well, we need to consider doing a couple of extra things. Now, the first thing that I'm going to do is I'm going to go back to my construction script, and I'm going to look at this spline mesh component, and what I'm going to do instead is I'm going to do a quick check. And what this quick check is going to do is it's going to see if the piece that's there is also the index 0. So I'm going to see if the current index is the index 0. And the reason I'm going to do that is because if it is the index 0, I actually want to set the scale to be a different mesh. So we can have an intro piece, and we can also do the same thing with an outro piece. So we can set the static mesh according to whether it's the first position, the last position, or if it's the mid position. So I'm going to get this spline mesh component, and I'm going to add a simple branch. I'm going to open these up and just pull them down a bit. And all I'm going to do here is, my first condition is checking if it's the first piece. So it's going to be saying, is this index equal to 0? Now if that's true, what we want to do is set the static mesh for this. Space that out just a little bit. We're going to set the static mesh for this and then continue with what we would normally do. And the static mesh is going to be equal, I'm going to promote this to a variable, rail start mesh. And I'm going to set this to be the rail mouth. Now, if this is false, let's then check to see if it's the end piece. And if it's the end piece, we'll do an operation on it as well. So, how do we check if it's the end? That's simple. All we need to do is check if this index is equal to the very last piece that it's going to check through, which is equal to that. At which point, I'm going to duplicate my branch. I'm going to connect this to here. And if this is false, I'm going to set the static mesh. So I'm just going to duplicate this. If that's true, I'm going to set the static mesh of this component to be equal to, it's getting a little bit messy, I should really clean this up. Just going to add a reroute note there and kind of connect it that way. And if this is true, what we want to do is promote this to a variable, and this is going to be called rail end mesh. Compile. I'm going to set this to be rail end. And if that's true, we're going to go straight on through and connect that. And the last piece that I'm going to do is, if this is then false, we're going to set the static mesh to be equal to the general mid piece. So set static mesh. We're going to set the mesh of this target, so that's hooked up. So if that's false, this will then connect through to here. And I'm going to promote this to a variable, which is just going to be called rail mid mesh. Compile, save. And if I look in the viewport now, you can see that the end has this shape. So if I look at what we've got here, oh, I missed a piece. I'm going to go back to my construction script, and I'm going to set the default variable for the rail mid mesh. Compile, save. And if I look at this in the world, I'm going to go into unlit so you can see it a bit better. You can see that this opening has that wide section that we had created for that first mesh, and that the end section now has this cap on it, which means if I wanted to, I could actually have this up here and the ball would still fall out. Which would be some nice behavior, because it would go and then drop. So that's the first section, but let's actually get this working a little bit nicer. There are going to be two extra little features that I'm going to add. The first is that if it's the rail start mesh, I want to have the ability to set a custom scale for the mouth of it. So to do that, all I need to do is get a reference to the current mesh component that we're looking at, which I can get from here. So I'm going to get this, and I'm going to set scale, and I'm going to set the start scale if it is the start mesh. So I'm going to plug that in and plug this into here. Now since that's quite messy, I'm just going to add a reroute node, pull it up and over, and all I'm going to do here is I'm going to split this pin because it's looking for an X and a Y, but realistically I only really care about making it wider. I don't really want to make it taller as well, just wider. So what I'm going to do is I'm going to split that, and I'm going to create a variable. So right click, promote to variable, and this is going to be called initial scale. And the default value here is going to be 1. Now, the next thing that I'm going to do is I'm going to set all of these variables that we've created to be editable. And the reason for that is that by making them editable, I can now modify them from the default properties over here. So let's have a look at what happens when I change these. If I set initial scale to 2, we now create a much wider initial section for the rail to potentially fall into. Sorry, for the ball to potentially fall into. So the ball's going to hit that, and then eventually it's going to get funneled into the rest of it. Now the other cool feature about this is if I go to my assets and I were to get some of these other assets such as plastic ramp and plastic ramp end, as well as general ramp. So I'm just going to import all with default settings. Now with these meshes imported, the reason this is super useful is that if I wanted to, I could set these, just type in the word ramp, and I could set this to be the plastic ramp normal. At which point we've got this. Or I could set it to be the version of it that has, type in the word ramp so I can see them all. I could set this to be the no top version. And then I could set the mid pieces or the end piece to be their own thing as well. So if I go to here, ramp, I could then set this to be no top. At which point we end up with this nice thing where the ball could roll in and then fall through. And it looks like it actually belongs on the stage. And it's something that we can easily then just expand on and modify and do all sorts of weird and wonderful things with it. So again, I can just click there, I can alt drag, and we can have some interesting setups, which is nice. All I need to do to really complete this feature is to set the materials on each of these three things, which I'm going to do very quickly, and set the collision for them. So by default, if I want to look at these, I'm going to quickly check out the collision, which I can see is wrong. I actually don't care about the collision on the top, so what I'm going to do is, for the time being, I'm going to disable collision on the top, and then I'm going to go collision and generate. Actually, I might just try 16, it'll probably be fine on this mesh. Apply, which will generate that. I'm going to re-enable collision, at which point I'm just going to quickly set the materials for each of these things. I'm going to set the roof to be white, I'm going to set the body to be yellow, save, and then I'm going to quickly run through and do that on the other meshes too. This can just be yellow as its general color. The other thing that I'm going to need to do again is check the collision. It's definitely wrong. I'm going to just do an auto generate off 16 as well. I'm going to save, And finally, I'm going to go for the ramp end, which is this one. Oops. Should be yellow. You should be white. Show my collision. Going to delete that. And the one I want to get rid of is this one for the time being. Apply. And now you can see that we're going to have something that'll drop straight through. And we should be all set up. So the last thing that's super important when you set this up, that's very easy to miss, is go add spline mesh component. And I want you to go down here and look for the word collision, because by default collision presets are no collision. Instead, I'm going to set this to block all. Compile, save. Now, when we want to test this at the end, I'm just going to drag in a ball so that we don't actually have to do any extra testing. I'm going to get this, going to drop a ball there so you can see what happens from the get-go. But you can see that the ball rolls in, falls through, and it's all set up. Nice little thing. So this can be used all across the board if you want to create walkways in your map, if you want to create all sorts of interesting things. It could be piping throughout the environment that you don't want to have to custom model and instead put in the hands of your level artist. There's plenty of times that this is going to be very useful. So always keep in mind that it's something that's very easy to create and leverage from. So we're gradually getting through this now. However, the next thing for us to look at is going to be creating a drop target set. So essentially a set of letters that exist within the world that sit along some sort of rail. When each letter is taken out, they eventually give you a multiplier to your overall score from that point on. So the player's aim is going to be to knock down each of these letters. Now, I'm going to use this as a good opportunity to teach you about child actors, which is a great way for us to basically create one actor that can, in its construction script, generate many other actors that will then be placed within the world. So what we're going to do that is we're first off going to create a variable band that is a simple blueprint that will have a starting position, an ending position, and a band between the two. At which point we're then going to have, after the variable band is created, a single drop target created, which is going to be a single object that has a letter on it. And then we're going to create a drop target set, which will be a blueprint that is based upon variable band that will basically create a variable band. You type in a word and it will then automatically create drop targets to the size of that word along its frame. So let's begin. Now the first step that we're going to have is we're going to need to import some assets. And what I'm going to do at this point is I'm going to implement the assets that are called SM post half. And the other one that I'm going to need to make sure that this works is SM band extender. So I'm just going to click on SM post half, and I'm going to scroll up to SM band extender, control click. I'm then just going to drag those two into import all. Default here should be fine. I'm just going to double click and check that the collision on this asset is fine. That should be correct. And also I'm going to go to my band extender, view collision. That'll actually be fine because we never expect the ball to go up or in between these, so that's totally fine. So from here on in, we're going to go to blueprints. I'm going to right click and we're going to create ourselves a new blueprint actor. Now this blueprint actor is essentially going to be running a construction script that will create two ends and then a piece between the two of them. So I'm going to create a new actor and I'm just going to call this BP underscore variable band. Let's open it up. And now, once it's up, let's have a look at what we have here. So at the moment, there's no asset here. It's just the default scene route. So I'm going to add a static mesh component. And this is going to be called post1. So post1 is going to be set to post half, at which point you'll have this. I'm going to compile, save, and then I'm going to go to my construction script. Now within my construction script, what we want to do is we want to essentially have a location in the world that is going to be the post location. We're then going to set post 1's rotation to face that location. We're then going to add a static mesh at that location, which will be the secondary post. And then finally, we're going to add a static mesh that will stretch between the two of them, that will be the band itself. So the first part there is going to be for us to add a variable that will be called post location. And it's going to be a vector. Compile, save. Now this vector is going to be set so that it can be editable. And as well as that, I'm going to show the 3D widget. Finally, I think I'll set the X to be by default 200. Compile, save. Now if I look at what that looks like in the world now, I can drag this in, and you'll see that we have this nice little post location widget here. And I can drag it around, although right now it won't do anything, but that's okay. So the next element is going to be getting this asset, post 1, getting post location, which is the area that we want to work with, where the new post will be created, and essentially all we're going to be doing is set rotation of post 1. You can see that one is called set relative rotation, at which point I'm going to simply drag off of post 1, get relative location, and then there's a nice little function called find look at rotation, and I'm going to connect that to post location. So it's going to find the rotation that is required to look between this position and this position. And if I was to then connect this to here, compile, save, you'll notice that now in the world, wherever I put this part of the widget, this is always going to face it. Do you see how that's rotating to face our actor? So that's the first step. Now that we've done that, we're going to create a new static mesh component. So I'm going to right click and add static mesh component, at which point the relative transform is going to be equal to the post location, and the rotation by default is going to be set up as an opposite of this find look at rotation. So I'm going to get my relative transform, and what I'm going to do is I'm going to drag off of it and type in the word make. Now it needs a few things here. First off, we have a location, which is easy, so I'm going to connect post location to the location. The next section is it's going to require a rotation, so I'm going to get my find look at rotation, but this time instead of looking from the relative location of post 1 to the post location, I'm going to do it the other way around because we're going to be looking backwards. So I'm going to get this, and I'm just going to duplicate these so it's just a little bit cleaner in the graph. Connect those two, and I'm just going to set that as a rotation. So with those two in mind, compile, save. If I was to look at my viewport, we're missing one thing. And what we're missing here is we don't actually have the mesh set. So while I could set this mesh manually by clicking here and then just plugging it in, I think it's a good idea for us to make sure that the two posts always match one another. So I'm going to drag in a reference to post 1, and off of the static mesh component, I'm going to type in set static mesh. At which point, I'm going to connect this to the mesh of post 1. Post 1 is a static mesh component reference. So I need to drag off of that and say get static mesh to find the actual mesh involved. And now, upon connecting those, compile, save, you'll notice that we now have a post here and a post here, and in between them we have nothingness. But they're actually facing one another. So wherever I move this widget to, it's going to automatically face home, which is exactly what we want. So, how do we put the band between them? Well, that's rather simple. If I was to look at the band extender, you can see with how this is set up in the world that this comes directly from here. And what that means is we can actually do an offset directly from that location. So we can add the band extender in and automatically just stretch it across. I'll show you how that's going to work in just a moment. So within variable bend, what we're going to do is we're going to once again add a static mesh component. So I'm going to right click, add static mesh component. I'm going to connect these two up. And all I'm going to do here is I'm going to set this. I know I do want this to always be the band. So I'm going to just set it to band extender. Now its relative transform is going to be the same transform as post 1. So I'm going to get this, drag it in, and I'm just going to say get relative transform. So now that that's set, what I'm going to do is I know band extender is exactly 100 units long. So from here to here is 100 units, which means at a scale of 1 on the x-axis, it is 100 units long, which allows me to do the math backwards to work out what scale it would need to be to connect the two locations. And that's actually rather simple math here. All I need to do is get the static mesh component, and I need to set the relative scale 3D. And the scale is going to be equal to the Y and Z scale. So I'm going to drag off of this transform and just do a break. And I'm going to split the scale, and I'm going to split this scale as well. Now the reason I'm doing this is when I set the scale here, I want my Y scale and my Z scale to be exactly what I had them set as. However, I want my X scale to be equal to, this is where the math comes in, it's going to be equal to post 1's relative location, so that relative location, minus, so vector minus vector, the post location. So by getting those two and subtracting one from the other, and then getting the length, oops, not get path length, get vector length, it actually tells me how long the distance is, like how far the distance is between those two locations. I'm just going to add some reroute nodes here so I can make this a little bit neater. And because that tells me the distance, all I need to do is divide that by 100, which we know is equal to a scale of 1, and connect it to here. Now, compile, save, and if I look at this, you can now see that wherever I put this asset, it's automatically extending the band between those two locations, which is fantastic. The final thing that I need to do here to make everything okay is to simply go into the actual assets themselves and set them up to be just a little bit prettier. So I'm going to open up the band extender. I'm just going to set it to be white, save. I'm also going to set post half to be equal to, we can see what each of these are if we're not sure, remember that, so I can go highlight this. So that's the main base. I'm going to tell this to be blue. I'm going to tell this to be white, same as the other asset, so simple white. And finally, I'm going to tell this section here to be simple metal, which is the cap. Save, and now if I see them in the world, I have a rather simple asset that we've just created that will automatically suit itself to the situation. Now the next element is going to be adding the child actors to the variable band to automatically place themselves along this line here. So we've gone and we've created a nice simple variable actor, the variable band, and it's time that we now create the drop targets that we're eventually going to align along this. So the drop target's rather simple to create, but the first element of this is we need to, as always, import the mesh. So I'm going to open up my files, and I'm just going to get sm_drop target and pop it into here. Import. So we've got our drop target. I know from the beginning that I want this to just be simple white plastic. Doesn't have to be amazing. Save. So we've got ourselves the basic mesh. Let's go to blueprints. Let's right click and let's create ourselves a new blueprint class. And it's going to be an actor called BP_drop target. So the drop target is going to be relatively simple. It's going to have a couple of little things though that we need to really consider. Now, the first thing is we need to set ourselves up with a function that will drop the target and a function that will reset the target. So that's rather simple. First off, I'm going to add a component, which is going to be a static mesh. I'm not going to set it to be the root. It's just going to be sitting above the root, and it's going to be called DT mesh, which stands for drop target mesh. So I'm going to set that up as my drop target mesh, compile, save. And all I'm going to do here is I'm going to right click, create a custom event, and this is going to be called drop. After the drop event, I'm going to go custom event, and this is going to be called reset target. So I'm going to just take a shot in the dark with how I want these to function. I'm going to drag in DT mesh, and I'm going to drag off that and type move component, and I'm going to use the move component to function. And this is going to be rather straightforward. All we're going to do is when we want to drop it, we're going to say move. We're going to move component to -110 on the Z axis. I'm going to ignore X and Y for the time being because we just want it to go straight down. Next thing I'm going to do as a safety precaution is I'm going to set the collision enabled to be no collision. So I'm going to plug that in. Now next up we're going to have a play sound at location. So we'll play ourselves just a simple little sound effect every time it drops as well. So I'm going to right click, play sound at location, which is just going to be, the location is going to be the actor location. And the sound effect is going to be, for the time being, let's just play the bumper hit effect so we've got something. Eventually we'll switch that out to be its own unique thing. For reset target, it's going to be substantially more straightforward. I'm just going to set this to move to 0. So that's a completely standard thing, all set to 0. And finally, to get this functioning, I'm going to tell it that event hit. So when I get hit, I want to drop. Now, one of the things that we want to always check whenever we use hit is just make sure how our collision is set up. Now, in this case, we have block all dynamic is checked, but we have one thing that is not, which is simulation generates hit events. So make sure you check that. Compile, save. So that's under collision if you can't see it. At this point, we now have a drop target that will theoretically drop and then, reset itself. But let's quickly test that. On begin play, I'm just going to add a delay. And after 1 second, it's going to drop. And then I'm going to add a delay again, which after 1 second is going to reset. So compile, save. And if I go to my viewport and I hit simulate, so now that we've told it to reset, and this is going up to XYZ on the 0, the next thing we need to do, that's very easy to mess up in this situation, is make sure that DT mesh is actually connected to your component here. If you're copying and pasting, it's very easy to leave that component reference empty. And of course, now that we're doing that, the other thing that we need to do is, in the same way over here that we set the collision to be no collision, I'm going to duplicate that, and I'm going to set the collision on this to now just say collision enabled again. So that should be a correct reset. So we're going to test that by setting a delay node off of begin play, which is going to have drop, delay, reset. So if I go to my viewport and I hit simulate, I can see after 1 second it goes down, and then after 1 second it goes back up. So we should be all good now for that to function. Now, with that working, I know that there are things that we're going to need to do later. I'm just going to make you aware of that now. At the moment, the target's not reporting anything to anyone to work out whether it's dropped or not, but that's okay. I'll show you how to do that in just a little bit. The thing that we need to set up though from here is our lettering, such that we have a character that is floating just in front of this. So I'm just going to add a component, and that component is going to be text render. Now by default, I'm going to get this text, and I'm going to set this text to say the letter U. So getting this text set up correctly just requires us to essentially kind of move this around until we've got something that really works. So I can see where the character is right now. I'm going to rotate this to be in 90 degrees on the Z axis. So it's now there. I'm also going to move it just a little bit in front. So 25 centimeters on the Y axis puts it there. Going to set the horizontal alignment to be equal to center. This way it's in the middle there. And now I'm just going to turn the size of it up to something that I think will work. So I'm going to try 5 and 5. Which looks okay. Yeah, 5 and 5 seem like good values for our X scale and Y scale. So that can be our basic character that sits there. Actually, I might move this just a bit closer because it's still pretty far out. At times like this, it's a good idea to disable the snap grid just to get it to the closest possible area you can. Cool, re-enable. The other thing that I think would be a good idea is that's a white character right now, but instead it might be a good idea to make it just a strong contrast. Now at the moment, if we were to run this, the U is actually not going to stay attached. This is going to drop down and the U is going to stay where it is. And that's because my text render component here isn't set to DT mesh. So this hasn't actually, I had to make sure that DT mesh was the parent of the actor that I was dropping in. Now finally, the other thing that I'm going to do here is I'm going to create a variable that is just going to be, it's going to be a string variable to keep things simple. And it's going to be called drop letter. So I'm going to expose this, and I'm also going to expose this on spawn, and I'm going to set the type to just be a string. Compile, save. And all this is going to be by default is a letter, so I'm going to put in F for the sake of testing. And in my construction script, I'm just going to get my drop letter. So when the construction script runs, it's going to get my text render component, and it's simply going to call on the text render set text. And the value that it's going to be looking for is just going to be drop letter. It's going to add an auto conversion because we're going from string type to text type, but that's okay. We can leave that. So now that we have that going, compile, save. If I hit my viewport, you can now see that whenever I change this variable to be something else, it's always going to equal that again, which is great. So now that we've got our drop target essentially created, the next thing that we need to do is create actor components in our new blueprint. So the variable band is in place, the drop target has been created. It's time for us to go about actually creating the final piece, which is to create an actor that we're going to call a drop target set. So I want you to right click on BP variable band and instead go create child blueprint class. Now I'm going to call this BP underscore drop target set. Okay, and you'll notice that when it's created, it looks identical to a standard variable band, but there's more to it. So how this is going to work is I'm essentially going to add actors to this actor according to the word that is specified as its variable, which means we need to go ahead and create ourselves a new variable that I'm just going to call drop target string, and I'm going to set this be a string variable. Compile, save. We're also going to make sure that this is public, and in my construction script I'm now going to go ahead and create that functionality. Now I want to point out something. At the moment you can see that we have construction script and we also have parent construction script. This means that as long as this node is here, this node executes what its parent would normally run in its own construction script, whereas everything beyond this point is going to allow me to expand upon that so that this actor has all of its functionality of its parent plus a little bit more. So in this case, what I'm going to do is, first off, I'm going to get my drop target string, and I'm actually going to run a quick little function on it called toUpper, because anything that we have that we're putting in here, I want to make sure we're only using capital letters. So I'm going to now set the drop target string to be the capitalized version of the existing string. And now I'm going to drag off of that and I'm going to type in a function called getCharacterArray from string. This is very useful because what it does is it breaks any string, so line of text given into it here, into an array. Now I'm going to put in a test array at this point that'll just be a simple word. And what it's going to do is eventually this is now going to put out Udemy, and under getCharacterArray from string, this array is now going to have one letter in each single value of its array. So I'm going to drag off of that and I'm going to do a for each loop. Now this for each loop is going to create a child actor component every time it iterates through. So what we're going to do is I'm going to drag off of the loop body, and for the time being I'm just going to add a child actor component. Now a child actor component means we're spawning a new actor that's parented to this as if it was a component of this actor. It's very useful functionality. I'm going to do drop target, and for the time being I'm going to tell it that it's relative transform. So we're just going to make this up as we go along as a quick test, but I'm going to go split, and I'm going to just for the time being tell it, just so you can see that they're all being added, that it's Z location, so this is going to go straight up, which is obviously not what we want in the long run, but I'm going to multiply the index, which is the current number in the array, multiplied by, let's say, 40 for testing. I'm going to plug that into here. This is set to drop target and this is set to there. So if I go view compile, you can now see that it's added letters going up again and again and again. So we know that it's adding these actors to our world. So this means that what we need to do is essentially we need to create something in our construction script that tells it where to place those actors. And if you think about the logic that we need to have there, let's have a look at it. We start here and we end here. We want to find the spaces in between and automatically place them. Now, we don't want to use the very ends. We want them to only be on the band. So a nice way for us to go about doing that is to, first off, we want to get the length of the distance between the two posts of our parent. So if I was to right click here and just, try to add a reference to post, I could, except how would I ever get my second post? So it's time for us to quickly expand something that we had in the variable band, and that is I'm going to go to here, and when we add the static mesh component for the second post, which is this one just here, I want you to right click and promote that to a variable that I'm just going to call post2. This means that at any stage, if we want to modify post2 in the future, now we can. So I'm going to compile and save, and then go back to my drop target set. And this time when I right click here and I type in post, you can now see that we have get post2, which means I can get a reference to both of these. So post 1, we want to get the relative location. Post 2, we want to get the relative location. At which point we want to subtract one from the other and then get the length, which tells us how far apart these are from each other. So this is a nice little function to quickly tell us how far apart these two things are. Now all I want to do from here is I want to figure out how spaced out the intervals should be given how far apart these are. So I'm going to use this and I'm going to divide it by the number of characters that we want to have. So to do that, I'm going to get this, the length of this, and I'm actually going to add 1 to it so that it never fills up and adds an extra element to the end piece. So with the length plus 1, and what I'm going to do is, so I'm just going to clean this up as we go, reroute, and what I'm going to do is I'm going to divide by a float. I'm going to divide this by this. So the length divided by the number of pieces we want to have plus 1 so that we have a little bit of extra space on the end. At which point we now want to multiply that, because if I was to get this and just plug that, for instance, into x, well, the first issue that we have is we haven't gone ahead and told it where the gaps are. This tells us how far apart to place them, but we need this, there we go, to tell them where that specific element should be. Now this is not going to work when I plug it in, but you'll start to see what's going on. Compile. You can now see that these are getting arranged in a straight line. And if I was to go and modify the value that we have for the location, so I'm going to delete this for the time being and instead put in a drop target set. If I was to add this and click on post location and stretch it out, you can see that it's expanding that space. However, it's still not correct. Now the reason it's not correct right now is we're offsetting by 1 on one end, but we need to offset it by 1 on the other end as well. So I'm going to go to my, my drop target set, and in my construction script, I'm going to add 1 to my array index. These pieces are now being correctly placed here. However, we have another issue. If I was to get my drop post and move it, it's sizing them along the x-axis, but it's not actually sizing them in a way that is between the 2 points. It's just going along its own local x. So how do we fix that? So we go to the drop target set, and what we do this time is after we've multiplied that by that, we now want to actually offset it so that it's facing down the direction of the post. So there's a great way to do that, which is if I get my post 1 and I find out which way forward is for that actor, I can now multiply this number. So keep in mind, at the moment, this is just a distance saying here's how far along you should be. And by multiplying that against a direction, oops, that should be a multiplication against a vector. So multiplied vector by float. By multiplying these two against one another, I'm going to recombine this for a moment and plug this in. You're now going to see that if I get this, it's starting to actually place them in the correct location. So see they're now actually stretching between the two locations. However, we have one final issue here, which is we need to make sure that the rotation is correctly set up as well. And that's okay, because the rotation just needs to be the rotation of this against, sorry, where is my drop target set construction script? It is the local rotation of the post 1. So I'm going to get relative rotation and connect this. And you'll see that these pieces are now correctly aligning themselves with the post, because we're already doing the rotation math. Now that that's out of the way, the only thing that we need to do from this point on is to actually add an offset so that these aren't just sitting in the middle. Now if this is the forward vector along that direction, this would be considered the right vector. So all we need to actually do here is multiply the right vector by, say, 20 units and add that to our location. And what you'll see there is this. So we're getting the right vector at the moment and making that our location. Sorry, the forward vector, making that our location. But if we plus vector, so we're adding an offset, and this offset was simply equal to the post, we get the right vector. So that the right vector is a vector that points in the direction of the right of the object. By multiplying that against, say, 20, it's now going to be 20 units to the right. What does that mean? It means that it's now going to place those here. Save. Now at the moment, these are all being set to U, but they are being correctly placed now. So the final part for us to do in setting this up is to go back to our construction script, and after we add them, we now get this. Now, most people would expect this to return an actor reference, but it actually gives me a component reference, because remember, these are actually components in here. So what I need to do is drag off of that and type in child actor, and you'll see that we now have the ability to get access to the child actor. So with that, all I need to do is drag off of this, cast to drop target. So we're going to cast the actor to a drop target. And because it's a drop target, I'm now going to set the drop letter. And the drop letter is going to be equal to the current letter. So I'm going to get this and plug it straight in. Now there is still going to be an issue here, which is, well, you'll see in just a moment. If I go compile save, you can see that those are all still U's. Now the reason for that is that the function that we added in our drop target, which was to automatically set the letter in the construction script, this functionality doesn't actually work if we're doing it through a child actor. So we need to set that up a bit differently. So to do that, we go to the drop target set, construction script, and after we've set the letter to the correct letter, let's also just simply call set text on the text render that we've added. And I'm just going to make that equal to the letter that we set it to just then. So we're essentially replicating a construction script functionality here. If I look at this in the world, you can now see that this will automatically expand and contract where it can, and add the word that we've created, which is fantastic. So let's see how that actually works in a game. I'm going to add this word here, and I'm going to move the piece over to here, just so we have something that is theoretically easy to hit. And you can see that every time I hit them, they're now dropping. So going from here, the next thing that we need to do is to make sure that this actually knows how to handle itself from this point onwards. So it needs to know that when it drops, that we're actually assessing the number of things that have dropped and checking whether it's time to add a multiplier from this node yet. Which means it's time for us to start looking into some extended behaviors, which are going to be event dispatches. So we'll do that in the next lesson, but for the time being, write something cool, place it somewhere that's difficult to kind of reach, but still reachable, and expand your general play area. So this time around, what we're going to be doing is using event dispatches as a way of communicating between blueprints. In this case, we're going to use the drop targets that are aligned along the drop target set to communicate back to the set whenever they've dropped. When they have all dropped, we're now going to pass that information onto the game mode and increase the current game's multiplier. So to do this, what I'm going to do is I'm going to go into my drop target, and I'm going to add an event dispatcher. So this is going to be a rather simple one. All I'm going to do is I'm going to add an event dispatcher, and I'm going to call this onDrop. Now essentially what we're going to be doing is, this doesn't need any inputs set up here, so for the time being this is fine. What we're going to be doing though is we're going to say onDrop, anything that has been bound to this event is then going to call a respective function accordingly. So within my drop target, I'm going to drag this over and I'm going to say call. So now on a hit, we call drop, and when we drop, we're going to call on drop. Compile. And now in my drop target set, what I'm going to do is in my construction script, I'm going to go ahead and add a binding such that when the game actually creates all of the drop targets, so when the construction script is run, what I'm going to do is bind an additional event to this. So to do this, what we need to do is follow along here. We can see that this is the point where we add the drop itself. So afterwards, I'm then going to say, after we set the text, let's do one other thing, which is going to be as BP drop target, I'm going to bind on drop. So I'm going to bind an event to on drop. I'm just going to plug this in here. Now, because we're in the construction script, I actually want to bind this to a function in the event graph, well, an event in the event graph. So I'm going to right click in the event graph, and I'm going to create a custom event that is just going to be called process drop targets. So every time a target drops, it's going to run this function. And to do that, what I need to do is go back to my construction script, and in the event, if I drag off of this, you can see that we have a couple of options, but the one that I want here is create event. So I've dragged off of the red pin, at which point I'm going to select process drop targets as the function. This means that when onDrop gets called on this child actor component that we've created, it's then going to call process drop targets on this actor. So whenever we call process drop targets, let's think about what we need to do. Well, we need to step through, we need to keep track of how many drop targets we currently have. We then need to decrement it, so we need to remove one because one has now gone down. And if the current number of targets remaining is equal to 0, we then do something to the game mode. So for us to do that, we're going to need an additional variable, which is just going to be called target counter. So this is the number of targets currently in there. So I'm going to go integer. Now this is going to be set up such that when process drop targets gets called, we're going to get the current target counter. So I'm going to get, and I'm going to type in minus minus, which means decrement. So subtract 1 from it. Now after I've done that, I'm going to see if this is equal to 0. Because if this is equal to 0, we're going to do a branch, because that means that all of these have dropped down. So we're going to do a branch, at which point we're then going to modify the multiplier back in our game mode. So in our game mode, we currently have a value called multiplier, and all I'm going to do is I'm going to get the game mode, I'm going to cast it to the pinball game mode, I'm going to get the multiplier, and I'm simply going to drag off of that and type ++. So increment float. And then I'm going to connect this up and connect this up. Now, this is currently missing something. At the moment, we're never telling the target counter what it should actually be equal to. So there's a couple of different ways that we could do this, but what I think I should actually do is add one more quick custom event, which is going to be in the game mode, which when we reset, we want to, whenever the game gets reset, we want to make sure that we've bound the values to be the current counter again. So every time the game gets reset, we want to actually set target counter to be back to that. So to do that, what I'm going to do is in my game mode, under reset game, I'm going to add an extra call just at the very end here, which is simply going to call an event dispatcher. So I'm going to create another one, which is called onGameReset. And I'm going to call this here. And in my drop target set, I'm simply going to say on begin play, we want to get the game mode. So I'm just going to copy and paste the game mode reference here. So on begin play, let's get the game mode. And let's very quickly just bind to onGameReset, which is what we called it. So we're binding to this here. And the event that we're going to be binding is simply going to be called, it's going to be called reset drop target counter would be fine. So I'm going to create a new custom event. Oops. And it's going to be called reset drop target counter. And this, now I could actually just plug this straight into here if I didn't want to do the custom event, but this can get kind of messy doing it this way. It's okay for the time being though. And all I'm going to do is say target counter is equal to the length. So I've grabbed my target string, the length of the string. So compile. Now we're getting a little error here. Oh, now the reason this is throwing an error is because I compiled this before compiling the game mode. So if I go back to here and hit compile again, it'll be totally fine. The reason being is that it's the game mode that had the delegate in it, the event dispatcher. So we've created that. That's now able to reset there. Now I believe reset game is currently being called whenever we create the game itself. So we should be fine. On begin play, we call create main menu, which on play resets the game. Yep, so this should be fine. So there's one last thing that I want to do here, which is in my drop targets. I'm going to, again, I'm going to set these up such that on begin play, I'm going to bind reset. So the reset function that we've already created, reset target, is going to be set so that when the game resets, we're going to be doing that. So once again, I'm going to drop in my pinball game mode. I just pasted it in from earlier. And I'm just going to bind on game reset. We want to go event dispatcher, create event. And I'm going to say reset target, which is the function that we created earlier. I'm going to compile and save. So now when the game resets, all of my targets should also come back up to the top. So with that done, we should be ready to test this out. So if I were to hit play, okay, so we've had one tile fall down. Now let's quickly test if these reset. 1, 2, 3, and this should be my last life. So now when I hit play again, you can see that that pops straight back up. Fantastic. So we've gone through and we've gotten most of the assets together. One last thing that I'd really like to add here is a slingshot, which is just a reasonably standard pinball asset. You'll recognize it once we start to get it in. And to do that, I'm going to need to just copy in the asset, same as before. So I'm just going to go to my assets folder and I'm going to pull up the asset to copy in, which is going to be called SM Slingband MT. So I'm just going to drag that in. And when it imports, I'm going to leave all of this the same. I'm going to auto-generate collision as well. And just click import. Now this asset has something different about it to the others. And what that is that if I was to open this up and quickly show you the materials, there are 3 materials for the surface and for the base sections and then for this band running around the middle. Now this band around the middle has actually had morph targets applied to it, which is just a simple addition that we can add in 3ds Max that allows us to have kind of like a very, very basic pose saved into it, so a single animation as to where it would end up. And the reason for this is we, through the material, can modify these morph targets to actually expand the band out and pull it back in again to create that slingshot effect. So to do that's rather simple. What I'm going to do is I'm going to right click and I'm going to create a new material, and this material is going to be used as the morph band. So I'm just going to create that now. I'm going to right click, new material, m_morph band. And this morph band is going to be set up reasonably simply. All I'm going to do here is I'm going to set up first off the color. So I'm going to hit V and drop in a vector parameter, which lets me set a color that can be instanced. I'm just going to call this color. I'm going to set the roughness to be very low. 0 is actually probably good for this. And next up, I'm going to right click and I'm going to type in static morph. And you'll see that we have static mesh morph targets. So when static mesh morph targets is loaded, what it actually is doing is it can read in a final position. So if I was to get that position and run it into a world position offset, it actually lets me say where I want each vertice to end up in. So to do that, all I need to do is, if I was to just plug this in, it would end up in the final position that's been saved into the mesh. Now we're not going to see anything here because this sphere doesn't have anything saved into it. But I'm going to just plug that in for the time being so you can see it. And I'm going to hit apply and save. I'm also going to quickly just set this color to actually be something reasonable. So let's just go with like a yellow. That'll do. Save. Now all I need to do to test this out is I'm going to go to my sling band MT, and I'm just going to send this bottom material to be my morph band. And you can see now that it's completely stuck out. So yeah, this has just popped out here. And if I was to unplug this and hit apply, it's now pulled back in. So what we need to do is get this parameter that allows the band to shoot out and basically just set it between a value of 0 and the final pose. So no morph target versus full. So to do that's rather simple. I had just held down L and left clicked to add a linear interpolate. So we call this a lerp. And I'm going to plug in WPO into the B channel. My alpha is going to be a scalar parameter that I add by holding down S and left clicking. So remember, a scalar parameter is a singularly modifiable value. So I drop this in. And I'm just going to call this %out. And initially that's going to be a value of 0. But if I was to push that up to 1, it would be popping out. So with that done, it's essentially all I really need done for this material, because we're going to be modifying it through the blueprint itself. So once again, I'm going to go pinball and I'm going to go blueprints, get a right click and create a new blueprint class. And this is just going to be called BP_slingshot. And my slingshot asset's going to be reasonably straightforward. All I'm going to do is I'm going to set it up to have the static mesh of the sling. So add a static mesh component, set it to slingshot band. I'm now going to get this and I'm going to make it the root. Now we only really want the sling to pop out if it touches this here. So I'm going to add a component and it's going to be a capsule collision. So this capsule collision is just going to be a little zone in front of it that we're going to use to determine whether we should be popping it out or not. So I'm just going to pull this up. Because my snap grid's too high, it popped all the way up top, so I'm just going to turn that off by clicking on the grid. So this is probably okay initially. We can clean this up later if we need to. So that's just there. And all we're going to do here is, in the event graph, I'm going to say on begin overlap. So this collision capsule overlaps all dynamic and it generates overlap events, so it's correct. Now on begin overlap, we're going to check if the other actor is a ball. So I'm going to cast it to a BP ball because we only really want this to do anything if it is a ball. Now if it is a ball, what we want to do is add an impulse, which will automatically get me a reference to the ball mesh. And we're going to set that impulse to be equal to, this is a cheeky little way we can do this. If I click on this, you can see that the red arrow is pointing that way, which actually tells me my forward vector. And in this instance, all I actually really need to do is say I want to go this way. So if I tell this to go negative impulse on the forward vector, it'll push out against the red arrow here. So to do that, if I go and get my capsule, get forward vector, which is the red arrow, the x-axis, and I multiply this by a big number to give it some projection. So I'm going to multiply it against the float. That's just going to be set to, say, negative 2,500, sounds good. And I plug this into here. Cool. All I need to do now is do something to actually modify the static mesh's material. But first off, let's just double check that it works. So I'm going to go into the world. I'm just going to add a sling. This sling by default is quite small, so I'm just going to make it equal to, say, 2 times larger. In the process, I might move these around as well. And I'll get rid of you. Okay, so we can put this here. And if I alt drag it, we can now put another one over here. If I right click, I can transform, and I can mirror it as well, so we can get that nice, just two assets kind of popping up there. Actually, let's face it this way instead. That's nice. Cool, very simple. So to test this, I'm just going to now hit play. So that seems to have worked. We got a little bit of a bump out of it, but it's going to be a lot clearer as to whether it's working or not if we go ahead and add a quick timeline so that we can see the band kind of shoot out. So to modify the bands, all I'm going to do here is after I add an impulse, I'm going to get the static mesh, and I'm going to change the variable in its material. Now, because I'm going to be changing a variable in its material, it's a good idea for me in my construction script to get this and just type create dynamic material instance. And when it asks me which one, I know that it's the channel 2. Remember, it's indexed by 0, so it's element 2. We can see that if we open up the mesh, element 0, 1, 2. So this is the one that we want to make an instance of. So I'm just going to quickly plug that in, and in my event graph, I'm going to get the material. It's going to be material 2. I'm then going to cast to dynamic, at which point I'm simply going to set scalar parameter to a value. Now, what we actually need to do here is we don't just want to set this value one time. Like, we don't just want to set it to the value of 1, for instance. What we actually want to do is set the value to be equal to something that we're projecting from a timeline. So I'm going to disconnect this here. Instead, I'm going to drag off, and I'm going to add a timeline. And this is just going to be called sling bounce. So update is going to be plugged into there. And we're going to double click on sling bounce and add a float parameter. And this is just going to be called bounce. And all we're going to do here is rather simple. We want this to be a way of adding a key at 0, 0, so I'm just going to set the time to 0. So this is where it starts, at which point we're going to right click, add a key. Keep in mind you can also shift click, just for me it's a force of habit for right clicking. So I'm going to add that there, and this is going to be equal to a value of, I want this to push out pretty substantially. I'll set it to 1 for the time being, but my gut says it'll end up as around 2. Now, because this value here is linear, you can see that it's coming off like this. If I click on any of these and then hit 3, it'll automatically add that nice curve to them. So I actually want this to kind of spring out rather quickly and then kind of pop down. So I'm going to move this across. Also, if you're not sure which of these you want to use, you can open this up and set it to any of these. Auto's usually pretty good. So I've plugged this in, and we've now got a rather basic timeline. Compile, save. And if I was to go to my event graph and just connect bounce to here, it's now going to just interpolate that value. Now remember, we have to put in the parameter name of the value. And in our instance, the value is called %out. So I'm going to have to change this to say the word %out. At which point, when it gets hit and enters the capsule region, it should now eject. There you go, and you can see that popping out now. Now, one thing that we've gone and done is it will only play one time right now. And the reason it's only going to play one time is we're currently telling it to play. But we actually, every time this goes in, we want to get the elastic band and play it from the start again. So I'm just going to disconnect that and plug it into play on start instead. Compile, save. We should now have a fully functioning band. pops out multiple times in a row. So we know that's working. The final thing that we really need to do is make sure that when we hit it, we know that it's the ball, that we add a score. So I'm going to add a quick function that's going to, I'm going to add a quick call that lets add score to the game type. So we've already got this, we know. All I need to do is, after we've verified that it's ball, before I add the impulse, let's go ahead and quickly, just going to move this across. I'm going to get the game mode. Cast a pinball game mode. If that somehow fails, which it shouldn't ever do, we'll just go straight through. But as long as it doesn't fail, let's go ahead and add score, which is that function that we've already created. Let's say these are worth 20 points, and just plug that in there. So that'll add score now every time. If I hit play, you can see it's adding a score. Fantastic. So the only other little thing that we really want to do here is go back to the mesh itself, and let's just quickly set up the materials to be just a little bit nicer. I'm going to set this to be a yellow band on top, and I'm going to set the middle one to just be simple metal, just so we've got a completed asset in there. Save. There you go. Now from here we're going to be doing some polish passes, so we're going to start adding sound effects to everything, as well as adding some particle effects where necessary. So stick around, jump into the next lesson. So aside from the materials, the other thing that we need to fix right now is the collision. So I'm going to click up here and view it, and you can see that this is currently set up so that it creates this very weird shape. So initially I'm going to click on that and hit delete. The other way you can do it is collision, then you can go to remove collision. There's nothing there at the moment, so it's grayed out. And what I'm going to do here is I'm actually going to tell it that I want it to auto-generate collision based purely on this top piece. The rest of it's going to kind of throw it into confusion. So I'm going to go down to LOD 0, and just temporarily I'm going to turn off collision on the posts as well as on the band itself. So it's just on this top section here. I'm going to do convex collision set to around 20 max Helverts. I'm going to click apply, and then we just wait a second. Now keep in mind that what I generate here is only going to be on this top area, but I kind of actually want this to go the whole way down. So there's a nice little thing that I can do. If I click on it, you can see that it lets me select the collision. So I'm going to get this and drag it down, and I'm going to hit spacebar, spacebar, and instead I'm now going to start scaling it upwards. Now, because of the offset between where this was and the ground, as I scale it, it's going to push it upwards, but that's okay. It's really only a thing that we need to kind of deal with once. So I'm just going to drag it this way until we get something that's about there, a little bit taller. So now we've gone ahead and just created a very simple collision block that goes from the top down to here, which should be a bit better for gameplay. So I'm going to hit save, and then we're done within the sling band itself. So let's start looking at incorporating sounds into our project. We've already done a rough pass on these bumpers, but it's time for us to actually work on different types of sound. Now to begin with, I'm going to show you a standard wave implementation. So a sound wave is different to a sound cue, which is the other type of sound format that we typically use. How this works is a sound wave is the raw audio that would be imported when you first brought a wave file in. So we use these when we don't need to care about attenuation, we don't need to care about anything that is related to distance, we just kind of just want to play the sound generally, which makes it ideal for things like UI sounds and music tracks. Now a good example of how to do this is for me to initially use this victory music loop that I've imported. So I'm going to double click on that, and in the sound wave I'm just going to say looping. Now you only ever need to set this version of it to looping if you're only going to be playing the wave and not a cue file. So I'm going to go blueprints, and I'm going to open up my game mode. There we go. Now that we've opened up our game mode, let's go to our event graph and let's look at our begin play. So when the game first begins, we call create main menu. But let's do one other thing. Let's play sound 2D. And this is just going to be called victory, which will load in the WAV file that we've now assigned. So from here, I'm going to hit compile, save. So we can see that that works. Now, the next format after we've done a standard sound wave is going to be going into this and actually adding sound cues. Now, we've already added a basic bumper hit, which just sounds like that every time. And if you remember, the bumper hit that we added randomized between different sound effects. In this situation, what we're going to be doing is we're going to be changing one extra setting. So that extra setting that we're going to be changing is the attenuation settings. So if I right click and I create new sounds and I go to sound attenuation, you'll see that this is an option just here. If I click on that, I'm going to make one that's called pinball attenuation. So this is going to be the general attenuation file that we use for every sound. Now how it works is very simple. We set it up so that these settings automatically will get loaded into any of the cues that we're using. So the settings that I really want to change here are things like the radius and the fall-off distance. In this case, what I want to do is say that any sound that plays has a radius of 1,000 units. And if my head was theoretically within 1,000 units of the sound, it would be at full volume. The next thing I'm going to do is the fall-off distance, which controls how far it actually reaches out. And I'm going to increase this to 4,600. So this means that it's going to fade between that distance and the radius to slowly drop off to nothing. Now I'm also going to make sure that spatialization and attenuation are enabled, which just means that my left and right ears can tell a difference, which is very useful because it means that if the hits a bumper on the right hand side, I can hear it in my right ear. If it hits something on the left hand side, I'll hear it in my left ear. So that's our attenuation setting, and first off I'm going to apply that to the sound that we already have called bumper hit. So I'm going to double click on that. And I'm going to change the attenuation setting to be pinball attenuation. Click and save. Now that we've done that, let's go ahead and actually make a cue file for when the ball first gets dropped into play. Now there are a couple of options we could use here, but I think ball launch is what we can use for when the plunger lets go and hits something. We've got ball loose, which is a good one for when the ball first comes into play. And then there's ball release, which we could potentially use as well for when the actual thing releases. It's up to us as to which way we want to go about it. But in this case, the one that I definitely want to have set up initially is ball loose. So we're going to play this every time a ball spawns. So I'm going to right click and I'm going to create a cue file. I'm going to keep the default name, which is just ball loose cue, because it's pretty descriptive as it is, and we now know that it's differentiated by being a cue. I'm just going to move this over to here, and I'm going to set the attenuation setting to be the pinball attenuation. So that'll automatically then get all of the attenuation settings that I would typically have. I'm going to hit save. And now under here, I'm going to go to my blueprints. And all I'm going to say is that in my BP ball, whenever the ball first enters play, so a ball is first spawned, I'm just going to play sound. Now there are a couple of options for how we do this. If we want, we could spawn the sound attached, which would be spawned to the actual component itself. We could also play the sound at a location. So there's a couple of different ways that we really want to set this up. In my opinion, it's probably going to be simplest if we just spawn the sound attached, because it's not really going to be moving around. So I'm going to get the spawn sound attached and simply just drag the ball into that. So attached to component is the ball component. I'm now going to set the ball to be the ball loose cue. I'm going to hit compile and save. And now when I hit play, it's a little hard to hear over the music. So I'm going to quickly tweak my music overall volume by going back to my game mode, clicking this button, and just setting the volume multiplier to 0.25. Compile, save. And now when I hit play, there you go. So I can hear the ball automatically is playing that sound every time it gets brought into play. And if this ball were to come out of play, I hear the new ones spawning again. So that's it for those initial basic sounds. From here on in, it's a good idea for you to start going through and adding some sound effects to each of the elements in your environment. So please go through, add some sound effects for the flippers. You'll notice that we have a left flipper and a right flipper. So this actually has a pre-done stereo sound for flipper left and flipper right. So you can plug them in without any issues. So go through, set things up for different sound effects. I'd also consider binding a sound effect for when all of these come down. There's a couple of nice little ones that you could potentially use, such as the bell noise for when this goes down. The bell is this one. Or this one. So you could do the bells for every time these singular letters come down, and then the bell impact for when they all go down, as a signifier that the multiplier is kicked in now. So go through, and when you're done, move on to the next lesson, and I'll show you how to add a audio component to the ball that's constantly rolling and fluctuating in pitch and in volume. So for this part of the tutorial, what we're going to do is get the ball, and we're going to add a constant rolling sound effect to it. And this rolling sound effect is going to just follow it around, and it'll always be attached to the ball. But we're then going to modify this sound so that when the ball stops, it stops. And when it starts again, it starts again. And according to how fast the ball is currently rolling, we'll shift its pitch and we'll shift its volume just a little bit. So how do we do that? Well, we begin by getting this pinball rolling sound, right-clicking, and creating a cue. I'm going to get rid of the 0, 1 on the end of the cue here, because it's unnecessary. At which point, I'm going to open it up, and we've initially got this, which is just a basic rolling sound. However, one thing that I would like to do here is I want to click on this, and you'll see that we have an option called looping that I can just enable. So I'm going to turn that on. Now, it's important to note that when we're using a cue file, you need to do your looping in here rather than on the wave itself. Another way to do it is to type in the word loop, and you can see that we can set up looping here as well. But for the time being, it's easy enough to just set it up on that. So now that I've got that set up, I'm going to go Attenuation Settings, Pinball Attenuation, and Save. After closing this asset, I'm now going to open up Blueprints again, and I'm going to go to the ball blueprint. So from here, I'm going to add a component. So by adding a component that's an audio component, I'm adding a sound that will be constantly set to wherever the ball is. And this is just going to be called ball rolling sound. And I'm going to set the sound to be the cue that I just created, which will be ball rolling cue. Now, the quickest way for me to do the functionality that I spoke of is to in tick add a sequence, so that sequence 0 goes ahead and fires off the impulse that we would normally use, but sequence 1, so the next value down, is now going to trigger something else. It's going to go down here and modify the rolling sound according to the current world variable. So I'm going to get the ball rolling sound, and I'm going to drop it in by holding Control and left click. From here, I'm going to type in the word volume, and you can see that we have an option called Set Volume Multiplier. So the first thing that I'm going to be doing when I make this is I'm going to modify the volume of the sound. The next thing I'm going to do is I'm going to set the pitch, and you'll see that we have Set Pitch Multiplier. Now both of these are just after a float, and we've got to think about how we actually want to get that float. What is that value? So effectively, we want the volume to go up to 1 when it's at a reasonably quick speed, and we want it to scale back to 0 when it's beneath that speed. So the simplest way for us to do that is actually to get the velocity of the ball. And now this velocity of the ball that we get returns a vector. So it's giving me the velocity in x, y, and z axes. But in this case, I actually just need the general velocity of the ball. I don't care about any of the other details. Like, I don't care which direction it's currently really moving in. I just care about the overall velocity. And to do that, we need to get the length, vector length. So this returns a single float value that's going to be the speed of the ball. Now, the next thing that I'm going to do is, when this is going at a reasonably quick speed, I want to have this set to 1. So the quickest way for me to do that is to say, let's pretend we want a speed of 1,000 to equal a volume multiplier of 1. So to do that, all I need to do is get the length and divide it by a number. That number is 1,000. At which point, when the speed is equal to 0, this number is going to be equal to 0, because it'll be 0 divided by 1,000. When this number is equal to 1,000, it will be equal to 1, because 1,000 divided by 1,000 is equal to 1. The final thing that I'm going to do is I'm going to clamp. So a clamp, when you run a number through it, what it essentially does is it makes sure that if a number is below 0, or below the minimum, it will equal this number. When it's above the maximum, it will equal this number. And by plugging this into here, it means that if the number were to somehow ever be below 0, it would be equal to 0. And if the number were ever above 1, it would just be equal to 1. So even if this is moving at 2,000 units per second, it would now be equal to a value of 1. So we've got our volume set up, and I'm just going to do the same thing for the pitch, but this time I'm going to set the min to be 0.97, and I'm going to set the max to be 1.2. Plug that in, and connect that to pitch. So with that plugged in, I'm going to compile and save. And when I launch the game, so I can hear it, but it might be a little tricky to hear over the music. So I'm just going to turn the music off for just one moment so we can verify that it's working. So I'm just going to disconnect my music over there for just one moment. Yep, and it's definitely working. So as the ball moves, wonderful. So now we have a ball that's dynamically modifying its pitch and volume accordingly. I'm going to connect this again so that we've got something there. I might even consider turning these down just a little bit more. I'm going to compile and save. At which point, this is now done for the ball. So that's all it took to get some dynamic modifications to a file. Now, if we wanted to do this with a sound that we had created, we could do it in a number of different ways, but the most important thing to note if you were to do it is when you create a sound from one way or another, here we go. When you're creating the sound, it spawns a reference to the audio component. So if we wanted to modify the ball loose option for some reason, we would just promote that to a variable, and then we would modify that variable at runtime as the game was running. So we could do it with dynamically created sounds, but for the time being, that's all we really need to have. It's just a ball rolling sound that's always there, because there's never a situation where we want it disabled. So that's it for dynamic audio components. So now that I've gone through and added sounds to my game, I have some basic bumper sounds, some slingshot sounds, there are some hits that my flippers will make now, as well as some success sounds when these tiles are all dropped. I'm going to add one of the last things, which is a spinner. After the spinner, we'll be adding a forced movement volume, and then it'll be just onto aesthetics, so we can clean everything up. So for the spinner, what I'm going to need to do is import a couple of extra assets. Now these assets are going to be sm underscore L bracket. Just going to import that. I'm also going to grab sm underscore spinner. Let me just, oh, there it is there, spinner tile. So this is the tile that's actually going to be spinning. And finally, the last one that I'm going to need, sm bracket top. So this one just here. I'm going to drag that in. We now have the three meshes that we're going to need to make our spinner. So import that. So to do this, what I'm going to do is create a new blueprint. And it's going to be an actor. And I'm just going to call this bp underscore spinner. Now I'm going to need a couple of things in this. So first off, what I'm going to need is the bracket tile for the left and right brackets to be set up. So I'm just going to add a static mesh component. And this first one is going to be the left bracket, which you can see is here. And I'm going to move this 100 units to the left, so negative 100 on the x-axis. At which point I'm going to duplicate this. And I'm now going to put this one to be 100, and I'm going to rotate it around so that we end up 180 degrees. It'll be sitting just like that. Now, with the left and right brackets in place, the next thing for us to do is going to be to add the top. So I'm going to quickly just name these left bracket, right bracket. And now I'm going to add the top, which is again going to be a static mesh component. And this is going to use the top bracket that we have before. And you'll notice that when I add this, it automatically is set up to have this kind of effect. So there's a couple of ways that I can handle setting this up correctly, but the easiest of those is going to be if I move it to here, and then I just scale it by 2 along the x-axis. Now, if I just enter 2, it's going to scale on every axis at once. So be sure to disconnect that, and then enter 2 on just the x. And you should end up with something that looks like this. So that's going to be our basic bracket. And if we wanted to, we could set this up in a couple of different ways. We could, for instance, make these brackets taller. And if these were taller, we could easily resize it such that the spinner would be based on the ground. It depends really how you want to use this, so I'm just letting you know that it's available. So if I push those 2 up, for instance, I could then easily bring this up, at which point you have this kind of shape. I might actually keep it like that just so it's a bit easier for you to see what's going on. So with this in mind, the next thing that I'm going to do is I'm going to add another static mesh, and this is going to be, I can do a search for cylinder, and I'm going to use one of the basic engine shapes for the cylinder. So if I drag this up, this will be kind of the pivot location for the actual spinner as it spins around. So this should be reasonably straightforward for this one. One thing I will do on this though is I'm going to be a little cheeky and turn off collision on it entirely. So that's shut down. Now for us to get a good shape on this, I'm going to get to the scale tool by pressing spacebar, and I'm just going to shrink this down so that it looks about right. That's good. And then I'm just going to scale it outwards so that it just pops through the ends. Whoops. There we go. So it pops through the ends, and we've got something like that. Now before I go any further, I'm going to quickly set up the assets themselves so that the metal bar is actually a metal bar. For these assets, I'm going to set them up within the assets, so within the static meshes. So I'm just going to double click on this, and I'm going to set each material to be just reasonably basic. So I'm going to set this to be simple yellow plastic with the metal. Save. And then I'm going to do the same thing for the top piece that we have, so the bracket top, which is also going to be, actually I might make this the white plastic, just so we have something that looks a bit different on it. There you go. Simple as that. Now that I've done this, I can see that there's a tiny bit of clipping. So the easiest way for me to fix this is to just add like 2 centimeters to the top so that it's just slightly above. That worked. 102 on the z-axis. We've now got this, and I'm going to name these before I go any further. So top bracket, and static mesh is going to be, the last one is going to be called a cylinder. Okay, so I'm going to add another component now, and this is going to be the actual spinner. So I'm going to add a static mesh component. I'm going to call it spinner, and I'm going to set the mesh to be the spinner tile mesh. So you can see it's just here. It's a good idea to now move it up, get it to a location that's going to work for what we want to do, and that seems about right, because ideally we want this to kind of hit here, and if the ball's going one way, it'll flip up, and if the ball's going the other way, it won't let it through. So we've added this to here. We've got ourselves a reasonably straightforward tile piece. What I'm going to do is I'm now going to add a very basic physics constraint that is essentially going to act as the bar that will force it to spin or not. So to do that, what I'm going to need to do is go add component and physics. And I'm going to add a physics constraint. Now for this physics constraint, you'll notice that we have a couple of options here. Essentially what we'll be doing is we'll be telling the physics constraint to stick to this and let it twist around it in only one direction, and as far as everything else is concerned, don't let it move. So I'm going to bring the physics constraint up to this, just so it's connected to where this bar is. And at the moment you can see these circles dictate what would happen with this if it were to be connected. So let's actually connect that. I'm going to go to my component name, and I'm just going to name this component spinner in this. And you'll notice that upon hitting enter, it's selected the spinner component. Next up, I'm going to scroll down, and you can see that the angular limits are all set to free, free, free. So what that means is that this is allowed to swing on that axis, and our axis. But I don't want that. Instead, I want to lock it, and I want to set this one to limited. So by setting this to limited, I know that it can only be spun in one way. Now, the next thing that I'm going to be doing is I'm going to get this and I'm going to tell it that the twist limits are going to be set for us. So see this section just here? That actually represents how this will spin. And if you think about how we want this to spin, we actually want this to be 90 degrees instead of 45, because it's 90 and 90, so it kind of does it in both directions. And then I'm going to offset this until it's around the other side. So I'm just going to go to here, and I'm going to type in -90. Now, the final part that I'm going to do is actually I'm going to quickly add 90 to my X rotation up here just to finish it off so that the axis kind of align. So I've added -90 to my X rotation, set that to 90 and that to -90. And we now have this. And if I were to then go down and I was to set up one last setting, which is under twist limits. So if I look at this, I can see that under angular limits, there's a couple of extra options. I'm going to disable soft constraint. I'm going to hit compile and save. Now first off, whenever you do a physics simulation, always hit simulate first, because if half the time it just falls down, which means you've done something wrong. But this looks like we're all correct. So the last things to do to get this working before we continue is make sure that the spinner has been set to simulate physics. And one final thing that I really like to do is to add an arrow component, because the truth is that we don't know which way this is going to be when it's in the scene. So I'm going to drag this up, and I'm just going to make the arrow point in the direction that I know this is going to spin in. Compile, save, and now if I were to hit play and fire it, you can see that it goes through there. And if I look at how this is set up, I can see that the arrow is pointing that direction. If I were to turn this around so that the arrow is pointing against the ball, now, the reason that didn't work the first time, but did work the second time, is due to an issue that we get from CCD. So for us to fix this, what we essentially need to do is tell the game that it needs to actually look at the collision of the ball more frequently than we have been. Because what it was doing is in between ticks, it somehow jumped between this side and this side. This is a common problem in video games, and I'll show you how to fix that. I'm going to go ahead and I'm going to change a couple of settings on the ball, just to make sure that these type of issues never really happen again. So in this case, the ball's going to need the following changes adjusted to it. We're going to need to make sure that when I go through here, we've set ball mesh. I'm going to scroll down, and the first thing I'm going to do is I'm going to enable CCD, which enables continuous collision detection. The next thing that I'm going to do is I'm going to increase the position solver iteration count, which is in the physics section here. So if I go to this, I can now actually tell it to more frequently check the position of the ball to make sure that we actually stay reasonably accurate. So I've set this to 12 and 2, and then I'm going to hit compile and save. And this shouldn't now happen again. You'll see that now if I do a full charge straight into it, it's getting blocked every time. So we know that problem's now been fixed. So the last thing I'm going to do is put this into a place where I think it'll look good. In this situation, we want the ball to be able to go through here, but not necessarily back, for instance. I could put this over here, and I could set it up that way. There are plenty of different locations that you could put this, but I personally really like it being over here as kind of an entryway to the game itself. Again, I'm going to use this arrow to make sure it's positioned the correct way. So, flip it around, and I'm just going to pop this right here. Now, since it's a little big, I'm going to scale it up. That should all work totally fine. However, we are going to get an issue that it's possible for us to not really get enough momentum to get through that sometimes, and I'll show you how to fix that next. But here's a quick demonstration of what I'm talking about. You can see that it now pops out, and the ball's never now going to get back into that area. So we'll be moving into forced direction volumes next. However, one last little detail to change here is I'm going to set this to not be gray. So I'm going to open up the mesh that's associated with the spinner, which is just under Assets, Spinner Tile, and I'm just going to set this to be white. Save. So that's our very basic spinner, and if you wanted to go further, you could potentially get this to award points as well and have a couple of them around the map and set up some more complicated behaviors. It's up to you. But onto forced direction volumes, coming up next. So the last prop that we need to add to our world is actually an invisible one, and this is going to be called a force movement zone. Now, essentially what I'm going to do is create a blueprint that whenever there's a ball inside of it, it forces it to only move in one direction. But it does in a kind of subtle way, is the intention here. So I'm going to right click, create a blueprint class, and it's going to be an actor, because we're placing it in the world. And this is going to be called BP underscore force movements zone. So I'm going to double click on the zone, and I'm going to add a component to it. And the component that I'm going to add initially is going to be box collision. So box collision. And this is going to represent the zone with a forced movement direction in it. For the time being, 32 by 32 by 32 is totally fine. However, when I go down to collision, I want to actually set this to custom. I want to basically ignore everything except for one thing, which is physics bodies. So we've told it that it's going to ignore physics bodies, and that should be it for our initial setup here. Now the other thing that I'm going to do is I'm going to add an arrow component, and this arrow component is going to be what we use to make sure that when we're putting it in the world, we know which direction it's facing. So I'm going to add an arrow component, which is just going to look like that. Now, for this, what we need to do is compile, save. I'm actually going to use tick here. Now, there are plenty of ways that you could avoid using tick in this instance. You could set it up so that it only does this when an object goes in, it turns it on, and when an object leaves, it turns it off. But because this is a quick setup, I'm going to set it up through tick. Just be aware that there are slightly more efficient ways that we could ultimately be running this function. And what I'm going to do is off of tick, I'm going to run a for each loop. For each loop. And that's going to cycle through an array. Which array? Get overlapping actors. So get overlapping actors gets all of the certain type of actor that is currently overlapping this actor. So at the moment I'm going to go through and I'm going to look for every single ball that is overlapping this actor. So what we need to do here is we need to get the actor. I'm going to cast it to a ball. Now I know this is going to be a ball. I'm going to convert it to a pure cast because I know it's going to be, since it's the only thing that can come out of that. At which point I'm going to set the physics linear velocity. Okay? So what I'm essentially doing here is I'm setting the velocity of the ball. Now, when I set this, I need to have a velocity to set it to. So, what's that velocity? Here's where a bit of math has to come into things. Essentially what I'm going to do is I'm going to, first off, get the current velocity of the ball. So we're going to have the current velocity of the ball, at which point I'm going to, this velocity is in world space. So if it's moving along X, Y, or Z according to the world, it's X, Y, and Z like in those world coordinates. But if I was to rotate this object, they would no longer match up with one another. So there's an interesting thing we can do here called an inverse transform, which essentially lets us get something and convert it from one space into another space. So what I mean by that is this. If I was to currently get my force movement zone, forward for this object is that arrow. So the x-axis goes along this way. And so it does with the world. But if I was to rotate this, I now have a local x-axis that's going that way, while a world x-axis is going this way. So what I can do is I can get the velocity in world space. I can run an inverse transform on it. So inverse transform the direction. And now it's going to ask me, when I add this, it's going to say, well, if you're adding an inverse transform, which object do you want it to now match? So this is converting from world space into something else. And the easiest thing for me to do there is to get the arrow, because we know that that's the direction that we always want to face, get the world transform of the arrow and convert it into the arrow's space rather than in world space. From here, what we've essentially done is we're now getting a speed value relative to the force volume that we've just created, which lets us do some pretty cool stuff. In this case, what it lets me do is run a function to basically interpolate the velocity from its current velocity into the desired velocity. And the desired velocity is actually rather simple. The desired velocity is a maximum x value that we're going to give it, or its current x value as long as it's greater than 0. So we're going to have like a minimum and a maximum clamped on the x, while the y and z we don't really care about. I'll show you what I mean by that. So if this is the direction, if I was to break this direction, we've now got an x, y, and z value out of this, which are all relative to myself. What I'm going to do here is I'm going to tell it that ultimately the speed that we want to have is going to be, if we're moving below 800 units along the x-axis, I want you to move towards 800. Otherwise, I want to use a max value of a very high number. I'm just going to set this to 19,000. I could have used a min here, but I'm just going to set it up this way for simplicity, since you're familiar with clamps already. Now, you're probably sitting there going, well, if I was to just set this as my x, y, and z axes, wouldn't that create a problem? And you'd be right, because that would instantaneously set my speed to be this speed. However, if I was to use what's called a v-interp2, what this does is my current speed is this, my target speed is this, and the maximum amount of change I'm allowed to make per second is this. So I can actually set this up as the target speed. So I'm going to split the struct and tell it that the x speed is this one that we just gave it. Y and z are both 0. The current speed is going to be this, because we know we've already gotten this speed. And then finally, just before plugging it in, I actually don't want to connect that. What I want to do instead is now transform it back into world space. So I'm going to, once again, get the arrows world transform. And if I drag off of this, instead of doing an inverse transform, I'm going to do a transform direction, which is essentially going to go, hey, this is the current space that I'm in, remove that, and it'll put you into world coordinates. Now, this is a very cheeky way to do what we're doing here, but it will work, and I'll demonstrate how this functions. The most obvious thing that could make this go wrong is if the ball wasn't set to be a physics actor, but I've just gone through and just double checked, because out of paranoia, the ball's collision is definitely set to be a physics body. So we're all fine on that front. So I'm going to drag a forced speed volume into the map. The quickest way for me to test this is to actually put it in here so that I can see that it's working. So if I drop this in here and I was to point this way, we can see that this is now encompassing this entire area. Before I hit play though, I just remembered I've made another mistake. I'm going to go back to my force speed volume. I got a little eager when I added this. I forgot to set delta time or interp speed. That was a good trick. So I'm going to say the interp speed, just going to set it to 100, and delta, I'm just going to say get the world delta. So remember, delta is the time between ticks for this object. Compile, save, and this should now function. Good thing I caught that before hitting play. Now if I hit play, you can see the object is now bouncing into that zone and getting some speed as it shoots back. Now the amount of relaxation that we want to put on that is totally controllable. If I set this interp speed to be 20 instead, and hit play, it's a little bit less. Interp speed, and I set it all the way just down to 1. So that wasn't enough. So a good idea here is to actually promote this to a variable that can be set on your own asset. So I'm going to call this the adoption speed, for lack of a better word. And the default value of adoption speed is just going to be set, let's try 15 or 20. 15 sounds good. Compile, save, play, play. I saw I got that initial burst as it dropped into it, and that was about what I wanted. Now a good area of use for this is I know I always want a ball that's coming through here to go out that direction. So if I was to get this, pop it up to here, rotate it to there, and now I'm going to shrink it back down a bit. Any ball coming up into this area is now going to go through this area and pop through that. I might thin this out just a little bit as well so that we don't force the balls into the edges of that, but this should work. So that went straight through, and we should be all good. So with that, we have essentially the last prop. It's time for us to now start looking at the last game function, which is the tilt function, and from there we can then move on to aesthetics, and this project will be complete. So let's move on to the tilt function. So we're almost there. We're moving through and we only have one last game feature to add before we can move on to aesthetics, which is putting in tilts. Now for anyone that's unaware of how pinball works, you're allowed to shake the table a couple of times before it basically stops you from doing so, and the game's over and the flippers no longer work. So what we're going to do here is we're going to add in a tilt feature, which is going to be reasonably straightforward. And the first part, of course, is going to be going into our project settings, and I'm going to go to my input, action mapping, and I'm going to add left and right tilt. So we've got left tilt, right tilt, and I'm just going to bind these to my left and right arrows. So now we've put in left tilt and right tilt. I'm now going to go back to here, and I'm going to open up my player controller. Initially, let's set up the functionality for doing a tilt, and then let's go back and work out how we want it to affect the game. So initially, we just want to do the tilt left and tilt right. So I'm going to add the events. Now, to begin with, all I'm going to do is rather simple. I'm going to, when you press tilt, I'm going to get all actors of class. And I'm just going to get any balls that are currently in the map. So I've got the ball, at which point I'm going to check if this array is greater than 0. So I'm going to get the length of it. And I'm just going to make sure that there is at least one ball on the map. And if there's more than one, all I'm going to do here is, and again, this is just kind of allowing for multi-balls in the future. I'm just going to say for each of the balls that are in there, let's add an impulse to it, to the ball. So we're going to project the ball in one direction or another. And just purely out of just an initial test value, I'm going to set this number to be -500. Now, the last thing that we will do is actually add a camera shake, but for the time being, I'm kind of okay with this. So if we wanted to as well, I could get all of this and I could collapse it into a tilt direction. And if I wanted to, I could collapse this into a singular function that left tilt and right tilt call. To do that, all I'd have to do is select all of them, right click, and I would now hit collapse to function, which is now going to be called tilt. So we've now got a tilt function, but there's one other thing I'd like to do here, which is, if this is a function, we probably want to change the impulse such that it works depending on whether it's left or right. Now I'm kind of going to just hijack one of the enums we already have here. So, because if you remember before, we had an enum that we created which was used for the flippers. Now the enum that we used for the flippers, if I open them up, was used for determining whether it was a left flipper or a right flipper. So we had flip type as an enum. So what I'm actually going to do is I might actually just hijack that enum since it is left or right, and since I know we're going to be pushing it left or right, I'm just going to make that a little bit more straightforward. So I'm going to go add a new variable to this function that we created, which is going to be called flip type, and it's just going to be called tilt direction. And the reason that I'm doing this is that this impulse we want to select depending on the direction that we're going in. So if it's left, we want to go -500, and if it's right, we want to go 500 on the X. So rather simple. The other thing that I'm going to do is I'm going to check velocity change here, so it doesn't care about the weight of the ball, it just kind of pushes it regardless. And of course I'm going to add a reroute node here to just clean this up a bit. Compile, save, and if I look at my event graph, I'm now able to duplicate this. You can see that the variable is exposed, so I'm going to go left is now right. So we now have left and right tilt, compile, save. Now, I'm going to play, and if I hit left and right now, you can see that when I hit left, the ball's going up in that direction. So that works reasonably well. It's not great, but it'll, part of the reason it's kind of weird at the moment is, so if I just mash the button right now, it's going to fly up in that direction because we're adding an impulse. So we don't want to be able to do that. We want to have a minimum time between tilts, and we also really want to kind of have a maximum number of tilts that you can do. So what I'm going to do is I'm going to expand this function, which at the moment is just assuming that you can tilt. So I'm going to go to tilt, and before I even do any of these get actors of class type of stuff, I think it's probably a good idea for me to check with the game type to see how many tilts have been done and whether I'm still allowed to tilt. So I'm going to open up my game mode. I'm going to add some extra work into there. So we now have a new variable, which is going to be called tilt count. And it's going to be an integer because we're just counting in whole numbers. And the default value for it is going to be 3 because we're going to allow ourselves to do 3 tilts. And one thing I'm going to do before I forget is when we reset the game, I'm going to make sure that one of the variables that we reset is going to be the number of tilts that we can do, which is reset game. It's a function just over here. So I'm going to make sure that when we reset everything, I'm going to compile, I'm going to make sure that I set the tilt count back to being a value of 3. So I'll plug this into here, and you'll notice that when I've done this, this hasn't actually updated. This is one of those things that if you duplicate the node, it'll correctly reaccess it. And I believe if I was to relaunch Unreal, it would have been fine, but for some strange reason, it doesn't always load the values straight out. So I've just duplicated that, and tilt count is now back, so that when it resets it to default. So compile save. All I'm going to do now is just have since we're storing this in here, I'm going to go into my player controller and I'm going to get the game mode. First off, I'm going to cast it to a pinball game, and this should always return true, so I'm just going to convert it to a pure cast. But all I'm going to do here is I'm going to check the tilt count, and if it's greater than 0, so if the tilt count is greater than 0, run through the function. There we go. If it's not greater than 0, then I don't really care too much. So we don't want to actually run it. So we're going through there. Now, one thing that I can do is that if that's false, if I wanted to, I could theoretically put in something in the game mode to disable the flippers as well, which is what a lot of pinball machines do when you go over the most amount of tilts. So all of a sudden the flippers would freeze up until the game has begun again. It's up to us whether we want to do that. To do so would require just adding a boolean to the game mode that we check against before we call flip in the flippers. It's up to us, but for the time being I'm going to just basically check the number of tilts that we've got, and if it's still above the threshold, we'll allow it. Now, after I've gone through all of this and I've completed this, the last thing that I'm going to do is I'm going to get this game mode again. Decrement, minus minus. So we're just removing a tilt. There we go. Compile save. So now that that's set up, we should be only able to do 3 tilts. And I'll check that now. 1, 2, 3. And now my tilt's no longer working. Cool, fantastic. So we now have a functional tilt, although it's not entirely how I want it to be, which is to say it's currently missing a camera shake. So at the moment when I tilt the screen, I really want to get the whole world kind of tilting with me to make it look like everything looks like it's been shoved in that direction. So what I'm going to do here is rather straightforward. Once I call this function to add the impulse, the other thing that I'm going to do here is call a function called client play camera shake. Now, a client play camera shake looks for a shake class, which is what we can set up as a basic set of variables for what a camera shake is. So I'm going to have to go back to here, and I'm going to create myself a new camera shake. So I'm going to right click, I'm going to create a new blueprint, and if I tap on the word shake, you'll see that camera shake is available under all classes. So I'm just going to select that, and I'm going to call this tilt shake. Now, when it comes to the variables for the tilt shake, the first time I double click on it, it's going to give me this, which is the standard blueprint layout. And it's got all of the graphs and everything else. A nice thing you can do is if you were to close that and then double click on it again, it would become just the default properties, which is really all we want. So it's a little bit cleaner to look at it this way. So I'm going to open this up and I'm just going to quickly set up some settings. First off, we want the oscillation to last for 0.25 seconds. Next up, we want to set up the y-axis oscillation, which is sideways for us, and I'm going to set that to 500. So that's 500 units in that direction, and a frequency of 1 means that we go there and back, so it's a full sine wave of there and back. So now that we've got that, I'm also going to set the offset as being 0 rather than random, because we want this to be the same kind of tilt every time. I'm now going to compile and save, and that should be all that we actually need to get this initial tilt working. So in my player controller, I'm going to set this to be tilt shake. And the other thing that I'm going to do is, see we have play space? When I go to the play space, I can actually set it to camera local, which means we're moving the y-axis, world, which means we move the camera along the world axis, so 500 along the world y rather than the camera y. But then there's also user defined. Now user defined is a very useful one for us to use in this situation, because if I wanted to, I could actually go ahead and set it up so that we can use the same shake to tilt both left and right, because tilting to the left is the same as tilting to the right, but just rotated 180 degrees for the play space. So to do that, what I can actually do is I can actually set this up to have a select on it, just like before. So I'm going to use this node again that we had. And all I'm going to say is if it's the left, then let's go ahead and get the camera. So get the player camera manager. There's a nice little function called get camera rotation. So if it's the left, we want to use that. And if it's the right, we want to rotate this camera by 180 degrees, which I can do so by combining rotators. So if you imagine the first one is just getting the rotation and the second one is rotating it 180 degrees on the yaw, which is the z-axis. We've now got ourselves a function that should move the camera left and right accordingly. So I'm going to save, hit play, and now when I fire the ball and I hit shake, you can see that we've now actually got the tilt happening until I can no longer tilt anymore. Everything else is good. So from that, we've now got the last of the actual gameplay features we wanted. I would strongly recommend trying out some stuff, like putting some blocking in there, so that when you hit the max tilt, we go ahead and we stop it from tilting anymore. Easiest way to do that is to use this false node to set up a boolean that connects to a branch, but I want that to be something that participants work out on their own. So moving on to aesthetics. So it's time to make everything start looking a little bit nicer. And the first thing that I'm going to do is I'm going to quickly go through and fix up our lighting setup and our fog and everything like that. That's kind of legacy from when we first started the project. So I'm going to go to my world outliner and I'm going to just delete my atmospheric fog. Now that I've done that, the next thing I'm going to do is click in the background and just delete these clouds. For my directional light, I'm going to click on this and I'm going to start configuring this in a way that it's actually going to be not casting as strong of a shadow, but rather something that's a little bit more kind of, not quite straight down, but only a little bit of a shadow getting cast onto the playfield. Now it's a good idea at times like this, I'm going to hit play, and then I'm going to hit stop, and then after I've clicked on the screen, I'm going to hit Control 1. And the reason for that is that actually bookmarks where the camera currently is. So if I was over here checking this out, looking at that, and then I hit 1, I can always just see what it's going to look like from a play perspective. So now that I've added that in, let's have a look at some other things that I need to do. Well, first off, I'd really like to be able to see this area a little bit better. So I'm going to start tinkering with this camera and putting it into a position that I think is going to be just a little bit nicer for play. So I'm going to move it up top, and I'm going to tilt it down just a little bit. And the other thing I'm going to do here is when I grab here and I pull it back, initially I'm going to pull it back a little bit too far. But you can see here that we have field of view, and if I change this, doing this and pulling it down this way actually kind of changes the lens a little bit. And more importantly, by dropping this to about 80 degrees or so, it actually makes this entire world closer to being an orthographic camera, so it makes it closer to being like a more flattened out perspective. When I hit play now, you can see that the camera ending up in this position has made this channel far more visible, and I can still see the rest of the world reasonably well. So you can see my settings over here if you want to use them, but I think that's probably a good move. It's also a good idea here to bookmark the new camera position, so I'm going to hit Control 1 again, and don't be afraid of like changing this around. You can leave different like Control 4, 5, 6, 7, 8, 9, 10 for different perspectives. For instance, if I was going to have the menu in the game over here, I could hit Control 2, and then I would have 1 and 2, and I could switch between those positions as I'm mapping and modifying and changing things. So with that in mind, we've got a rather simple setup for a camera. Let's actually go through and start setting up everything else. Now the first thing I'm going to do is add a frame around the table, just something to make it look a little bit more like an actual pinball table. I'm going to go to my pinball assets, and I'm going to import the asset down at the very bottom called table frame. I'm just going to drag that straight in. And I'm just going to click import. For this asset, actually, I'm also going to disable collision because it's purely there for aesthetic reasons. And you'll notice that we now have a simple frame. So I'm going to drop this into the world, zero out its x-axis. It's a good idea to change your snap grid at this point. I'm just going to zero out all of the axes, actually. So now that we've got that in, I'm now just going to scale it across and then start positioning it just so it's a little bit nicer with where it sits. It's a good idea to go into unlit mode if you're trying to get it scaled up correctly. Alternatively, I can click here, I can go to my top-down camera, and I can see whether it or not it's fitting the frame. At the moment, I can see pretty clearly that it's not, so I'm going to tinker with that first and go 1.4. Oops, these were scaled in the process. So 1.4 seems like it'll work. We kind of want this to be sitting... We want this to be sitting here, but this to be here. So 1.4 is a little big. 1.45. That seems pretty good. And now for the y-axis, I'm going to change that to be just a little bit lower. I'm going to try 0.9 initially. 0.925 seems pretty good for my setup. This is going to change depending on who's doing it. So I'm not too concerned. And when I go back to it here, I go back into lit mode, hitting play, that gives me this. And I can see it's probably a good idea for me to change my directional light around as well. And another option that I have here is getting the camera. Now, if I want to pull the camera directly back, a nice technique is to click here and switch it into local space, at which point I can actually just pull it directly back, which I just did then. And that does look a little bit nicer. So I'm now going to fix up my lighting. I'm going to turn this back into world space. I'm just going to give it a little less. There you go, that looks quite nice. Another potentially good idea here is to add in a light source for a general skylight. Now initially the light source isn't actually going to capture much and it's not going to look right. And that's because it's trying to capture the scene around you to create ambient light. Because we don't actually have one, my suggestion is to switch it from being captured scene over to being a cube map that's been just pre-captured. And once I do that, I'm just going to select a cube map that I think will work. My gut says that sunset could work. Alternatively, epic quad panorama gives you just a little bit of ambient lighting kind of bouncing around. I'm also going to turn it down just a little bit from being 1, so that's the difference between them. I'm going to push it down to about 0.25, just so it's bright. 0.3, so it's brightening things up, but not by too much. So we now got this. So that's starting to work. And at this point, I think it's a good idea for me to also start considering how I'm handling the brightness of the scene, because this is not actually going to really require any post-processing beyond like some bloom. I'm going to go ahead and drop in a post-process volume, and I'm just going to move it across to the side so it's easy to find. I'm going to tell it to be unbound, which means you don't have to be inside of the volume for it to take effect. And then I'm going to go down, and the first thing I'm just going to disable straight up is going to be the eye adaptation, which is auto exposure. So I'm going to go to that, and I'm just going to tell it the low percent and high percent. You can see the values that are set up here. Now, the way that you can kind of turn off exposure by default is if I set the min and the max brightness to be the same thing, it now won't adjust. If those are equal to one another, it completely turns off the feature. So that's actually good for us because it means I can use that to balance everything else out. In this case, I can see that, yes, I did put in the skylight before, but when I turned it down, I was turning it down as a way of compensating for the adaptation that was going on. So I'm going to turn that back up to 1, and we've got this. A little bit nicer. Cool. Just going to make sure that this is all good. see that I'm not particularly good at pinball. There we go. So this all works, everything's fine. I can see that my multipliers are still good, so we've got a score that's racking up, and I've got an environment that's starting to look a little bit nicer, but let's actually get this going another step forward. So the next thing I want to do is have an environment along here that kind of looks a bit more like a glossy wood. And a good way for me to do that is to go back to my assets, and I'm going to import the texture that we use called fibers, which is just t_fibers. So I'm going to drag that in. Now the fibers texture looks like this. Oops, just loading up. But we're going to use this to make ourselves a basic wood material that we can use as a way of having like a nice backboard. So it's a little ugly now, but it'll be good in just a moment. I'm going to right click and create a new material that's just going to be called m_tabletop. Capitalize the T. And within this, I'm now going to start setting things up. So the first thing that we need is a color. So this is going to be, I'm going to hit V, and I'm going to make a parameter called table color. And this is going to be, I think a deep red would be nice. I'm going to get rid of the green values from this to kind of make that kind of deep red. So 0.2600, that's what we have. Now if I was to just plug this into my base color, hit apply, save, we would have ourselves a very basic table color that we could use. And you know, that's actually kind of a nice color to have, so I can look at that and see that it works in kind of an interesting way with the yellows. But let's go a little bit further. So let's go ahead and actually add those fibers in to make it look a little bit more interesting. I'm going to add a texture, going to type in fibers. Now that we've got the color and the first fiber texture in, I'm going to basically add in a thing that says I want 10% of the fiber to be added to the table color. And a nice way to do that is with a lerp. So if I connect this with this, we would end up with a blend between the two. So you'll see it on the left hand side as I go. Now that's initially going to be white. But what I actually want to do here is I want to set the value of the fibers being kind of blended into it as if they were also colorful. So instead of lerping this against this, I'm going to multiply the color against the fibers first off and connect those two. So you can now see that it's a bit more like that. And now the next thing I'm going to do is I'm going to get the alpha, and if this was equal to 0, it would be all that. If this value is equal to 1, it would be all that. Instead, I'm going to set this to be about an 0.1, so there's just a little bit of the fibers coming through. And I'm going to convert this to a parameter just so we can change it later if need be. I'm going to call this fiber blend. Now the other thing that I want to do is I want to make this look not just up and down the grain, because if I hit apply and save and I look at this, what we have right now is that, which is just running up and down, which looks okay, but it's not the final result that I really want. So I'm going to get this, I'm going to duplicate it, and this time what I'm going to do is I want to have this going sideways, not just up and down. Now, the common thought here is to rotate, add a rotator and move it around that way. But there's a nice function that if I hold down U and left click, this gives me my X and my Y coordinates that are going to be going onto this image. And I can use a function called swizzle, which lets me swap the X axis with the Y axis. And if you think about what that does, it actually makes the image go sideways instead. So I'm going to multiply these two against one another. And I'm just going to increase this blend initially so you can see it a bit better. You can now see that we end up with this kind of pattern going on instead. So I'm going to set this up to be 0.25, it's looking a little nicer. Save. And that's a bit nicer for me. The other thing that I think I kind of want to have going is I want to control how big these are. At the moment these are very small little lines, but I wouldn't mind them just being a bit bigger. Now I could just get this and plug it into, I could just increase the coordinate size here. But it's always a good idea to parameterize stuff like this. So what I mean by that is if we multiply the texture coordinate size against a number, we can actually change the scale of that number. So if I get this number and I plug this into a multiply, when I get this, if I multiply it against the number 5, for instance, you can see it's, I'm going to make this a bit clearer by just changing this up to 1 again. If I multiply it against the number 5, it'll be here. 1 is here. 0.2 is here. So you can see that a smaller number makes it a larger texture. So I'm going to go, for the time being, 0.25 we'll try out. And I'm going to set this blend back to 0.25. Which looks a little bit nicer to me. We've now got like a nice red wood that we can use. If I wanted to as well, I could use the fiber to change how this is reacting for the roughness values. But to be honest, the base roughness actually looks quite good, I think, for the table. So we've got that going. I'm now going to go through and set the rest of this up. I am going to quickly just match the colors between everything by going to my assets. I'm going to drag in this tabletop material onto all of the floors so it's consistent. Now if I look at these, it might be hard to see, but they don't entirely align. If I control click on all of these and then I go to alignment, align surface planar, it actually puts all of them so that they're perfectly aligned with one another. I missed a surface just then, so that was a good trick. But if I click alignment, align planar, they actually now all match one another so that they all blend in correctly and there's no seam, which is a nice little technique. So I've added this initially. Next up, we're going to look at how to add some decals so that I can start just adding in some cool symbols and stuff along the board. What I'd advise for the time being is spend some time just dropping in some materials so that you can kind of set up the board in whatever way you see fit so that we've got some color in there for the actual frame. I'm just going to go through and do that myself, but for the next session, we'll meet up and start doing decals. So I've gone ahead and done a very quick pass in just making the thing look a little bit better, just getting some block colors in there and that kind of stuff sorted. Now the next thing I'm going to be showing you is going to be the actual decals. And we're doing this because at the moment we have a reasonably blocked frame. You can see that we have a reasonably blocked out frame. We have, well, I mean, just an environment that could look a lot better. So let's start kind of getting some arrows in there and some symbols, some logos, that kind of stuff. So I'm going to go ahead and I'm going to import two textures we have. I'm going to import Decal Pack 1 and Decal Pack 2 textures. Now these are textures I've made ahead of time, and I'm going to show you how they're set up. They might look a little bit ugly at first, but I'll explain what's going on. If I open up Decal Pack 1, we have this. But if I look at what's going on here and I turn off the channels, the red layer looks like this. The green layer like this. The blue layer like this. The other thing I can do here, if I want to try and improve them just a little bit, is I can go down and tell these to be masks, so they know that they should be set up in that way. So these are all packed into a single texture where red, green, and blue signify different images, and I've done the same thing for a second set for Decal Pack 2, which is just here. So what I'm going to do from here is I'm going to create a new material that's just going to be called m_basic decal. And we're going to instance this for other things, but for the time being, basic decal is literally going to be a texture. So I'm going to hold down T and left click. I'm then going to set Decal Pack 1 as my texture. Now we're going to need some way to select which of these colors we want to use. The easiest way for us to do that is to use a component mask param. So if I drag this in, and this comes into here, this parameter lets us choose red, green, or blue from a texture. So in this situation, I'm just going to have this selecting the red channel, and I'm going to call this decal channel, so we can change this to whatever we want. And the other thing that I'm going to do is hold down V, and I'm going to have a decal color. And this by default is going to be, let's go with something that's slightly, oh actually the blue could look nice. Let's just go for that for the minute. And how this is going to work is this is going to set the opacity of my decal, and this is going to set the color of my decal. So to set this up as a decal, what I need to do is I need to set this to be a deferred decal just here. And you'll see that when I do, if I go base color and I plug you into the opacity channel, I now also need to set the blend mode to be a debuffer translucent color. Now at the moment what we have is a slight issue where it's not going to work because opaque needs to be changed over to translucent. So it needs to know that it actually is a translucent material. And you can see that we've got this now appearing over here. So if I were to hit apply, save, and just quickly test this asset, what I would see would be this. If I got this, and I added a deferred decal into the map, and I set the material to be equal to my basic decal, you can see now that we can paste things in. Now this is a reasonably low res image that I've used for my decals. It's just a 512 by 512. So we could up the quality here if we want to get something a bit more substantial. In this situation, the more I look at it, the more I think that it would be a good idea as well for us to use a white as a basic color instead of a blue or anything like that. So I'm just going to go out and set this to 111 so we have a white standardized texture. Good. And the other thing that I'm going to do to kind of just clean it up a little bit is at the moment you can see that there's some artifacting going on from the texture itself. And there's different ways that we could clean this up, but the easiest way for us to do it is because we're using a hard mask for every single one of these textures, it means that we don't really need to care about any gray values. So what I can do here to kind of clean it up is I can run a power and plug that into the opacity channel here and just crank the power up to like 4, and you'll notice that it should start getting rid of some of the jaggies along the edge. Now the alternative to me doing this is to multiply by a small number first, say 1.5, and then clamping that at the end. So essentially what we're doing here is if any values are very gray, so they're very close to being the right color, it's going to grab them and push them up so that they're all there. I'll show you what that looks like. And then when we power it, it's going to then make anything that's below white darker, and the clamp is then going to just clamp it off this way. Now this still has some issues with it, and ultimately at the end of the day, the better solution is to actually set these textures up as a higher resolution if we want to try and save memory, but this will do for the time being. So we've got our first very simple decal in, but how do we make the others? That's rather simple. I'm going to create an instance, and I'm actually going to make a couple of these, including one that's actually just a blank instance, purely for us to have something to work with here. So it's going to be called mdecal_ straight arrows. It's going to be the first one. And this is actually just going to have these options enabled, but not changed. I'm doing this so that if we ever modify the base, I still have one for the arrows. So I'm going to change this basic decal to be straight arrows instead. You'll see no change whatsoever. So this one here, I'm going to put here. And I want to set this up to be, at the moment it's at -220. So if I were to drag this and just change it to 220, you'll see that we have this nicely set up. Somehow this isn't quite at the same point, so I'm just going to move this over a little bit, just so it's a little better balanced. Cool, so we've got that set up now. We've just got some basic arrows kind of pointing down. The next thing that I'm going to do is I'm going to duplicate this, and I'm going to make this new one called decal_curved arrows. And if I double click on that, I can now change this channel to be a different one. If I want to see this a bit better, I can make this a box. So at the moment, this value is equal to the red channel, but if I swap this over to be the green channel, we get that instead. So save. And now again, if I want to drop in a deferred decal somewhere, while that's selected, I'm able to kind of place in some nice little arrows. One. It's always the last one you check. There we go. So I've now got some base little arrows there. Now be aware that these will project onto everything. So if you look here, you can see that this is actually projecting onto these surfaces as well. Sometimes you want that, sometimes you don't. But the easiest way to fix it is to just simply change the scaling along that axis So if I hit spacebar twice, I can see that the axis that's up and down is this red one. So if I change that to 0.2, it's now only going to be painting stuff in that region. So the decal is only going to be projected in a very thin area. So again, I'm going to go here, 0.2. And I'm going to do it for these as well, because the other thing that they will decal right now is if the ball were to go over them, they would actually spray onto the ball dynamically. So that looks alright. It might be a good idea for me to tweak things off, but this is good for the minute so you can kind of get an idea as to how it looks. I'm now going to create another one, so once again I'm going to duplicate, and this is going to be duplicated to be equal to the edge, just kind of like a generic tech edge piece. So this is going to be equal to the blue channel, save, and if I drag in a decal, you can see that we've now got that tech edge kind of going on up there. So this is rather simple. What I'm going to do next is I'm going to bring this across, and once again, so you can see there that it's projecting onto all of the assets here. So the spline mesh is getting it as well. Can right click here, and I'm just going to mirror it on this, mirroring on the local Z, which is timesing this one by -1. And I'm just going to make sure this is kind of nice and tucked away into the corner, just for it to balance the others. It's good enough for the minute. I'm going to set this to be 0.2, as we've been doing. So we're starting to get some general tech kind of look going on. I'm going to duplicate this one and make it the generic stripes. So this is the decal underscore, which is going to be called stripes. Now, at the moment this is actually missing a parameter. What I haven't done is I haven't set the texture parameter that feeds in the texture as a parameterized section. So I'm going to go back to the basic decal, and I'm going to right click on this and convert it to a parameter. And I'm just going to set the parameter name to be equal to decal map. I'm going to save that. And then if I go back to stripes, I can see the decal map is now an option, and I'm going to set it from 1 over to 2. So I'm going to save this, and I can now drag that in to have kind of like a warning area that I can use as my as the decal down below. So I'm going to get my deferred decal, drag it in, and I'm just going to quickly set this up to be along this bottom row. I don't mind condensing these lines down a bit because I think it still looks okay. So I just want to kind of put that there. Zero it off so it's in the middle. And I'm just going to set this up to have a little bit of a gap. Final setting is going to be making sure that the x-axis is zeroed out to much smaller. Much smaller. So just quickly setting that up so we've got something to work with. Now the next thing that we're going to be going into is a slightly more advanced form of decal. So come into the next lesson and I'll show you how to do debuffer decals that actually change certain parameters beyond the color. So we've gone and added some very basic decals, but what I want to do now is something a little more interesting. We're going to actually start using decals to modify more than just the color property, and to do that we need to actually go into our project settings, into our rendering settings, and we need to enable a feature that's not on by default. What we need to enable are debuffer decals. So I'm going to go to there and I'm going to type in the word decal, and you'll see that we have debuffer decals. Now if I enable this, be aware I'm going to need to restart my editor. So I'm going to do that and then follow along from there. So we're back now, and you'll notice that it's going to seem like everything's broken, but that's okay. What's happening is, unfortunately, when you enable debuffer decals, the engine needs to actually go ahead and recompile every single shader. So it might take a minute or two for it to adjust, but I promise you that the results are going to be worth it. What we're going to be doing from here is actually setting up a decal that modifies more than just color. It modifies either metallic or roughness as well. So what I'm going to do is I'm going to use the two Unreal textures that we have here, which are number one. I'm just going to show the two channels. So the red's this, which we've used already. green is a kind of a fat version of the logo, and blue is the logo itself. Now the reason that I'm doing it this way is so that I can use this green section as kind of like an outline, and the blue is the inside. So we've gone through, and it's gone and rebuilt all of its shaders. What I'm going to need to do now, though, is I'm going to duplicate basic decal. I'm going to make this new one called advanced decal. I probably could have a better name, but this will do for what we need to have done. Now, what I'm going to go to is, if I scroll down here, you can see we have decal blend mode. Now, at the moment that's set to translucent, so it purely puts out just that one texture. However, if I want to, I actually have a whole bunch of different options here. In this situation, the one that I actually want to change is color and roughness. So if I go to this and I set up color and roughness, this will now actually let me set a very smooth surface for the ring of one decal map and set up the other as the interior color. So what I'm going to do here is I'm going to change decal map to be pack 2. Now that's going to be setting up the, if I go to view all, for the time being I'm just going to set the roughness as a default value of 0. And from here what we need to do is I'm going to just demo it in the world so you can see what's going on as we create it. So I've created the decal. Once again I'm going to drop it in as a decal setup, and I'm going to set my advanced material to this. Now at the moment advanced decal is running off of that, and that's okay. But what I'm going to do is I'm going to quickly show you what this would look like if, instead of running the opacity through this channel, I was to run, it's weird that hadn't updated, but instead of running the opacity through this channel, I was to just use that exclusively on roughness, just so you can see it. Apply. Okay, so we can see this a little bit better now when I set it to black, but you can see that we now have shiny, not shiny, shiny, not shiny, shiny, not shiny, which is a nice little setup. It means that we can kind of use those in different ways. What I'm going to be doing here is I'm going to set up the base color to be equal to the Unreal, whatever Unreal logo color we want to have. I'm then going to, I'm then going to set that up so that we have that on a separate mask param, just in case. So there's going to be an inner layer and an outer layer. So I'm going to rename them accordingly. I'm going to make decal map 1 and decal channel 1. Oops, that's a good trick. And what these are going to do is they're going to set up the basic opacity of the material itself. So I'm going to plug that into here. Now, because I know I want to run off of some reasonably basic channels here, I'm actually going to go ahead and preset this up to use the green channel, because I know I want that to be the main channel. Oh, sorry, not green, blue. So we've got the kind of fatter one as the general opacity. And I'm going to set the roughness for that one to be equal to a lerp, where if it is equal to channel 2, it's going to control roughness of one value versus roughness of another. This will make sense in just a moment. Actually, I can leave this as being between 0 and 1. So we've got those, we've created them. I'm now going to go ahead and duplicate what we have, and I'm going to rename them. Make sure you rename these before modifying them, otherwise it'll modify the same titled assets, nodes. So we've got channel 1, and I'm going to set this to be using blue. And if I stop preview, what we should see, if I look at it from this point onwards, is we've got channel 1 has that, channel 2 has a separate roughness. So if I go apply and save, this is going to come through here at the moment, but if I look closely I can see that that outside there has a separate color. Do you see how that's getting kind of a shine to it because the roughness values are different? Let's go on and actually improve that a bit and use this asset here as a way of deciding which color is which. So whatever comes out of this controls decal color 1 and decal color 2. So if I plug that in to here, A and B, now I'm going to just preview this node so I can see it a bit better. If this was to be dropped down to here, we'd now see that the Unreal logo would be black and the outside would be white. So if I apply and drop this into the world, you'll see that we get that. If anything, I actually kind of want the opposite of this though. I want to have a shiny black metallic for the outside and an interior that looks a little bit nicer. So I'm going to swap these values around. I'm going to push you up to be white, and I'm going to dial you back to be black. Which is then going to give me that. So we can then use this as just a basic logo that's kind of in the world. I can have this however I want it to be. Some very basic stuff. But these decals are very, very useful because they let us do some really interesting things. If I go to here and I show you the blend mode, you can see that these are all the parameters that we can change in different ways. Now, the color and normal and roughness are incredibly useful because it means you can use decals to add just a very subtle bump to the surface. So I could make it look like a hatch was hidden away there that was just slightly difficult to see. You know, I can add all sorts of additional lighting details that normally wouldn't be there. So this is very useful, and I strongly recommend messing around with them in your various projects. This was obviously just a very quick approach to it, but it's enough that hopefully you can see where the power of it is. I'm going to just set these up to be a little bit bigger, U to 0.1, and I'm just going to put this up on the top. And that's it for the basics of that project. We've now gone and added various bells and whistles, and we have ourselves a simple game. The final thing that we're going to be doing is working on the user interface and just extending it a little bit further so that we have some nice animations for things as they take place. So let's look at polishing up UMG, so making our UI substantially better. At the moment, if I click play, that's what we have. And it's not really that pretty. Really what we want to do is make sure that anything that's in there has like a nice level of polish. So what I'm going to go about doing is setting up a main menu that actually looks reasonably good. So this time around, I want you to go to your assets folder and create a new subfolder. So I'm going to right click, new folder. I'm going to call this UI. And I'm going to import these from my textures UI folder. So both of these, just drag them in and import them. Now you can see that we've got two textures here. One is the back plate, so that's what we're going to have for the core of the main menu. And the other section is simply the logo itself. And I want you to double click on each of these and set the texture group to be UI. Save. Double click, UI, save. So now that that's good, let's go to Blueprints, and I'm going to open up the main menu. Now, the first way that people would think of adding a backplate to this would be to make sure that, you know, they could just drag an image and hope that it all works. However, that's not actually a good way to do this. If I was to drag in an image and just drop it there, and I was to set the image to be the backplate, even if I checked size to content and like ramped the size of this thing up, it's not a good way to handle this. And the reason being is that according to the screen resolution and everything else, it's going to resize itself in different ways. And I'll show you what I mean by that. Let's say I put this here and I set this up so that, you know, the scale was reasonably close to what I had, and I just popped that there. If I was to change the screen to say an iPhone, it would now be all the way over here. If I was to change it to a MacBook, it would be sitting here. So different screen sizes have different consequences for where it's going to end up. And the way for us to fix that is to initially, I'm going to drag this so that the Y's kind of match. At which point I'm going to go to this and I'm going to set the anchor to be this one just here. Now I can see that this isn't correctly scaled, but that's okay. What I need to do is tell that the position offset for X is equal to 0, which will position this left-hand side of it perfectly with the middle. At which point, if I go down to my alignment and I say x is equal to 0.5, this will now automatically put this in the middle, which is nice. Now the other thing that I'm going to do is you can see that we have offset top and we have offset bottom, and I've just zeroed out both of those values. Now the next thing to get this working is to right click on this and go to wrap with and set the wrap width to be a scale box. Now a scale box is fantastic because essentially what it lets us do is tell it to automatically fill the y-axis wherever it can and then scale the x-axis accordingly. And to do that, what we need to do is under vertical alignment, I'm going to click on this button here that says vertically align the fill, and I'll show you what that looks like. If I was to go screen size and change it to something that was in portrait, you can see that the menu is now stretching all the way to the top. However, it does have another issue, and that other issue is that this section here is not being correctly stretched accordingly. Notice how the x-axis is quite thin and that's not actually circular, it's more of an oval. So for us to fix that, all we need to do is go to our scale box, and under here where it says stretch scale to fit, we just tell it to scale to fit the y-axis. And now you can see that the x and the y are kept in line with one another. And it looks a lot nicer, no matter the screen size. So if I change the screen size to any other device, that's always going to look reasonably consistent. So, next up what we need to do is get our scale box. I'm just going to drag it to the top here so that it's the backing. But it's time for us to look at UMG animations. So for a UMG animation, we're going to create a logo that upon launching is going to resize itself onto the screen. So let's look at how to go about doing that. First off, I'm going to get rid of this pinball game text because we're going to be replacing this with an actual logo. So I'm going to delete this, and instead I'm going to drag in an image, and I'm going to get this image and I'm going to tell it that the anchor point is going to be based off of the top center because that's always where I want the logo to end up. And I'm going to tell the brush to have an image that is the logo. And I can type in the word logo for us to find it. You'll notice that, it's automatically kind of done this. A nice way for us to handle this is I can go size to content, and you can see this will automatically pick up the size. The alternative is, instead of doing size to content, I can just tell it that the size X and size Y are given values. So as long as I make sure those are square, we should end up with something that looks like what we want. Now for this, I kind of want to have this sitting about here. So it's going to kind of sit a little off-centered, and then we'll eventually have the play button down here and a full high scores list. 500 by 500 looks okay. I might up it to something that's a bit easier to work out a downsampled version. So I've changed it to 512 purely because the texture itself is a 2048 by 2048, and if I divide that number by 4, which is a nice clean value, I get 512, which creates a slightly nicer image when we've made it smaller. So I've put it there as a 512, at which point I'm going to go ahead and quickly animate this to appear, and then we'll start looking at fixing up the play button and the high scores button. So initially what I need to do is I need to get this image and I need to add an animation for it. So the best way to think of animations is set your initial scene up as to how you want it to end up as, and then when you go to create an animation, you kind of work backwards from that. So I've clicked on the Unreal Pinball, and I'm now going to add an animation, and I'm going to call this new animation Intro. Now within this, I could theoretically change any of the values for any of the assets that are currently in the scene. An animation isn't tied to a single section, like it could be the entire menu is animated in different ways. For the time being, I'm just going to focus on this logo though. So to do that, what I need to do is I need to add the image. Now you'll notice that at the moment we haven't really been naming any of these things very well. So I'm going to go back to this image and I'm going to click F2, and I'm just going to rename this to be menu logo. So now when I go back to add, you'll notice that we have menu logo as an option. So by adding menu logo here, I can now click on this add track button. And the track that we want is the transformation track. So if I click on that, what I'm actually able to do is set up keyframes that allow me to change its transformation values, so its translation, rotation, scale, and the shear. We're going to ignore shear for the time being. I can change those on the fly to do different things, and I'll show you what that means. If I was, for instance, to go to my scale, and I was to select up here at about the 1 second mark, and I was to add a keyframe, you can see that it's added the 2 keyframes here. So what we're going to be doing here is initially we have two values of 1 and 1. I'm just going to drag this all the way back to this initial frame, and I'm going to select this, and I'm just going to set this value to 0 and this value to 0 as well. And you'll notice that now, if I was to play this animation, the pinball logo just goes from 0 scale to scaling up to create something like that. Now, it's a good idea when you're doing these kind of things to kind of add a little bit of a pop. So to do that, all I'm going to do is at this point, so at 0.9 seconds in, I'm actually going to set the scale to be 1.2 and 1.2. And what this means is it kind of gets big and then goes small again. So that's initially what we've got, and this is already set to be a cubic interpolation, which is nice. So that gives it a nice kind of smooth in, smooth out. But if you wanted to, you could set it to linear as well, which is another common way of interpolating variables. I'm also going to get these two keyframes, and I'm just going to kind of move them across just a little bit so I can position them to get kind of a quicker pop. Actually, I might move this way instead. Yeah, that looks a lot nicer. So you can see it goes pop and then comes back down. Great. So that's our initial intro. And if I was to hit compile, save, we wouldn't see that when we played the asset initially. And I'll show you why. So if I go to my pinball game and I hit play, you can see that we had the menu and we had the logo, but nothing played. And the reason for that is rather simple. If I go to my graph, and I go to the section that says construct. Construct is kind of like the widget version of begin play. So if I get the construct and I was to get the animation reference, you can see it's over here, and drag that in. So I get that. I can now call play animation. And if I was to plug this in, compile, save, you can see that on launch, it just played the intro animation, and we had something rather nice. So there's a couple of different ways that we could do this. If I wanted to, for instance, I could go about setting up the main menu to have the middle section slide in, scale in, do whatever wonderful things we wanted. But for the time being, I kind of just wanted that logo to be correct. That's all we need to kind of get some basic animation. If I wanted to go to my intro, I'm able to add new assets to this, so I could get the background plate and add things there too. And I probably will do that once everything is completely 100% set up as a final push, but I'm going to hold off for just the time being. Instead, next we're going to focus on adding fonts. So instead of using this standard Unreal Engine Roboto font, we're going to put in something new. And I should stress here that one of the most telltale signs that a project is still in the prototyping phase is that all of the fonts are still set to Roboto. It's just one of those things you start picking the more you see Unreal Engine projects. So it's a good idea to kind of give it a nice level of polish to kind of move away from that as early as you can. So we're going to look at that for the next lesson. For this lesson, we're going to be looking at adding fonts. So instead of using the standard Roboto font that we have on this play button, we're going to have something new. Now the font that I've selected for us to use for the standard menus and everything else is going to be the font in our pinball assets called League Gothic. And I'm going to be using League Gothic Condensed Italic as my standard font here. So this is a free font available from the League of Movable Type. And to add this, I'm just going to go to my content browser, Assets, UI, and I'm going to drag in the condensed italic font. So just drag in, and this will create a font. Now it should be noted that up until version 4.14, this is what will happen. However, in version 4.15 onwards, it will create a slightly different import in which it will create two font types, a font face and the font itself. Don't be too alarmed, just be aware that you need to use the font face if you're in version 4.15 or above. So I've clicked on this, and I'm going to go back to my main menu, and I'm initially just going to select this play text that we've already created. And you'll see that the font is now available as an option. However, we do have a bit of an issue. If you look at this, you can see that the font has automatically clipped on the left and the right hand side. So to fix this, all we need to do is set this up in a way that's going to make sure that this button is the correct size given the font. So to be clear, this issue is brought on by the fact that it's italic and it's a slightly larger than average character. If I go to this section down here that says minimum desired width, I can actually increase the size of this box. Now it's not going to do anything until it hits the minimum level of where the characters would be, at which point it'll start to increase in size. So in this situation, I'm just going to increase it to about here, and then I'm going to change the justification to be centered. And you'll notice that this is now correctly in position here. Now the next thing that I want to do is I want to set it so that we can't see this button. I want all the functionality of the button, but I don't want this button to be something that's anywhere near as ugly as this. So what I'm going to do is select it, and I'm going to go to the style box. And in the style box, I'm going to set the normal tint, and under here you'll see we have RGBA. I'm just going to set the A to be off, and the other one that I care about is hovered. So again, tint, I'm going to set that to off, and finally when it's pressed, tint, I'm going to set this to off. Now you may be wondering, yeah, but how are we going to know if something is hooked up and selected? But that's okay. What I can do now is I can get this play button, and if I scroll down to the button itself, if I scroll down, there's on hovered. So I'm going to click on that, and we now have an on hovered event. What I'm going to do is on hovered, I'm going to increase the shadow of the play button. Now the other option I have here is I could either increase the shadow by just setting the variable, or alternatively, I could actually create an animation that changed the text whenever we do it. So I think the nicest way is, since we want to kind of blend in the shadow and blend out the shadow, I'm actually going to set this up so that the play button, first off, let's just quickly position this button itself to be in a spot that we want it to be. I'm going to set it just here. Just going to turn that off for the moment so I don't grab it. And I'm going to get the play button, and I'm just going to put this about here. Okay, we're going to get the play button, and first off we're going to name this to be something that's a bit easier to recognize. So play button text. I'm going to add an animation which is going to be called play hover, and all I'm going to do is add play button text. The first track I'm going to add is going to be shadow color, and then the next track that I'm going to add is offset. That way we can control how dark the shadow is and how far it's offset. And all I'm going to do is, in shadow color, I'm going to say that at the 0 mark, all of the values are normal, which have been automatically added. But at the 0.3 mark, let's go ahead and add a keyframe and set this opacity value to be 1. So you can see that it gets a little bit of darkness underneath it. However, we do have another issue, which is that the shadow is kind of close to the object. So at the moment the shadow offset is set to 1. But if I was to go over here and I was to change this value, you can see that we can kind of push where these values end up. So I'm just going to push this across to about 6.2, and I'm going to push this up as well. And now if I was to look at how that runs, when you highlight the button with play, it's going to look like that. So in my graph, all I'm going to do is drag in play hover, and if I go play animation, you can now see that if I was to drag this on hovered, we're going to play the highlight animation. Going to compile and save. Play. And what we've shown here is that yes, it works, but we need one other thing to be set up for this to really work correctly. And that is, we need this to play backwards on unhover. So if I was to get the button again and scroll down, and this time do an on unhovered, I'm now going to just copy and paste the code that I already have for play animation, and this time set it to play in reverse. Now, that is correctly playing and then playing backwards, but we have one last thing that we need to change, which is we need to kind of pause it when we get to that section of the animation. If I was to click on this Unreal logo and scroll to this behavior section, see we have visibility. What's essentially happening is the reason it was kind of jittering on and off is that when I selected this region of the button, it would turn on. But because my mouse was coming from here and across, it would then unselect it because it was now trying to select this Unreal Pinball logo instead. So if I go to visibility, I can actually set this to be hit test invisible. which means that the art is still there, but it no longer gets in the way of my cursor. So I'm going to set that to be hit test invisible and compile, save, and now I'm going to hit play. And you can see that that all works. So we now have the ability to highlight the play button and everything will be set up. So the next thing that I'm going to do is show you how to set up the high scores in the same way. And we'll move through that video in just a second. So this time around, we're going to be opening up the high score widget and setting that up with our new fonts as well. So I'm going to go to Pinball and I'm going to go to my blueprints. And once again, I'm just going to open up. This time around, it will be the high score widget rather than the high score entry. Now, the reason for this is this one refers to the menu that we put on both of the screens, whereas this one is just the final screen. So I'm going to go to my high score widget and I'm just going to set up initially just a heading up top that says high scores, followed by the scores beneath it. Now we already know that the scores beneath it are actually reasonably okay. So I'm just going to set this up to have its font as the font that we've imported. And I'm going to increase the font size as well because right now it's reasonably small. So this will look a little bit nicer. So that'll go there, and I'll just quickly test this out. Now, that there represents our next issue. At the moment, it's scaling up such that it ends up in kind of a weird position. You'd have seen how as it expanded, it kind of went in a strange direction, and I'll show you why that's happening. Essentially, what it's doing is as the text is filling out, this box is scaling itself, but it's scaling itself relative to this position and here. So what I'm going to do is initially let's treat this in isolation. Let's ignore what it's doing in the main menu, and instead copy the score text, hit Shift-Enter, paste, Shift-Enter, paste, Shift-Enter, paste. And we've now got the 4 scores. And we can set that up from here. So I'm going to move this just down a little bit, shift dragging it. And I'm going to quickly add in that last piece of text that will say high scores. So remember to set your justification as middle. Remember to set your anchor as the top center. And set the position of the X to 0, which will put it all the way over here, but the alignment to 0.5, which will drag it back again. From here, I'm going to make sure that the font is set to the font that we want. And I'm going to punch up this to be about a size 85 looks good. I'm just going to move it up a little bit. So that's going to be our high scores list. Once again, I'm going to go through and I'm just going to increase the minimum desired width to be something about there. And I'm going to do that on this box as well. I'm going to push this all the way out to the edges just in case. Compile, save. Now if I was to look at this in the main menu, there will be issues, but that's okay. Play. So the issue here is that it's currently positioning itself off. Now the menu itself has been set up correctly, but it's time for us to fix it in the main menu instead. So I'm going to open this up, and I can see that by just putting it there, and putting in an actual amount of text that's similar to what we wanted to have in the end, we can start to see where the headaches are going to be appearing. And that is that at the moment the positioning of itself is kind of based off of some weird elements that we had in there that looked okay initially, but as the item gets larger, it's more obvious that they're broken. What I need to do is I'm going to set the position X to be 0, the alignment 0.5, and now I'm just going to set the position Y be something around there. And this should now scale reasonably well with the rest of it. We can test this out again, remember, on different screens. So that's correct. That's still correct. Now there may be some things that we would want to do according to the screen resolution, such as adjust the scale, but the positioning isn't enough to actually break any of it. And that's what we care about right now. So that's set up and that's set up. So that seems like it's actually okay now. I'm going to compile, save. Now, what's happening here is that the text that we're inputting actually has one other issue that I didn't account for. And that is that what it's essentially doing is it's adding an extra blank carriage return at the very start of what it does. And you can see what we're essentially getting if I was to do that, which is very close to what we're seeing. So I'm going to have to just go make sure that the function that sets the text, so the get text, which is calculated by generate high score text, that this is correctly doing what it should. And that is that at the moment it gets the old text, it then adds new text, which is equal to the name with a carriage return at the end of it. So essentially when I look at this function, I can see that the mistake that we made was that initially it gets the old text, and when it's the new text, it goes ahead and it adds a carriage return. But that also means that the first time this function runs, it's going to get nothing in the old category because there's no output text yet, and it's going to move everything a line down. And that's okay. That's very easy for us to fix. There's a couple of different ways that we could do this. The simplest is going to be a select node on the output text here. And all I'm going to say, if the array index is the very first index, so if this is the first index, it's going to be name dash score. If that's false, it's going to be the composite. Compile save. Now, that's working. So that's working. There's the obvious issue that in what we've done, I'm allowing for characters that go beyond a character length, but that's okay. We can fix that too. So to get that working, all we need to do is go to our high score entry page, and let's correct this and make sure this is all set up nicely as well. So at the moment, this is what the list looks like when this pops up. It's currently asking for text to go in here, and it's giving us a list. I'm going to get this and drag it just to here. I'm also going to now adjust this so that it's something a little bit nicer when we enter the high scores listing. Now there are a few things that we want to adjust while we're in this screen fixing things up. The first is I want to figure out where I want to have this positioned. Actually, you know what? Let's put this up top because that'll be nicer. The next is that I want to make sure this high score text entry is positioned nicely and that it's the correct font. So as they type it in, it actually looks good instead of this kind of ugly font we've got going on at the moment. So to do that, all I need to do is adjust the font in the text entry box itself. So just going to quickly get rid of all of these sections. Under font, I'm just going to set this up as League Gothic. It's a good idea at this point to consider putting in some text that is test text. Now you can see this is what it's doing at the moment, and that's really not very good looking. So let's get this and let's increase the font size as a first step. So after you've kind of adjusted the font, I want you to set the font size to something that's substantially bigger. Let's go with 70. And I'm also going to just drag this, zeroed out the X position so that it would recenter itself. Now the final thing that we have when we're kind of setting up this kind of stuff is I'm going to go and change this initial text to say enter. Okay, I'm just going to empty that out now, actually, now that I think about it. So that's set up. The issue that we have though is that when people first enter this score, they're going to need to effectively click on this with their mouse. So we set that behavior up before, but what I want to do instead is when we go to the high scores screen, I want to set it up so that it auto selects this. And the way I can do that is under graph, under construct. If I get my text entry and I just drag it in, I can now drag off of that and type in the word focus. And you'll see that we have set user focus. And if I get this and I set this to just be get player controller, which gets us, when I get a high score now, it's going to automatically select that. Now, the final thing that I want to do here is I want to make sure that they can't enter more characters than we want to have in a high score. So I need to make sure that that's set up correctly as well. What we're essentially going to do is I'm going to click on here. We're essentially going to set it up so that every time we put in a new letter, it checks to see whether that's over the character count or not. If it is over the character count, which we could set to say 7, 8 characters, it then is going to remove any additional characters in it. So I'm just going to scroll down and you'll see that we have on text changed. So I'm going to click on that. So all we need to do after clicking on the on text changed is to set the text to actually only be a certain character length. So there's a nice function we can do here. If I get text and I convert it to a string, I'm able to actually then do certain operations on it as a string that I couldn't do with standard localizable text. I'm going to drag off of string and I'm going to type in get sub, and you'll notice that we have get substring as a nice little function. And what this does is this gets from one character index to the length that's given to it and returns that. Now what that means is on text change, if I was to say get start index is 0 and length of 7, I'm then able to get the text entry and set the text to be, there it is, set text to be this. And what this is going to do is that any characters that go beyond this length will be truncated, and it will make it equal to just the maximum length. So what you'll see if I set a high score is compile, save, play. So now, as I keep pressing a character, it's not going to allow me to enter anything past that, but I can still delete. Main, count, and it won't let me go past it. So, hit enter, we're back on there, and everything's great. So that's all it takes to force the text to not go beyond a certain character count, and from now on in, we don't really have to worry about that as an issue anywhere else. So it's time for us to add some particles to this project, and after that I'm going to let the project be, because it's up to you to kind of go out and create your own custom variations from here. But the last thing that I really want to leave you with is the ability to add some simple particle effects so you can have some kind of cooler stuff happening within your environment. So to do this, what I'm going to do is right click, and I'm going to create a new particle system, and this is just going to be called p underscore bumper sparks. And what I'm going to do here is I'm going to create a simple particle system that's going to like explode sparks out of the bumpers, so out of these, every time they're hit. And I think the best way for us to do that is to kind of generate a ring of sparks that are going to shoot out from here and then out around the world. So there's a couple of different ways that we could do this, but to begin with, what I would personally recommend doing is creating a ring, and then we go from there. So the nicest way to handle that is initially I want you to delete your initial velocity, right click, and go down to location. And I know location may not seem like the best starting place, but there's a reason for it, I swear. So sphere, click, and what we're going to do is essentially this initially creates particles popping in and generating them as a sphere. So you can see here that they're in roughly a spherical shape. If I turned my spawn rate up, you can see that they're all just popping into the shape of a sphere. But I don't actually really want that. I want a ring. So instead what I'm going to do is I'm going to disable positive Z. So now we have only half of a sphere, which is the bottom half. And I'm going to disable negative Z. So we now have them all just spawning within here. But the final thing that I'm going to do is I'm going to go surface only, which means only spawn things on the outside of the sphere, or in this case, along the rim. So what we do now is if we check velocity, you can see that when these spawn, they start pushing out from the center. Now that's really useful for us because what we want to do is have a big explosion where they all shoot out at high velocity. And if I were to go down and set this to be 20, you can see they pop out like this. Now it's time that we set this up so that they are all exploding in a big bunch rather than just spraying out like this. And to do that, what we need to do is go to our spawn, and we're going to set the rate to 0. And instead we're going to go down to burst list, and we're essentially going to create a big burst of particles that shoots out at one time. So I'm going to go to this and I'm going to set it to 500, and you can now see that they all spawn at the same time, and it spawns 500 that shoot out all around. So with these popping out, what we're going to do is we're going to vary the speed of each particle so that they're not all just moving at a speed of 20. Instead, I'm going to go to my sphere, I'm going to go to distribution, and I'm going to change it from a constant distribution, which means a single number, to a uniform distribution, which means pick a value between two given numbers. And in this case, I'm going to set the two numbers to be 20 and 30. And you can now see that we get this wider ring of particles shooting out. Now, if I go up, you can see that we have a constant radius of 50, and I want to set this radius to be about 200 instead, because I know that the particle wave is going to have to generate around this, and I know that these are reasonably wide. So I think around 200 is probably going to be a better starting number. And this is something you can adjust to kind of configure to however you want it to look. For instance, I could do between 20 and 10 to kind of get this happening. It's really up to you. But what we need to do from here is make these not look like little crosses and instead sparks. So how do we do that? Well, we create a material for the particle system. Now to do this, what I need to do is, actually I'm going to put my content browser up here. I'm going to right click and I'm going to make a material that's going to be called m_simple spot. Now this is one of my favorite types of materials to create because it's something I use in many particle effects. And that is that instead of generating a round, perfectly circular particle with a texture, I generate it programmatically. And by generating it programmatically, what it lets me do is have a much nicer edge whenever we zoom in on the particles themselves. So right click and type in radial. And you'll see we have radial gradient exponential. So click on that, and what this generates for us, I'm just going to plug this in for a moment so you can see it, is a nice simple radial circle. So we've got this going. What do we do from here? Well, we go and we set the material to not be opaque. Instead, we want it to be translucent. And we don't want this to be the color, we want this to represent the opacity. Now at the moment, because emissive color is set to black, this is popping out like this. I should point out at this point that there are situations where you may want this to be additive instead of translucent, but for what I'm doing, I'm going to set this to translucent for the time being, just to keep it a little more straightforward. I'm going to go shading model and set it to unlit, because we don't really care about any lighting data. And I'm also going to go and set this emissive color by right-clicking, tapping in the word particle, and you'll see that if we go to the very top, we have particle color as an option. So what this lets me do is any particle color that's given within the particle system will output this node. The alpha value is currently not tied to anything. So if I get this and I multiply the alpha against the radial exponential, this actually lets me set it up so that this fades out, which is exactly what we want. So I've added a multiply, which plugs into the opacity channel. I've added my particle color, plugged into emissive color. I'm now going to save this particle system material, and I'm going to go back to my bumper sparks. And it's at this point that if you go to required, you can set this from default particle to be simple spot. Now initially when these load in, they're just going to be white circles, and that's okay, that's a good start. In fact, I'm going to use that to get my color system set up. So at the moment, the color over life, if I click on this, I can view the points that they're currently adopting. So what this means is that at the moment, at 0 seconds of their life, so the very start of their life, these are white. And at the end of their life, they're still white. So if we wanted to, we could adjust this curve here, and we could have them fade from a color back to being white. So if I was to change this number from 1 to say 50, and this to say, there we go, that looks quite nice. So 50, 10, 0.1 were the values I just put in there. Now if I go down to alpha over life, you can see that these are also, over the duration of their life, going between the value of 0, so at 0% of their life, they are at 1 for their alpha. And at 1, meaning 100% of their life, they're at 0 alpha. So these are set to fade out. However, every particle currently lives for as long as the next. So I'm going to change this from 1 to be 0.1 and 3. So the lifetime is now going to have these particles kind of fading out over time. 0.1 might be a little early, so I might change this to say 0.5. And that gets us something that's a bit more like that. Now the next thing is that these particles that are shooting out are unfortunately, well, if you look at them, they're perfectly circular. But sparks really kind of adopt the velocity of the particle that's being shot out of them. So how do we fix that? I'll show you. We go to required, and see we have this section called PSA square. This means that every particle is essentially a square that is pointed right at you. But if we want to, we can click on this and say, you know what, make that square face along the direction that it's currently traveling in, which is what PSA velocity is. So if I set that, and I go to my initial size, I want you to see what happens when I change the X values to be 2 and say 10. So the Y values are both set to 25, and the X is randomly between 2 and 10. You'll see that the particle systems are a lot thinner because they're being stretched along the Y-axis by comparison. And this lets us do some pretty cool stuff. For instance, if instead of going between 2 and 10, let's set this to be 10, 50, and 20, and 30. We now get these particles that are these nice long particles. I might actually crank that up a little bit further. There we go. So I'm going to save this system, and I'm just going to drop it into the world for the time being so we can see what it looks like. So I'm going to go here, going to get bumper sparks, and I'm just going to drop it into the world. Now, this represents one of the first issues that you can really get when you're working with Unreal and particles. At the moment, we're using what's called temporal anti-aliasing, which is a really, really nice anti-aliasing solution, but it does have the issue that it can end up anti-aliasing out your effects because they're so small. So how do we fix this? We go back to our material, and I go to this section here, and I'm going to type into here responsive, and you'll see that we have responsive AA, and I'm going to turn that on. This essentially tells it to not use any anti-aliasing on the particle effects, and you're going to be careful where you do this. You really don't want to abuse it, but you'll notice that these are now much more vibrant when they're popping in, which is good for us. But it also means that when we look at this, we can see how we want this to be attached to the object, and like how big it should be. So if I was to put this here, these particles would currently shoot out at about that radius, which might be a little too big. So I'm going to go back to my bumper, and I'm going to drop the sphere size down to, say, about that, which is looking a little bit nicer. However, I will increase the speed. So I'm going to go sphere between 20 and 30. That's much nicer. So those are now projecting out and looking reasonably good. However, there's one other thing that I want to do. If I go to this and I right click up here, I can go type data. Now at the moment these are all being calculated on the CPU, but if we want to, we can actually push them over to the GPU, which means that they're way less intensive. So if I right click, I can hit GPU sprites. Now the only thing you've got to remember if you're doing GPU sprites is to change this to have a bounding box. You can see that there's a warning popping up at the moment. Now a nice simple way of doing the bounding box is letting the particle system play out, and at any stage clicking up here and click set fixed bounds, which is going to find where the furthest away particles are right now and set those as being the maximum size of the particle system for you to catch when you're viewing it. So I clicked there and I just clicked set fixed bounds. Now the thing with GPU particles is that it actually lets us, if we want to, turn this number up without really having anywhere near as many issues with performance, which can create some really cool effects. But be careful not to overdo it. So for the time being, I'm going to set it to that. And I'm also going to right click and I'm going to go down to collision. And this is another cool thing that we can do. Under collision, we can just set it up so that when these particles hit something, they bounce. So if I view this in the world again, I'm just going to have to drag it back in because I deleted it. If I view this in the world, you can see that when this particle system goes off, those particles would kind of explode out and bounce off of things and create some chaos, which is kind of cool. But it is up to you as to how much chaos you really want to create, so fine-tune this number to be whatever you want it to be. I'm going to set it to be about half of what it is right now, just as a test, and go from there. I'm also going to set my lifetime to be between 0.5 and 2, because that seems like it would have been better, judging by what we just saw. So, the next thing that we're going to do is quickly implement it into our bumper. So I'm going to right-click here, I'm going to edit the bumper, and what I'm going to do here, in the event that is bump, after we add the score, I'm going to right-click, I'm going to type in the word particle, and I'm just going to spawn spawn an emitter at the location. I'm going to click here and select bumper sparks, and I'm going to say the location that we want is the bumper mechanism's world location. And then if I plug this in and this in, we should now be set. Oh, there is one other thing, and you'll see the issue when we're playing, but it's good that you know what the consequences of not setting it up. Now, if you had been paying attention then, you'd have noticed that the systems were playing again and again and again over and over. So to fix that, what we need to do is in the particle system, we need to tell it to only play one time. So under required, you'll see that we have under duration, emitter loops. I'm just going to set that to 1, which means only play one time and then it's completed. Now the other thing that I had was that they were spawning too close to the center of the bumper, and they were being culled out on the sides. So I am, after all, going to go back to here and set this to be a larger size. 150, maybe 200. I'm not sure yet, but let's have a quick look. And that's all you need to do. So go through, develop any particle systems that you want. There's some pretty cool stuff you could do. For instance, if you wanted to, you could add gravity, so I could go acceleration and tell these to start falling down and bounce off the ground. You know, there's some really cool stuff you can do. So have a look around, figure out where you want to spawn particles, and set some things up. You know, when the player's ball goes out, maybe you should explode the ball instead of just teleporting it. When this is a multiplier, let's have some celebratory effects going on there. So that's it for the pinball project. From this point on, I'll show you a couple of examples of different setups that we've had, but we'll be moving on to the next project, which will be a little bit cooler. It'll be featuring an outdoor environment and a little more action. We're going to be developing a top-down survival game now, and this is going to require some outdoor landscapes, which means we're going to need some additional assets. So launch the current build of the engine. And from here, I want you to create a new project. Now, in this instance, I'm going to be creating the project from a blank template. So once the editor is launched up, I want you to go to New Project and just select blank. And I'm going to be calling this Survival. Again, blank. And this time around, I'm not going to bother with any of the starter content. So I'm just going to click No Starter Content because I believe there will be enough from the assets we'll be importing. So, create project, and this will create a new project for us. Now, while this is going, I'm going to go about locating the assets that we're going to be building upon. So, in your launcher, go to your Marketplace tab, and go up to the top, and do a search for Infinity Blade. That launched over the top, so Infinity Blade, and just press Enter. And this will do a quick search, and you'll see that we have a bunch of assets that have been developed by Epic, and these are all free. Now in this situation, the assets that we actually want to be building upon are these Infinity Blade Grasslands assets. So click on that, and then add it to the survival project that you've just created. So just go to here, and click Add to Project, and in this situation, I'm going to do a search for Survival, and the project I'm going to add it to is this newly created Survival project. Add to Project. And now we wait. Now once this is completed, we'll have all of these assets that are in this set in our own game. And this is fantastic for quite a few reasons. Essentially this content was developed for a mobile release, which means that it's all been pretty well optimized and we can use quite a lot of it no matter which platform we choose to deploy to. Since we're doing a game that's going to be top-down survival, it means that we don't really have to care all that much about what things look like when they're super up close, which is really, really useful for us. Now in this situation, this is now finished adding to the project, so I'm going to open up this, and if I were to go to my content browser, I'd now see that we have, I'm just going to click on this button here to open the sources panel, I can now see that we have Infinity Blade Grasslands as a pack that's been added. And if I double click on this, you can see that you have effects, environments, and maps. Now I could open the overview map and see what's there. It's, in my opinion, a better idea to start with how it's being used and then look at the number of pieces they used to create it. So I'm going to open up this Elfin Ruins map for a quick overview and how this content is set up. So here we are, it's loaded up. I'm now going to click on the tab to open the map, and I'll see that I have this around. So hit G to go into game modes to get rid of all of the volumes and such. We can see that we have quite a bit of content here that we can use as a foundation for what it is we're developing. Essentially, I want to have a very similar environment to this that we look down upon from this kind of angle. We can click to send our player in different locations, and we can throw magic and swipe our sword as well. So in this situation, we're going to be developing off of all of these assets, and while this does look like a lot, it's a good idea to go to the overview map that's included with this package. So in the overview map, you'll see that while it seemed like we had a lot of content, there's this amount there. And don't get me wrong, this is all free, so I'm certainly not complaining, but it's great to know what you can do with limited pieces. And we're going to be extending on this with a couple of additions. Now that means it's time for us to start looking at the first stage of all of this, which is to create a landscape using the textures that are included in this pack as a way of having an environment that we can simply paint into. So, move on to the next presentation and check out how the landscapes go together. So in beginning creating our landscape, we're going to go to File, New Level, and I want you to go ahead and just create a default level. Now we're going to be creating a default level so that we've got some basic lighting and fog conditions already in there, but I want you to delete this static mesh that we have in the middle. Now, for this session, we're going to be creating a basic landscape, and this is going to take some time. So initially, this is going to go through the creating of the landscape and how to use tools with it, and it's going to be followed by how to develop more complex materials to use with landscapes. And I've got to be, really stressing this point that properly designed materials are what take your landscapes from being like a 3 or a 4 out of 10 to a 10 out of 10. Like they're really the final step that makes it, and a lot of people overlook them. So it's incredibly important that you understand how to set them up. Now, in this situation, we're just going to be stepping through the basics of landscapes to begin with. But I want you to go to your landscape under your modes panel, and if I right click and zoom out, I can now see that this is what I have here. Now it's going to look a little bit daunting at first, but I want to go through what we have. We have components, we have sections, and then we have quads. Now a component is made out of sections, and a section is made out of quads. The amount that your landscape tessellates, so as you move around, the amount of extra detail that it works into its three-dimensional space, is dictated by the number of quads, which is determined by the number of sections. Now, components are what we use for these larger sections, and if none of a component is visible, the entire section won't be drawn. So you've really got to think about how you optimize these, because if you have a lot of components, then if I'm really close to the ground, as I look away, it's more likely to cull them out. For instance, if I was here, it wouldn't draw all of the information that was on this side of the screen. The second I look around, it would. If you look at a piece like this, even though I can only see the corner, it's still going to be rendering the 3D information off screen. But the second I can't see the component, we're good. Now, the problem is that if I was to zoom out, this would actually have more overhead because each of the components render separately, which means we're going to be adding more overhead if we're looking at a lot of the landscape at once. However, if we're going to be looking at it in small sections, you want to have more components. So it's a bit of a trade-off, and you need to understand this before you go into developing. And to be honest, it's one of those things that you're probably going to do a couple of times before you really get it right. Now, in this example, I could be setting this up to have 63 by 63 quads, and then the number of sections as 2 by 2. But then, if I wanted to, I could set the number of components to be 4 by 4. And you can see the divisor between the sections and the components, because you can see the different color of the lines. So this is the same size as before, however we have fewer overall components. Now for the time being, I'm just going to leave it on this because this is as good a place to start for the type of situation that we're going to be setting up. It's a reasonably small landscape, and because we're kind of looking down, I'm not too concerned about the overall loading. It should be okay. But I've created this, and now I'm going to reach over here and see that we have this button that says create. Pressing this is what switches it into an actual object. At the moment it's just like a potential landscape. Now it's worth noting that if all of these numbers confuse you, you can look at Epic's website and go through and view the documentation for the best suggestions of sizes and component ratios to kind of, get the most efficient use of space. So definitely check that out if you feel like you're in deep water here and you're not sure how to proceed. But for the meantime, just follow my lead and press create. So upon pressing create, it's going to create the actual landscape itself. Now don't be concerned about these black lines. These black lines are the result of us not having built lighting yet. If I was to view this in unlit mode, you can see that there are no black lines. They're purely temporary until we have lighting in place. Now, I actually don't want to go any further without doing that, so I'm just quickly going to go back into place mode. I'm going to type in light mass, and I'm going to add a light mass importance volume. I'm going to set its location to be 0, 0, 0, and now I'm just going to scale this up to be the size of the landscape. So I'm going to set this to be 60,000 by 60,000, and in terms of height, I'm going to set this for the time being to be 5,000 is probably not good enough. Let's go 10,000 just in case, and we might even turn this up a little bit more. And normally I would hit build, but it's going to take a little time for me to do so. So if you would like to, you can hit build and then continue on. It'll just get rid of these lines. But in the meantime, I've done this for future use, and I'm going to go to my landscape, and let's start looking at the sculpting tools. Now, to begin with, your sculpting tools, if you've ever used Photoshop, they essentially use most of the same hotkeys as Photoshop. So keep that in mind, as it makes life way easier. In this case, we have Sculpt, Circle, and Smooth are all set up as our tool is the Sculpt tool. Circle refers to the type of brush we have, and Smooth refers to the kind of fall off. So if I were to look at my landscape, I could test this tool out by holding down left click to just paint straight onto the landscape. And you can see that this is a great way for me to start setting up some external hills around my map. Now if I was to hold down shift left click, you can now see that it does the opposite, and I'm now carving holes into my map. So this is very, very useful because I can just carve out an entire arena and have everything looking great in no time. I can also use the square brackets on my keyboard, or I could use this to change the brush size. And this is great because I can set the size to be substantially larger to quickly paint more of the environment. Just be careful about going too large, because if you do so really quickly, it can kind of get out of hand without you realizing it. Sometimes you have more fun than you really should be for these kinds of things. So I'm going to paint this into the environment and just have a general setup, but let's start looking at some other tools that I could use to accompany this. In this situation, I'm going to go back to the Sculpt tool, and I'm going to try something else. Let's have a look at the Flatten tool. So when I use the Flatten tool, if I was to click here and drag across, wherever I clicked on initially, it's going to flatten the environment out to be at the same height as that. So I can use this to easily carve out sections, and it'll raise them up or lower them down, whichever is required. But I can use this to create easy plateaus or pathways, and that's fantastic. The other thing that I can do with this that I think is very important to note is that when I click here, you can see that it's flattening, but it has this kind of ramping off around where this fall off area is. So the outermost circle. If I was to click that, it doesn't just flatten that section down. However, if I was to go to here and set the brush fall off to 0, I would remove all of it. And if I looked at this, you'd now see that we have an incredibly sheer wall where that drops off. By the same token, if I went the other direction and had the fall off set to 1, it's now going to be smoothly kind of going in. This is more prevalent in other tools than just the Flatten tool. You can use it in all sorts of areas, but it is worth keeping in mind. So now that we've looked at the Flatten tool, let's cover the Ramp tool. This is one of those things that somehow no one seems to know exists, but it's kind of amazing. If I get the Ramp tool and I click here, and then I click up here, it'll draw out a ramp in space. Why is that great? Well, if I click Add Ramp, it'll automatically add in a flattened landscape between position A all the way up to position B. And I'm sure you can see why that would be useful in a lot of situations when you're crafting out an environment. Now, if I click, it's always going to go from where that base point was. However, if I want to, I can click Reset to clear the first point. So this is very, very useful. And while it is called Ramp, keep in mind that if I was to go to my Sculpt tool and I was to paint something from here and something to here, while it is called Ramp, there's no reason that I couldn't have a reasonably flat road going from A to B and add it that way. And again, there's the amount of fall off that you add. So if I undid the previous edition and I got the fall off and did it this way, you can now see that with basically no fall off, it's an incredibly smooth line straight up and straight down. However, if I went the other way and set it to 0, we would have shear walls on either side. So very useful ramp tool. No one seems to know about it, but now you do. So next up, we're going to look at some of the other tools that are quite useful. There's a time to use them and a time not to, and it's one of those things that you're really going to get a feel for as you work with them. Essentially, they simulate erosion. So they simulate what would happen over time to an environment. And if I just paint this in there, you can see that it's painting in these little changes, just this little bit of noise that's determined by where the current ramps are and everything else. If I go to something like this, which has a strong profile, and I erode it, you can see that it immediately starts smoothing out the sides, creating little lines of noise around them. And it's a good way to get something that looks a little more natural. However, it's very easy to carve into the world. That said, we can kind of mitigate that a bit by looking at how it's set up. If I get the noise, at the moment it's set to lower, but if I wanted to, I could set this to only raise. So it'll do the erosion, but it'll only do the erosion that lifts it up. It'll ignore anything that's lowering the environment. Alternatively, I could go to both, and I could paint in so that it both drops sections and raises sections. This is really going to depend on the kind of environment that you're after and how you want it to look, but it is a very useful tool for getting a much more natural look to your mountains and hills. Now the next thing that I'm going to go to is hydro erosion. Now this simulates what would happen if rain was to fall on these areas, and it works in a very similar way to the standard erosion, in that I can just kind of paint this in, and it's going to carve out around these dips. It's a bit hard to see right now. I'm just going to quickly go to my world outliner, which is over here, and I'm just going to set my light source to be movable for the time being, which will get rid of all of those lines and put it into a dynamic lighting environment. But you can see that by using the hydro erosion, it's created far more substantial dips. But again, I can change this to be either dipping and raising or just raising. There's no purely negative one for this one. So if I set this, we can have some other effects that can kind of kick in there. But I do recommend checking out the hydro erosion tool. I use it in moderation. So instead of holding it down like I was there, I find kind of like clicking a little bit and letting go and letting it kind of carve out that nice groove, and then moving on with regular erosion works reasonably nicely. If I go towards the bottom of any hill, it's always going to start creating these kind of effects over time. And you can change things like the amount of rain that it's simulating pouring onto the landscape and turn it down a bit, which can create a far, less aggressive effect. It's all up to you. Next up, we're going to be looking at some of the other tools. We're going to be focusing on how to copy and paste and how to mirror, as well as how to select regions. But we'll be doing them in the next tutorial. So the retopologize tool is incredibly useful, but it is one of those things that you aren't going to use that often. So while it is very useful, often you forget that it even exists, and therefore it just kind of slides by. Now it essentially works by remapping the UVs such that when I paint it on, it kind of handles the projection in a slightly nicer way. So it's really, really useful when you have really strong cliffs. You can go through and make sure that the texture correctly kind of adheres to them. So I'm going through here and I can just retopologize it so it does a nicer job of kind of splicing inverts onto it. But be aware that doing so adds overhead, and it's something that you probably therefore don't really want to do. So unless you have a strong cliff that is just quite messed up as far as the textures are concerned, I would typically stay away from it, but remember that it is there if you want it. Now if we go beyond the retopologize tool, we have the visibility tool, which I can't use right now because we haven't set up any visibility culling. So I'm going to skip past that, and instead I'm going to show you these region tools. So let's begin with the mirror tool. Now the mirror tool, the second you click on it, is going to give you this. And the reason that the mirror tool is fantastic is that you can set up where the mirror is in the map, and you can set up how you want it to actually work, like which axes and everything else. But what that means is that if I go to sculpt and I've got the mirror tool, I can now hit apply, and you'll see that we've just created a map that, if I was making a capture the flag map, for instance, would be perfectly mirrored. So see, the environment has just been flipped. So in this case, it's copying negative X to positive X. If I wanted to, though, I could copy this side over to here, and it would end up like that. Alternatively, if we wanted to, we could do some kind of interesting stuff. So you can do rotate -x to x, which gives you this. So that has been kind of rotated around to here instead of just mirrored. And these are all, fantastic for different kinds. And again, I can do this on the y-axis too. So I could drop this over here. But these are the kind of things that are very useful if you're doing team-based games and you need to ensure that both sides of your landscape are going to match. Now, apart from the mirror tool, there's a really, really useful copy-paste functionality kind of built in. If I get my copy-paste tool and I was to start selecting a region, what I'm able to actually do is grab something and then move it to anywhere else that I want to. Now to do this, you need to first use your selection tool. So I'm going to just use this to quickly paint in a selection. If I now hit Control C, you can see that it's done a selection and copied this area that I've just selected. It's automatically, upon hitting Control C, returned me to the copy paste tool. And if I want to, I can now actually copy the data to the gizmo. It's done. I now want to fit the gizmo to values in a selected region. So if I get this and I put this over here, I can now hit paste. So either Control V or I can click it over there. But you can see that it's now given me that as a tool. So if I hit Control Z, and I'm going to go back into editor mode, I had gameplay enabled. You can see that upon hitting Control C, it's done this. So I'll go through that one more time so you can see. I go to selection. I'm going to I'm going to select what it is. I'm just going to quickly do a shift select because I don't actually want any of that stuff there. Let's say that we wanted to copy this little mountainy hill here. We wanted to put another one of these elsewhere on the map. Control C automatically loads up the gizmo, at which point I can literally just grab it and drag it to wherever I want. So you can see that now that I've copied this in, if I wanted to, I can do some pretty cool stuff. Instead of going paste mode and setting this to both, if I hit raise, this will now only raise it up above the polys that are currently there. So in this case, it created a tiny bump unless I grab this and pull it up and then hit paste, at which point it would give me this. Again, the same thing could be done to lower. So if I wanted to, I could get this and drop it to here, hit paste, and it's only going to drop in the dips. It won't add any of the raised height. This is going to be more obvious if I was to get this and move this over to here, which is a flatter, expansive land. I've got this, I'm going to pull it down to about there. Now you can see that there's meant to be a hill, but upon pasting it, there's no hill, there's only the dips that were around the hill. So again, really useful. If you create a cool mountain that you feel like you could rotate in 12 different ways, it's a great way to start. Now, with the copy and paste tool covered, it's time for us to start looking at some of the other tools that we have. And that means that we've actually got to go into the paint section and start looking at how we can set up materials that actually work for us. So we don't want to just focus on the simple painting tools, we really want to get into the more interesting and complicated stuff. That said, we're going to start with the most basic environment that we can, and we'll work up from there. So the next lesson is going to be an introduction to landscape painting. So it's time for us to look at painting landscapes. Now this is a really interesting feature that they've added in that they have both weighted and non-weighted painting. Now I'm going to show you how these work. First off, I'm going to bring my content browser back down this way, and I'm going to, in content, I'm going to create a new folder that's going to be called landscape assets. I'm just isolating these a bit to make my life a little bit easier when I want to handle everything. So I'm going to right click and I'm going to add a material, and this is going to be called m_simple landscape. Now we're not going to be running with this in the end, however we will be using this for quick testing to begin with. Before I go any further as well though, I do want to clear the region selection that was there because that was just driving me nuts. So click on that button up top and you'll be good. At which point what I'm going to do is double click on simple landscape, and I want you to just add two things for me. First, what we're going to do is I want to right click and type in landscape, and you'll see that we have a couple of landscape specific options. Now in this case, the one that I want to add is going to be a landscape layer blend. And I want you to add and call it grass, and add another and call it dirt. Now this isn't going to be our final product, so I don't care about how intense the setup is. It's purely there for the sake of demonstrating things. Now, if I get grass and I add a vector, so I'm going to hold down V and left click, and then I'm going to set this color to be something vaguely green for demonstration, and I plug this in. I'm now going to add another one, so I hit Control W, I'm going to call this dirt, and I'm going to click here and set this to something vaguely brownish, and plug that in. Now, you can preview how this would look if my preview weight was set to 1. You can see that it would be green. Now I'm going to hit apply and save. Now the reason I bring this up as a very important feature as the difference between landscape types is that when I go back to here and I go to my landscape, I'm going to go to over here, I'm going to set the material for the landscape. Okay, so I'm going to set this up to be using the material that we've just created. Now by default, this is going to be selecting the landscape gizmo. Honestly, I find it easier sometimes to just ignore the management setup for a little bit and just click on the landscape up top. But you can see that once I did click it, we've got all of our options available. And I'm going to set this to be simple landscape. Now, upon doing so, you'll see that the two layers that we created, grass and dirt, are both exposed. And what I'm going to need to do is I'm going to need to add some layer info for both of them. So to do that, all you need to do is click on Create Layer Info, and for the time being, we're going to add Weight Blended Layer, because that's what I wanted to demonstrate to everyone. I'm going to put this in Landscape Assets, and I'm going to do this again, Weight Blended, and put it in Landscape Assets. So we've got these two things set up. Now, if you right-click on Grass and click Fill Layer, and then wait a second, you'll see that it's now covered the landscape in green. And if I wanted to, I could click on Dirt, and I could paint in. First time you ever add anything to a component, by the way, it's going to do what you just saw. It's going to have to rebuild the material if that combination's never been used. And I'm going to paint this straight in. Now this looks fine and dandy, right? But what you'll notice is happening is that when I paint in dirt, it removes the grass. So eventually it fades from green to brown and is then exclusively brown. Now the difference between weighted landscape layers and non-weighted is that if you use non-weighted layers, you can actually paint onto each layer if you set up a way for them to blend, which we do with height maps. So what do I mean by that? I mean that if we had, for instance, a rock layer and a grass layer, as the grass layer blended into the rock layer, we could fill in the cracks on the rock and add grass in between the cracks on the rock until it became all rock. Or we could keep it as a mix between both. And that's where the real power comes from, in my opinion, of the advanced landscape systems that you can set up. So let's go about doing that. So for this next presentation, we're going to be focusing on advanced landscapes. We're moving on to advanced landscapes now, but this is going to take us some time because we're going to need to create two material layers first and then the landscape material. We're going to try and do this in conjunction with having an actual landscape, but it is still going to have a little bit of crossover between making the layers and making the landscape material. So let's begin. I'm actually going to get this and nuke everything that I've done. So we're going to go File, New, and I'm going to use a default map again. I'm just going to delete this and go back to adding a landscape, and once again I'm going to have the settings that I had before with 2x2 and 4x4 for the components. So add that and create. I'm also once again going to set my light source to mobile just for the sake of not having the lines on screen, and just very quickly I'm going to paint in a bit of some hills, purely so I can actually have something to really look at and understand how it's all set up, so that as I'm doing my landscape I can see how it looks on the assets itself. So just very quickly, I'm just going to add some sculpting in. Now that'll do for the time being, and let's have one larger mountainy area over here that's in the distance. Oh, too much. Cool, that'll do, I don't mind too much. So I've got some flat areas to check it, some noisy areas to check it, and a big area to check it. Now, I'm going to delete these landscape layer infos that we had already created. And I'm going to keep simple landscape material just as a memory of all that could have been. And I'm going to go m_landscape_01. So this is going to be my landscape material. Now, how this is going to work is we're going to create a landscape that is going to have two sub-materials within it. So what I mean by that is it's going to have a grass layer and a dirt layer that are going to actually be made up from their own material layers. And I'll show you how this works. If you right click next to all of this and we go to materials, we can create a material function. And I want you to call this ml_grass. So upon double clicking, it's going to look like the material editor because it essentially is, but there is a big difference. You'll notice that I'm no longer outputting to a standard material. Instead, I'm just outputting to a result. And this is essentially a way for me to create my very own material nodes, which is pretty cool. So what I'm going to do is I'm going to create a dirt layer to begin with. So to do this, I'm going to hold down T and I'm going to left click. And this in the texture is going to be set to the dirt texture that came in the Infinity Grasslands pack. So T_dirt. So there you can see we have a basic dirt texture. Next up, I'm going to hold down T, and this time around what I'm going to do is plug it into the normal for the dirt. Now if I wanted to plug in the diffuse and the normal into the result, I couldn't, because right now I don't have the standard color and roughness and normal and all of those inputs that I would usually have. Instead I just have a single thing. But that's okay, because what we can do is we can drag off of this and type in set material, and you'll see that we have set material attributes. Now this looks like it has a single input, but this is where this is quite cool. If I go over to here and add an element, what I'm actually able to do is add pins that create a material. So I'm going to add a base color, I'm going to add a roughness, I'm going to add a normal. So you can now see that we have 3 pins that would act as if they were one large make material attributes node. So if I plug this into base color, you can see now that it's applying it as if it was the base color on a standard material. Next up, I'm going to plug this into normal, and you can now see that we've got that happening too. However, we do have a bit of an issue with our dirt, and that is that we need to be able to set the roughness on it. At the moment there's no value being set, and yeah, I could just plug a number into it, but you know, that's not really where we want to end up on. What I ideally want to have is a roughness that is less, that is more rough around the dirt and a little less rough around where these rocks are, so we can get a little bit more of a shine on them. So how do we do that? Here's how. If I was to get the information coming out of the color data here, and I was to just grab a single channel of it, say the green channel. So if I got this, and I was to then look at it, I'm going to multiply it by a value of 1, which means it'll be just the channel. I'm going to start previewing that node. This is what I can see. You'll see that the rocks are highlighted as a grayer color than the dirt, which is a darker color. Now what we can do here is quite cool. We can get this and we can multiply it by, say, 3, just as an example. And in doing so, the brights got brighter, and yes, the darks did too, but if we use this in conjunction with a clamp and what's called a power node, we can create some very interesting effects from just pulling data out of the color data that's here. What I mean by that is, so at the moment, if a value was equal to 1 on the green channel, it would now be equal to 3, because I've multiplied it by 3. However, if I clamp this, if a value was equal to 3, it's now only equal to 1, because it doesn't let the value go above the max or below the minimum. Now why did I do this? I did this because I'm now going to use what's called a power node, and these are really useful nodes, because what they essentially do is they get the data coming in, and for each pixel they do a power of function on them. And what that means is, if you think about how this works, 1 to the power of 2 is equal to 1. However, 0.5 to the power of 2 is equal to 0.25, which means the lower a number is, when I power it, it's going to actually approach darker, while the lighter values are going to stay within a lighter range. So if I preview this, you can now see that by doing a power of, the rocks have stayed reasonably white. However, the dirt itself has gotten much darker. So this allows us to then create a blend between the dirt, and the rocks that sets up the two roughness values that we would want to have here. So all I need to do that is add a linear interpolate, which allows us to blend between two values using an alpha value. So if I plug this in, at the moment it's blending between 0 and 1, so it's going to be exactly what we just saw. However, if this was to blend so that the dark dirt was equal to a value of 0.95, and the rock, on the other hand, was equal to a value of 0.5, you can see now that the rocks are going to be significantly smoother and the dirt's going to be quite rough. So if I plug this into my roughness value and I go to previewing the output result again, you can now see that we have a much rougher rock surface, but the rocks themselves, a much rougher dirt surface, but the rocks themselves can have a little bit of a shine. And if I go back to this lerp, I can actually change those values around. If I set that to 0, for instance, it's a bit more apparent. You can see that those rocks are they're getting that quite a shine as the light hits them directly. You can see it mostly on this one. But for the time being, I really am thinking that a value of about 0.4 is probably going to be fine. And that's going to be a good base for us to create a dirt material. Now, this is the initial setup that we have for one dirt layer, but there's a bit of a problem that we have, and I'm going to show you what that is. If I was to get this material that we've just created, which I called ML grass and I just realized was meant to be ML dirt, that's okay. Let's just rename this. I'm going to go to ML grass and I'm going to rename this using F2 to ML dirt. If I go into my landscape and I add the dirt layer, so to do that I can go here and then just get the dirt and drag it into it. You can now see that dirt is outputting a result. Now I can't plug this in at the moment. However, if I go to this node within the properties that says use material attributes, this allows me to plug it straight in and create the dirt material plugged into here. Now this is going to have a couple of big issues when we first set it up, and I'll show you what those are. So I've got my advanced landscape. I'm going to drop it onto here. I forgot, sorry, you can't drag and drop. I'm going to click here and I'm going to set the landscape material to be my landscape. Now, this is going to be applied to here. Now, I'm sure you can see the first issue that we've got. The tiling is incredible, but also if I was to stand here, you can see this repeating pattern going all across the landscape. So, how do we fix that? I'll show you that in the next session. So this was creating the basics of material functions, or in this case material layers, but next up we're going to look at how we handle landscape blending and material layer blending over a distance.